Okay, good morning, everyone. Welcome to AWS Community Sri Lanka 2022 Virtual Edition. So we are so excited to have everyone today for the third time in a row, and it's all thanks to AWS enthusiasts and evangelists, both inside and out of Sri Lanka. We are so excited you're here, and we have a full day full of great session planned out and many opportunities for you guys to learn as well as win exciting gifts. So before we get started, I thought we'll go through a bit of an introduction. So let me share some slides. Yeah, I can see a lot of people are joining through. Hi everyone. Maybe just as a fun thing, when you guys join in, you could maybe just say where you guys are joining from, just to keep things rolling. Good morning, guys. We can see a lot of people joining. Great to have you guys here. So, first things first, let's go through the agenda for today. So we have quite a long day planned, and we have a lot of exciting events ready as well. So whenever you guys, if you guys want to tweet about this or share even throughout any social media platform, so do use this hashtag Community Day SL 2022. That'll help us out a lot. But yeah, so yeah, I can see Jones is here. Supun, hi guys. Kokila, good morning, guys. Look, hi. So yeah, let's get started then. I'll share the screen for our agenda. So let me add that to the screen. Yeah. So here, this is our website, main website. So I'll just go through each of these sessions. So first things first, this is the introduction. So that's what I'm doing right now. So I just wanted to go through what we are doing today, what to expect today, basically. And so the first session after that would be the keynote speech by Derek Bingham. So Derek is a developer advocate at AWS, and he's a dear friend of the user group. He has helped us out many times. He has done many sessions with us. So it's great to have him as our keynote speaker, and yeah, it's truly an honor that he's joining us all the way, from Australia. So after Derek, we have Alex Debris session, which is understanding DynamoDB for fun and profit. So this is a deep dive, a little bit of a deep dive, but then you get insights about DynamoDB and its foundational concepts, its underlying architecture, and how you can do mission critical applications with DynamoDB. So it'll start off a little, you'll get to know a bit more about how DynamoDB works internally. And Alex is a really great person to do that because he's a data hero. So he's the best person to do this. So after Alex session, we will be having our first quiz. So our first quiz will be done by our quiz master, Chamira. We will introduce him later on, but he will be doing all the quizzes for today. And yeah, so the first quiz will happen at 10:45, just after Alex's session. So keep an eye out for that. And just notice here. So I think if you guys registered through Confab, we are showing the link in the ticker as well. And I think we had a comment posted earlier as well. So you guys can go and register for the quiz so that you can easily start when the quiz time comes. But we will again repeat this later on as well. But if you guys can register now itself, that would be great. Yeah, moving on. After that, we will have Lakindu session. Lakindu is also a fellow community builder, and he has also been helping with this event a lot. But we are excited to have his session as well. So he's going to talk about scalable and loosely coupled backends with AWS serverless. So excited to have him on board. I'm sure you guys will learn a lot from his session. And he's actually one of the youngest community builders in Sri Lanka. So we are proud to have him here as well. So after that, we will be having a little bit of a lunch break, and then we'll take a small break there, and immediately after that we'll have Lahiru session. Lahiru will dive deep into zero trust on AWS. So he's going to talk a little bit about security and discuss how traditional security models is ineffective and how we can leverage AWS services to bring that trust journey. So Lahiru is also a fellow community builder, and yeah, we are excited to have him on board as well. So after Lahiru's session, we will be having a second quiz, which will be again done by Chamira. So again, that will be at 1 p.m. So keep an eye out for that as well. So the first quiz is at 10:45, and the second quiz is at 1 p.m. Both times Chamira will come on board, and he will take you guys through the quiz process. Right. So after that, we have Geetika's session, and this is a serverless architecture: the good, the bad, and the ugly. So Geetika is again a Sri Lankan speaker, but he's I think the first time he's coming out for us, so we are excited to have him on board. His session is on serverless applications and how it can be, how we can make it faster and cheaper. So yeah, let's hope you guys can learn a lot there as well. After that, we have Arshad Zakarias, one of the Zach's sessions. So he's going to do a session on secure network using AWS Network Firewall. And Zach has helped us back in the day as well with quite a lot of sessions. So happy to have him back as well. Same goes with Yankui. Yankui has been supporting us from day one. So happy to have him for the following session where he's going to talk about choosing the right messaging service for your workload. So he's diving deep into SNS, SQS, Kinesis. So these kind of sessions kind of tie in with the other sessions we are doing as well. So it kind of builds on top of the other session. So it's great. It's a great learning experience for anyone who's joining us today. Yeah. So after Yankui's session at 2:45 to 3:30, we have Sanchit Dilip's session. Sanchit has also done a session in a user group previously. And he's also a hero now, so great to have him on board. He's going to do a session on data lakes, and he's going to talk about scaling data in petabyte scale using AWS data lakes and lake formation. So that's going to be great. And finally, we have our new hero and the other Zach, which is Jones Zakaria. So he will be talking about Lambda and serverless workloads and how infrastructure as code can help minimize this application logic. So his event is also something to look forward to. We are happy to have him on board as well. So yeah, that's all the main sessions. And after that also, we'll have a final quiz at 4:15. That is before Jones' session also, we will have a final quiz at 4:15. This will again, Shamira will come on board and walk you guys through the process. So the 3 quizzes will happen at 10:45 and then at 1 p.m. and then finally at 4:15 p.m. So keep an eye out for those. And yeah, after that, we'll do a small wrapping up with a thank you note. And yeah, we'll end the session. That's what we have planned for today. So we have a lot of sessions and these are all interesting. The speakers are very interesting. So we hope you guys learn a lot today. And if you, so let me quickly jump back into the slides. So if you stick through and if you do all these quizzes, we have a lot of exciting gifts. This is just a sneak peek of what we have on what we have planned. So each quiz winner will get a prize. So if you win quiz 1, you get a prize. If you win quiz 2, you get a prize. So there are prizes for each quiz. And then an overall quiz winner is also decided. So if you did good in all 3 quizzes, and if you kind of even didn't do good in the second quiz and you did better in the third one, you can still catch up and win that overall prize. So that is something we are doing this time around. So we hope you guys can have fun while doing these quizzes. And yeah, we are excited to send these gifts out as well. Great. So I think a lot more people have joined now. So hi, good morning, guys. I was just going through some of the what the agenda is for today and when we have the quizzes and stuff. So If you haven't already, get registered for the quiz. The link is shown in the chat as well as it's going in the ticker in the stream. So do join in for that. We have a lot of gifts and exciting things planned. Okay, so just before we get started with the sessions, we just wanted to do a small recap of what we have done so far. So as a AWS community and as a AWS user group Colombo, what we have done, we started off in September 2019, and we have been doing these community days and a lot of meetups for 3 years now. So we are still relatively new, but we have learned a lot in these three years, I would say, and our community has definitely grown a lot. So far we have done 2 community days. So the first one we did it on 2020, and last year we collaborated with all the South Asian user groups, India, Bangladesh, Nepal, and we did the South Asian community day. But this time around we are kind of doing it. Only our core team is working on this, so it's kind of personal this time around. So it's we are excited, really excited to do this for the 3rd time in a row. And yeah, so we have done 32 meetups so far, and we have had more than 50 plus speakers, and we have more than 2,200 members right now in our meetup page. So that's great, and we get a lot of returning viewers in our sessions as well. So it's always happy to see those guys. And right now we have around 34 community builders in Sri Lanka. So in 2019, or when the program started, we only had few, and now the numbers are growing. So we'd like to think we had a little bit of effect on that as well. And we have one AWS hero, that's Manoj Fernando. So in these 3 years, I feel like we've grown a lot. And so the main reason we started these user groups just to increase the AWS exposure to and get more people excited about AWS, right? So in the first year, we did have a lot of physical meetups, but due to the pandemic and economic crisis, we had to kind of switch online. So in these 3 years, we have learned like a lot of people are quite interested. We have a lot of, as I said, a lot of people who are joining back again and again. And we see that hands-on sessions are getting more traction. Like people want to learn more and people want to do things that they can work with. So it was a great learning experience. And even though there were a lot of thick and thins, like a lot of obstacles, we still saw people coming through to our sessions and supporting us. So it's a huge heartfelt thank you to everyone who supported us and who still continue to, because we wouldn't be able to do it without you guys. No matter what it was, even during the power cuts, we still saw people coming through and attending our session. So that was really even surprising for us. Even at times where we thought a lot of people might not join, you guys showed up. So that was really great. So thank you so much again, guys, for always supporting us, and keep continuing to support us. We are trying our best to deliver the best we can to you guys and bring the most relevant content to you guys. So what we are planning to do going forward is to again try to go back to these physical meetups, because I think those are good for the community and to network going forward, because then physically if we meet up, we get to see a lot of faces, and it'll be more fun that way. So we'll try to do that now that things are a little easing up. So we'll try to do physical meetups soon as well, but we'll keep you guys posted. So yeah, so that's a quick intro. So just before we get started, I thought we'll show our team as well. So this is our team: Manoj, myself, Keshav, Shamira, Trehana, Lakindu, and Lahiru. So just as a fun thing, these guys are all here in our backstage. So I'm going to add all of them. So we'll just show.
Hey guys. Hi
Hi,
guys.
hi, hi. Yeah. So this is the team. We've been working quite hard for a few months now to get this event out. So we are really proud of this, and we are really excited to get things started. Yeah. So thank you guys, and thank you everyone for joining. So yeah, I'm going to remove you guys now. See you guys. Yeah. These guys will be online the entire day, so you can reach out to them if there's anything. But yeah, finally, so if you guys want to get involved and if you guys want to contribute to the community, we have this meetup page, AWS User Group Colombo. And there are the Facebook and LinkedIn and Twitter, everything is linked inside the page. So you can just go up here. You can join us. We are always looking out for new sessions, new speakers. So if you guys want to speak in any of these sessions, also do reach out to any one of us that you just saw. We are all happy to help you guys out. We are all happy to facilitate that. Okay, then. So that's about it, though. That's the mandatory introduction that I had to do. So I'm not going to bore you guys anymore. So let's get started. We have Derek waiting very eagerly to do the session. So yeah, so that's going to be our first session keynote. So it's going to be done by Derek Bingham. Derek is a developer advocate, and he is joining us. He's the developer advocate for the ANZ region. He's a focused and engaging individual, and he has done a lot of cloud native architecture and front end mobile development. So he's right now currently enjoying agile development, but yeah, he has done sessions for us in the past as well. He has given us so much support, and he's always fun to talk to. So without further ado, I'm gonna bring Derek on, and let's start with the keynote, and hope everyone has a great day today. Thank you again for everyone for joining, and thank you, Derek. I'm just gonna hand it over to you. Take it away.
Thanks, Kshev. Thanks for having me.
Yeah, thank you, Derek. Yeah.
Yes, and what a lovely introduction as well. So thank you very much. I'm very excited about today. I was just listening to you do the lineup, and I was like, "Oh, you got Jones on, fantastic!" And Alex, this is going to be a great day. So that's very exciting, and yeah, looking forward to kicking things off.
Awesome, Derek. Yeah.
So if you put my deck up, I'll start talking. And that'll be the easiest way to start. So welcome everybody. As Kshev just said, I am Derek, developer advocate at AWS for Australia and New Zealand. I've been at AWS now for about 5 years, and I've seen a lot of changes in that time. I've seen a lot of new services, that's for sure. And I'm actually just came back from reInvent. So I landed getting back from reInvent last night. And so I was very, very happy and very humbled to be invited to come and give this talk. So this talk is not going to be about reInvent and the launches from reInvent. I'm going to do a different sort of talk this time because I think this is a special event. However, if you were listening to the announcements at reInvent last week, there's two that probably stood out for me. The two that you should probably check out is Lambda Snapstart, which reduces the cold start times for Lambdas if you're running in Java, and also Code Catalyst, which is an interesting set of tools for building software. So obviously they're right up my alley. So I just thought I'd mention those before I get started. So let's get into this talk for today. So as I said before, it's absolutely my pleasure and privilege to give this keynote at the 2022 Sri Lankan Community Day. But I'm going to talk about communities themselves because tech communities in particular have been so important to me, both personally and throughout my career, because I'm incredibly passionate about the value that they bring and why we should all support them. So before I explain why we should all support them, I'm going to tell you a bit of my personal history with tech communities. So I actually am not originally from Australia. I actually grew up in Ireland, but always wanted to travel the world. So when I left university, I got a job as a web developer in London during the initial .com boom. So that's telling you how old I am. That was in 2000. And after working a few years in London, I decided to move to somewhere a bit warmer and better weather.
Experience 24 hours of head-to-head.
So that's a technical glitch, and this happens when you're doing live. a few years, I moved into Australia, and I worked on when I was in London some really cool stuff, like the first ever MMS messages for mobile phones, and the first ever voice recognition software for mobile phones. So that was really cool, and I interacted a lot with the people I work with, but never never interacted with people outside of my own work environment. So over time, I've learned that that's a big mistake. So when you are working in a particular organization in a particular industry, it's always good to get outside and mingle and learn things from others in a community that you don't necessarily work with. And that's the mistake that I made when I first started, because what happened is I moved to Australia. In fact, I moved to Perth and I couldn't get a job. So I was this new software developer, had about 5 years experience, and I came to Perth and nobody knew me. I didn't have a job. I couldn't get a job. And so what I started to do, I started to connect with communities. So I started to go to community meetups, so the Java meetup, .NET meetup. And then I eventually found what is a lovely community in Perth called DDD, which is the largest tech conference in Perth. And that was absolutely amazing because it opened up a whole new world to me. And as you can see here, I'm as we've seen before this talk started, we've seen all the people in the background who made today happen. I was that background person, the volunteer, and I absolutely loved it. So here are some pics of me in the background helping out with the community. I've got me in the pink shirt as a DDD helper, volunteering and making sure that all our sponsors for the conference are good. And this was before I joined AWS. We got pictures of me in the background of another conference, just making sure that the presentation's working okay. And then there's me again on the right-hand side in the background of an ANZ Summit for AWS. Again, always in the background, always helping to make sure that community is front and center. So I made so many great connections as I joined the communities. I learned from so many awesome speakers, and I wouldn't be where I am today without the awesome communities in Perth, Western Australia. And that's why I'm still here 20 years later. So as well as those communities, I've been to several AWS user groups and summits before joining AWS itself. And from what I could tell, AWS user groups did a really great job of talking to their fans. So people who already knew AWS, but were not very good at talking to people who were not familiar with about AWS. So as someone who was new to the community, I didn't always feel, because I didn't know AWS, I didn't feel welcome. And then I noticed some of the user group leaders seem to be selling their own consulting services more than serving the actual users that were going to the groups. So a number of AWS user groups, it seemed like a sales pitch to me, and I didn't resonate, didn't like that much. And I noticed that AWS also didn't seem to sponsor many of the other community events, and I didn't often see speakers outside of their own events. So you would always see AWS speakers in summits, but you'd never see them in community or user groups or other events, which was really strange to me when I first started. So then when I joined AWS, I wanted to change that. I learned that there were others as well inside AWS who'd seen the same that I had, and they wanted to change the way that we're actually engaging with the local developer groups and communities. And that's really how I became a developer advocate. So by starting to recommend external speakers who I'd come across while I was in the community and trying to find opportunities to support that wider community, like events like DDD, which is a community I was very, very involved with. And now I've been in AWS for 4 or 5 years now, and it's so much different than when I started, because AWS has kickstarted a transformation on how we engage with builder communities. And a big part of that is down to Felipe, who is our head of developer relations for AWS. So this year, we had an internal event in Seattle, where Felipe laid out his vision to us, the developer advocates at AWS. And he said that we are on a multi-year journey to transform AWS into the best ally and best place for builders to build on. So I want to unpack a few of those words while I can. So note the word transform here, not just how we engage with developers, but also helping others in the company to do the same. Also multi-year. So we are a large company, so it's going to be a tall order. So we're going to look for years in the future. And also allies. We want to empower people, help developers be more successful, understand technology better, do things faster, maybe get a promotion, maybe help their company save a few dollars along the way. Or if we can do that at scale, we can have a deep transformation impact in whole countries around the world, lifting economies, helping companies grow, and helping thousands of people take advantage of the cloud and its opportunities. So that's Felipe and our vision, and we're on that journey now. And I wanted to share with you how we're actually going to do that in today's talk, and how are we going to engage with the wider development community to do that. So we know that the AWS Builder community, which Sri Lankan community group is very much a part of, is a very key part of doing that. So we care about these communities because builders are participating in communities to share their learnings, like I did when I first came to Perth. I needed to join a community, share some learnings and learn new stuff, ask questions and experiences from each other, and feel a sense of belonging. So members of our communities are our most passionate fans. So we realize that as AWS. So we want to support that and reward that. And thank you for everything you've done to keep your community growing, especially within the last 2 years, where it's been a real struggle to keep those communities going, given the situation that the world has found itself in. And also, communities also help us scale. So a really nice way of doing that. But we definitely do not see our communities as a marketing channel. We want to earn your trust, and we just don't want to be you to be an amplifier of sales messages. We want to learn from you how we can improve our services, yes, but we're not here to sell. And we don't want to be complicit, and certainly not take you for granted. So the last 2 years have been very hard. So we've all had to pivot very quickly and learn how to do our jobs during what has been a pandemic. Sometimes it may be extra volunteer work, like running a community or writing blog posts in your free time. Just didn't feel like a priority as things when the world has changed. And I completely get that. My priorities changed as well. But we saw so many experiments where people tried to replace the in-person experience with something that was a bit virtual. So we saw 8-bit worlds. So we saw little 8-bit figures running around worlds as part of a community day. We also saw virtual conferences, complete with bathrooms, because we all know that conferences need bathrooms. And we've been blown away by the creativity and resourcefulness that everyone's shown, and specifically in the APJ community. Because as a developer relations person, I look after Australia and New Zealand, but my team is the APJ developer relations team. And we've really seen some awesome things in the APJ region. And I'm going to show you some of those highlights. Well, I think are highlights now, and some of them might look familiar. So this is the highlight. I'm doing this first because this is the ANZ Community Day, and this is something that we put together last year when COVID started to hit. So we had it was 2 years ago. We had a week-long event where we got the AWS heroes, and we have in Australia. We're lucky. We're so privileged to have 10 heroes in Australia and New Zealand, and we had 2 of them to host each day. So we got the heroes to host each day in their area of expertise. And again, this is the behind-the-scenes shot. So earlier I said before I joined AWS, I very much work behind the scenes. Well, now I also work behind the scenes and bring this sort of community experience. So I help produce this across those 5 days. So once again, I'm in the background, and there's definitely a theme there. I don't want to be in the foreground, and this is quite rare for me to be talking in the foreground. Now I know, and a very similar experience happened here in Sri Lanka, and this is the third, I believe, in a row where you've had an online community day, and it's a lot of work because, as you see in the previous slide, I've done it, and I really have a enormous respect for everybody who is putting this together today because of the work involved. So here we have Sri Lanka Community Day 2020. I've got Manoj, the Sri Lankan hero, up in the top right doing the introduction. So it shows how important community days have been here in Sri Lanka as well. So this is a video that we're going to play now. I think we can play the video.
2, 1, hit it. Experience 4, 3, 2, 1, hit it. Experience 24 hours of head-to-head AWS sessions from around the world. Mic check, 1, 2. Jaws Pankrishon 2021. Up till down.
Boom. So this was Jaws prank creation. So this is the Japan AWS community put this together, and it was a good example of how they embraced what it went on and pulled in a 24-hour global event. So we had attendees from 22 countries and speakers from 13 countries, and the community in Japan built that all on their own, which was absolutely fantastic. So then, if I can, this is typical of an online live event. Things can happen. So then, in 2021, I've got another example. So this is Rafael Jambalos or Jambi, who's the AWS user group leader for the Philippines. He launched a dedicated AWS ASEAN community dev.to blog. So it wasn't an event. It wasn't a live show. It was actually a blog platform to centralize all the content that was made by the passionate developers across ASEAN. So the last time I looked at it, it had over 90 posts and 120,000 views. So that is awesome, and a fantastic way that the community in Jambi has brought the community together to write blogs and content. And then so that's when the pandemic started. But thankfully this year we're starting to move cautiously, and an introduction. We talked about in person again, but we had to get to in person again. We have to cautiously start getting together to make that happen. So here are some examples of how that's happened. So the next video that we're going to play, can we play that? Absolutely love that tune. So that is in May, the AWS Korea user group hosted a summit watch party. So what they did, they rented out a movie theater, and they joined by 82 leaders. And as you say, so they got some interesting speakers there. They had Jeff Barr and 4 AWS heroes. So this was the AWS Korea's user group's first post-pandemic meetup and its 10th birthday party. So that worked out really well, and they made a really nice video about it as well, as you just saw. So I thought I'd share that with you all. So now, what we're doing now is we slowly move away from all the virtual. Some communities are embracing hybrid. So here's a good example of one of those communities. And this is the Indonesian community who just a few months back in Jakarta had a hybrid community day. And their hybrid event was 150 people in person and more than 1,000 people watching across 4 different streaming channels. So they experimented and brought that to their folks in the community. So there's some great examples, and I hope you enjoyed some of those. So what next? How can we support as AWS communities for what the future holds? So the next slides, I'm going to go through what exactly that will look like. So what we've done as AWS, created tenets to use to make sure we are heading in the right direction. And these are the tenets I'm going to share with you today. Our first tenet is to scale to millions. So we'll build programs that operate globally and are relevant to many different builder personas. So I've mentioned developer a lot, but that's only one type of builder persona. You could be a data engineer, data scientist. You're building things on the platform, so that makes you a builder. The second one is be authentic. So we're going to bring a language, tone, and personality that's relatable and approachable to builders. So as peers, we are your peers and we're speaking the same language. So we avoid, as I said earlier, corporate or any marketing type messaging, because it doesn't need to happen. We create interconnected journeys. So what I'm saying here is we build programs aligning to the overarching and interconnected customer journeys. So we do not support or launch new community initiatives that operate in a vacuum and confuse everybody in the long run. So we want to try and avoid that. Next, we wanted to support. I haven't had much sleep. We want to support sustainable growth. So we aim to enable growth that becomes organic and sustainable without AWS's ownership. This is very important. So we as AWS want to help and incubate and empower people, but user communities. But ultimately, we want those communities to be self-sustaining, which would be absolutely fantastic. We want to recognize and incentivize. So acknowledge and award outstanding community leadership while providing benefits and resources to empower and incentivize further advocacy from community influencers. Next, we want to trust the community. So community leaders know best what works in the community. So we trust their relationship and leadership to provide relevant support of what is important to them. So we never tell community leaders what to do, and we do ask them to align to our internal goals, which is absolutely 100% important because, as I said, you know exactly what you want from your community, so we will help you do that. And then finally, foster peer-to-peer interaction. So as I've noted a few times during this talk, communities is all about the interactions you're having with your peers, between builders focused on problem solving or career development, sharing best practices and networking. So we don't want to focus on introducing employee-led or product-led messaging into these communities. We want them to be exactly the way they are. So the driving force is you. It's not us as AWS. We're here to help, but the driving force is ultimately you and your passion that comes along with it. So that's the tenets, but what about in practicality? What programs have we got to help that? So here's the final video for today about one of the most rewarding programs.
Hi.
Hello builder and future builder.
I am
AWS
community builder.
AWS
Community builder.
builder.
Hi.
Hello. Assalamualaikum.
Hi guys.
Hello builder and future builder.
I am
AWS
Community builder.
AWS
Community builder.
builder.
I am a community builder.
I'm from
Lanka,
Germany,
Pakistan,
Japan,
Tanzania,
Australia,
India,
Belgium.
worldwide.
What does it mean to be an AWS community builder?
community, passion.
It's an opportunity like no other.
You're part of a global network of people learning AWS technologies together.
It's a group of buzzing and energetic people.
I am able to interact with various community builders from all over the world.
You have the opportunity to meet like minds, to learn from the best,
To bring innovative ideas.
To continuously further my knowledge of AWS.
Grow professionally in your career.
And learn from each other.
You get to learn from industry experts.
And share my knowledge.
AWS tools and resources, the credits, mentorship and networking opportunities as well.
This program is for everyone, from student to intermediate to expert.
Being a teacher at heart, I love writing and using my gifts and talents to share and help educate people on AWS. So I have the permission to be as creative as possible.
It's a form of recognition for my work, recognition for my creation, and AWS encouraged me to create more and more.
And what I like about the community is its unbound potential for growth.
It's a great network opportunity with fellow builders that love what they do.
I'm really passionate about helping and creating an impact in my community.
Awesome, passionate, like-minded people.
You have the opportunity to upskill yourself.
You have meetups, you've got events, you have a wealth and a plethora of different people from different walks of life.
Together, we can do so much. It's been an amazing, priceless experience.
And you can find powerful tools to improve the world in so many ways.
That's what I love about AWS community.
This is a really great opportunity. It feels great that my learnings help others in the community with their AWS journey.
I do love and always recommend AWS Community Builder programs.
I am super excited that I got accepted into this program.
We're waiting for you.
You can get awesome swags like this jacket.
It's about you being you. So go ahead, apply.
Just do it.
Let's build.
So that is the AWS Community Builder program. If you haven't heard about it and you're not excited by it, you should be. You can go to the Community Builders website. So Google AWS Community Builders and go in and you can put yourself on the wait list. So what we're looking for is passionate, community-minded people who really would like to get involved in the Community Builders program. And it's quite funny. I've seen that video a few times. And I realized that Sri Lanka is the first person on it. And also, a lot of people I met last week at reInvent that I hadn't met before, and some of them are on that video, which is quite funny. So this program's been around since 2020, and it's very popular. So we've got thousands of builders are now on that program, but it's a great way to begin your journey to becoming, say, an AWS hero like Manoj. And in fact, one of the great perks is getting to not only swag. So somebody mentioned swag in the video, but also you get credits. You can connect to AWS heroes, and you also connect into service teams. So that's when I was saying earlier that we want to get feedback on services and we want to get it from the community. So the AWS Community Builder program is the easiest way to do that. So check it out. To get on it, you need to demonstrate that you've posted about AWS, you know a bit about AWS, and good luck with your application. So as well as helping communities, we help them support each other by connecting communities from different regions in APJ, not only single countries or a group of countries like ASEAN, but across the entire APJ region. And this year we had there's an example here of how Young Lang is working with other community builders and heroes across the region of APJ. But also this year we had a community summit. I know Manoj was there in Thailand, in Bangkok, and that helped us to provide a mechanism to connect people across countries. So we invited all heroes, community builders, and user group leaders to Thailand, and we all had a great 3 days and we connected with everybody, and we seen a lot of relationships start between different areas of APJ, which is really fantastic, and why we wanted to have this event in Thailand. And I know, as well as me, there was a few other Sri Lankan community people in attendance, and we have met a lot of people that week, which was fantastic. And those who were there, I'm sure you all agree, was an absolutely fantastic event. And for me personally, it was the best event I've had all year. So that beats any summits, any reInvents, even reInvent last week. The AWS Community Summit that we had in Thailand was for me the best event that I've been to this year. It was great. So as well as helping communities collaborate with others outside of their country, we also help them feature up and coming events from speakers who may not be in the community, and we support them like I'm doing now. So giving this community day keynote in Sri Lanka, I'm supporting the Sri Lankan community. And I've also talked at Sri Lanka meetups. This year, I think I talked about Flutter, and I also helped find speakers from across the world to come and talk to the community. So one of the best user groups we've got here is AWS user group in Colombo. It was a great group that I spoke to, and very worth supporting. And here's some examples of talks. So all talks you can also grab on YouTube. And indeed, the organizers of today's community days, well, you may notice them as speakers at the AWS user group Colombo. So it's absolutely worth supporting and getting behind. So what's next? What are we currently working on as AWS? So we're working on more community managers to help support you. So community managers is a role within AWS that helps bring the community together. So they manage the community, the leaders, heroes, and community builders. We're also trying to promote more community tracks and lounges at big events. So you'll see summits this year. We'll have community tracks and more community involvement. And we're always trying to push for more and more and more and less sales. Programs, we're looking at more programs that we can leverage so you can use inside your local communities. We're also trying to improve tooling. So things like Meetup, how can we improve the Meetup experience for people? And we're also this year started launching dedicated student advocates. So we've got one student advocate in APJ, two actually. And this is a new team that's primarily focused on students, because we see the whole student community as a really big opportunity to grow the AWS community as a whole. As well as those, we're also continuing to focus on diversity, equity, inclusion. We think this is big because when you have a diverse, equal, and inclusive community, you get more ideas, better ideas, more interesting ideas. And so we really want to focus on that. We really want to share your stories. So we want a way of collaborating and getting stories from the community to get out into the larger AWS ecosystem. So we can share stories, for example, from Sri Lanka Community Day. We can get that out there so other communities can see what's happening and also learn. We also want to collaborate more with 3P. So as I said at the start, AWS has been very good at its own communities, but we'd also like to start collaborating with other 3P communities like Java, .NET, Python, machine learning. All of those communities we want to do more with. And we also want to build better links with AWS internal teams. So I mentioned the Community Builders program, and how you can build links to internal service teams. We want to improve that. We want to make that more seamless, and make sure, as well as service teams, that we're also connecting with TNC and leadership. Because to us, and to me in particular, I think community is absolutely everything. It is everything. So Why is it so important? It's important to me personally because I owe a lot of my career success to the developer community and to the community. Without connecting, when I first moved to Australia, without connecting with communities, I would not be where I am today. I would not even be close. I would be working in a company very focused on their single output and not aware of all the things that are going on out there. And so that awareness is built my career. I've built my career on. I also learned things like how to fight burnout, because burnout is certainly in the last 2 years becoming a thing, and by giving back to communities, it actually helps fight burnout, because you're not always working for the same people. You're actually giving back and giving back to the community. So I like to give back to the community because the community helped me, and it's really, really, really nice to give back to it. Even after you've landed, for example, from a whole week of work at reInvent, I'm happy to give back, even with 5 hours sleep, to this ranking community day, what I'm doing now, and it's an absolute pleasure. Because ultimately, we want to invoke the campsite rule. So if you have never heard of the campsite rule, this is to leave this world a little better than you actually found it, and so that is the campsite rule, and we should all be trying to achieve that, leave the world a little better than we found it. Because for AWS, we simply couldn't do what we do without you, the community, and your passion and enthusiasm have inspired us over the last few years, and the drive. So all of the examples I showed you, the drive to create those has been inspiring, always iterating, improve on your behalf. And if you'd like to have more ideas, if you watch this talk and you think, oh, more ideas on how I can support the community better, or how AWS can support you, those ideas, don't hesitate and share with me. I can share with others. So with that, I'd like you to enjoy today's Community Day. Again, I think it was an absolute privilege to be here with you. If you want to reach out, please do so. I'm always happy to chat. And as I said, I looked at the rest of today's schedule, and it looks like a very cool Community Day schedule indeed. So with that, I'll say thank you very much and enjoy the rest of the Community Day.
So thank you very much, Derek, for that wonderful keynote, and for these wonderful communities across the world, especially like speaking such highly of our little community in Sri Lanka or Colombo.
Yep. It's very special.
Thank you
very
very much.
special. Yep.
I hope that everyone found it very intriguing and would, be convinced in joining this community and taking part in all these little events that we have. So moving forward, that's one thing that we would like to see everyone do. So once again, thank you very much, Derek.
My pleasure. Absolute pleasure.
Thank you. See you.
Nope. I removed myself and then you added me back in.
So, hi everyone. I think we've had a wonderful session from Derek that actually extended to all AWS communities, and gave us an insight about what AWS is doing to further the community journey, as it. So, moving on, we have our first session for the day. Our first session is about DynamoDB. And what better way to start learn about DynamoDB than from the AWS hero himself, Alex Debris, right? Alex has a wealth of knowledge about DynamoDB and has even authored a book that covers DynamoDB. Fun fact, this is an external reference that is recommended to internal AWS developers. So you know how good it is. He is also a very familiar face within the AWS community and has spoken at multiple AWS reInvents, where pleased to have him here at our AWS Community Day. So without further ado, let's welcome Alex Debris.
Awesome, thanks. Hey, Hero, how are you?
Not so bad. I hope you're doing well. Heard that you are.
I am. I'm recovering from reInvent a little bit. I've definitely got the post-conference flu. So my voice might be a little gravelly. I might have to cough and mute a little bit, but yeah, hopefully y'all can listen to me for a little bit.
Awesome. So I'll let you take it away. I know you're not a stranger to all these events. So
yeah, I should have got my screen on. Okay. Oops.
Over to you, Alex.
All right, sounds good. I just put there we go. All right, cool. Yeah, thanks for having me, everybody. Excited to be here at Community Day Sri Lanka. Would love to be there in person sometime, but virtual we'll have to do for now. I'm going to be talking about DynamoDB today because I love Dynamo. So we called this Understanding Dynamo for Fun and Profit. It's pretty similar to the talk I just gave at reInvent, a little clipped down and shorter. So hopefully we'll have some time for questions in there. But feel free to drop in questions as we go. I'll try and pick them if I can or hit them at the end. I'm also just very available via email, Twitter, any of that stuff after. So in terms of what we're going to talk about today, I'll start off just by doing a quick overview on what Dynamo is, what makes it unique, a little bit about some infrastructure stuff, and then we'll go into data modeling, because I think data modeling is the most important part with Dynamo. It is kind of unique and different from relational databases that you might be used to. So we'll go over a lot of data modeling basics. Then we'll go into some higher level, sort of deeper topics. There's a concept called single table design that's new, it's foreign to people when they're coming to Dynamo. So we'll talk about why you should do that. What does it mean to sort of do single table design, things like that. And then I'm going to close off at this one point around consistency, constraints, and transactions, which I think is a unique and not well understood point about Dynamo, especially as compared to other NoSQL databases. So who am I? As mentioned, Alex Debris. I'm the author of the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. I'm also an AWS data hero. I love doing talks and things like that. So feel free to reach out if you want me to have talks at your event or whatever. And then I do consulting as well. So let's hop in. So when I say DynamoDB, what do I mean by Dynamo? The short phrase I always like to say is that it's a fully managed NoSQL database provided by AWS. So the middle part of that, NoSQL databases, it's not a SQL relational database. There are a few different types of NoSQL databases. Mongo and Cassandra are probably the most popular ones in addition to Dynamo. And there's some similarities between those, but also some differences from how Dynamo works as well. One thing that's interesting about Dynamo is that it is that fully managed database, right? So you're not going to be provisioning instances, sort of scaling them up and down, adding new instances to your cluster, having downtime for updates and things like that. AWS is going to handle all that for you. And because of that, it's provided only by AWS. That's the only place you can actually run DynamoDB, and that allows them to give that fully managed nature. Because Dynamo is a multi-tenant service, right? There's when you spin up a DynamoDB table, they're not spinning up a unique service for you specifically, but across an AWS region, they're running this giant shared infrastructure where all the DynamoDB tables in that region are sort of running on this shared infrastructure, and it allows them to give you a different level of service and guarantees around it. And one of those guarantees, one of the things they aim for is just giving you predictable performance at any scale. So that's really the product ethos of Dynamo. They want to make sure that requests complete within single digit milliseconds, no matter if your table is 1 gig or 1 terabyte, things like that. So let's take a look at just a very high level of what DynamoDB's architecture is like. On one end, you'll sort of have your clients, which could be a mobile phone or your computer. It could be an EC2 instance that's reaching out. But if you're reaching out to Dynamo, you're not going to have like a specific IP address or URL for your specific Dynamo instance. Rather, you're going to hit a region-wide endpoint. It's going to be something like dynamodb.region, US East 1, whatever, .amazonaws.com. And so that's serving all the traffic within a particular region. And an AWS region is going to be split into different availability zones, which represent different physical data centers within that given region, right? So that regional endpoint is going to resolve to some load balancers within a particular availability zone. Those load balancers will reach out to what's called a request router. And the request router is starting to do some of the logic of Dynamo. It's going to do authentication, authorization, look up the key. And it's also going to figure out sort of which storage node you're on. And behind the scenes, Dynamo's running this enormous fleet of storage nodes. It's holding all these customer data. Your data is going to be divided into partitions, and these partitions are stored on these storage nodes with all other customer data segmented properly, of course. So that's what that request router is doing there. And then there's some supporting services in there as well around metadata caches, auto admin, transaction coordinator, things like that. And it's not just running within one availability zone, one data center within an AWS region, but across all these different availability zones within that region. And the great thing about this and that multi-tenant service, right, is that you could have an entire data center, an entire AZ could go down, and your DynamoDB table would be fine, right? You'd still have those other two AZs working. They'd be working to spin up additional infrastructure to sort of support that. You could suffer the loss of an entire data center and really be fine. And that's going to be pretty rare, but it's not that rare to have individual instance failures, right? If you look down in the bottom right, there's a storage node that fails, and storage nodes are going to be failing all the time. They're just designed to sort of handle that failure, recover from that, and not give you any impact on your application. And same thing with a request router, with a load balancer, all this stuff. It's built to be multi-tenant. It's built to be handling failures as you go and be really resilient and give you really high availability and durability for your data. So that's a look at sort of high-level DynamoDB architecture, which I think is interesting. We'll go back to pieces of that as we go, but I want to go into the data modeling basics here. And for this, we'll just use an example application, right? And what we'll use is a game, right? A massively multiplayer online game. Last year, Amazon Studios released this New World game, which is a new online RPG. Werner actually talked about it at reInvent last year, and all the different AWS services that are supporting New World, including DynamoDB. So one thing he mentioned, one of the ways that Dynamo is being used is they're sort of tracking the play time for a player. So if you're playing every 30 seconds, they're going to increment your total play time just to see, so they can show you how long you've been playing the game, right? So he said Dynamo's doing 800,000 writes, or New World is doing 800,000 writes to Dynamo every 30 seconds, right? And that's actually a fairly small workload as far as Dynamo is concerned. There's a lot larger workloads out there. So let's look at how we would actually model out this workload as we learn DynamoDB data modeling. I want to start off with some terminology with 4 key terms: table, item, primary key, and attributes. We'll start by looking at users in our gaming application, right? So we have some users in our table: Amrith, Alex, Janelle, and Chad. If you look at all these users together, all these records are going to be contained in what's called a table. So a table is going to be that container for all of your data, similar to a table in a relational database, but with some key differences as well. And if you look at an individual record in that table, that's going to be called an item. So this Amrith user item, that's going to be an individual record there, similar to a row in a relational database. Now, when you create your DynamoDB table, you have to specify what's called a primary key. And every item in your table needs to have that primary key and must be uniquely identified by that primary key. You can see here on the left, we have this primary key of username, and that's uniquely identifying every record, right? We're not going to have 2 users with the same username, but every user needs to have that username property to help us identify that record. This will be similar in some ways to a primary key in a relational database, but usually those are going to be, auto-incrementing primary keys that don't have anything to do with the record. Whereas in Dynamo, it's usually going to be something meaningful in your application that you're using for that primary key. Now, in addition to that primary key, you also have other attributes, which are similar to columns in a relational database, but different in the sense that you're not going to declare these up front like you would in a relational database. So DynamoDB is a schemaless database. You don't sort of declare an application schema. Your database isn't going to enforce that for you. Rather, you're going to have to enforce that in your application layer, right? Before you write to Dynamo, when you're reading back from Dynamo. Now, if you're looking at these actual attributes, you can see you can have simple scalar attributes like strings and numbers. You can see we have class, gold, total playtime, guild, things like that. You can have simple attributes, but you can also have complex attributes. As you see, we have inventory here, right? And it's a list of different objects that we have. You can have lists, sets, and maps as your attributes in DynamoDB. I want to go back and talk about the primary key a little bit because it's so crucial to how you do your data modeling with DynamoDB. In DynamoDB, there are 2 types of primary key. There's what's called a simple primary key, which has 1 element called a partition key. And then you have a composite primary key, which has 2 elements, a partition key and a sort key. If you go back to that users table we looked at already, that's going to be an example of a table with a simple primary key. It just has that partition key of username that's uniquely identifying each record. when you're using that simple primary key, this is basically like a key value store, right? You can operate on a single item at a time, but you can't do sort of more complex operations. If you want to use more complex operations, reading multiple records at a time, then you want to use a composite primary key. So look at that here and imagine that you have quests in your application, right? In addition to users, you have users going on quests, and we want to keep track of all the quests that they've gone on. So here's an example of a table with a composite primary key, right? You can see that this primary key now has two different elements. It has that partition key. Again, we're using username here, but it also has this sort key of quest ID. Now, if you look at this table, there are 5 different records here, and look at the top, those are 3 different items we have in our table. But notice that they all have the same partition key. And you can have multiple records that have the same partition key, and that's a very common pattern to do. You're sort of grouping them together. It's going to be very efficient for Dynamo to retrieve those. We're going to show some of those patterns later. We'll call that an item collection here. But the key point when you have that composite primary key is the combination of those 2 elements. Partition key and sort key must be unique, but you might have multiple records with that same partition key. Now, if we look at that primary, or the 2 types of primary key, notice that both of them have a partition key, right? And partition keys are really important to how Dynamo works. If we go back to that high-level architecture and you see that request router is actually using that partition key to figure out exactly which storage node to go to behind the scenes, right? So DynamoDB, it's not going to be this giant single instance, but behind the scenes, you're going to have all these different partitions that make up your table, right? And when a request comes in to create a new record, right? If you want to make this new user energetic Elsie, it's going to hit that request router, and the request router is going to look up metadata. It's going to hash that partition key for your table, and it's going to figure out which partition it belongs to. So in this case, it belongs to partition 1. And the great thing about Dynamo is they keep these partitions really small, so 10 gigs or less. And if you start to exceed that, then they'll add more partitions. They might add a third partitions or 6 more partitions or 1,000 more partitions. But whatever you're doing, that first step is very efficient. So that partition key, what it's doing is reducing your working data set from potentially infinite, right? There are tables in Dynamo that are hundreds and hundreds of terabytes and larger. It's immediately reducing your working data set on any given request to down to less than 10 gigabytes, right? And it's much faster. That's how they can give you that predictable performance at any scale. Take a drink here. So because of that, the partition key, that primary key, and especially that partition key are so important. And that's why you have to be accessing your data with that primary key, right? With that partition key, not with your other attributes, because those are basically unindexed attributes, and that performance is going to get worse as your table grows. Likewise, if you have a composite primary key, you want to access with those elements of that primary key rather than those other attributes. Again, those are unindexed attributes. So the key point here is you have to design your table for your access patterns rather than sort of normalize all your different tables first and then start to think about how am I going to query my data, what indexes do I need, and things like that. So let's talk a little bit about the DynamoDB data modeling process. And as we do this, we'll learn about some features of Dynamo, a little bit about the API in Dynamo as well. So I say there's 3 steps to the Dynamo modeling process. The first one is basically you're understanding your application, right? You create your entity relationship diagram, your ERD, where you have boxes for each sort of object in your application. You indicate the relationships between them. And at this point, you're trying to figure out what your application is about. Now, once you've done that, usually in a relational database, you'd go put those entities into their tables. You actually draw out the tables. With Dynamo, you're not actually going to get work to designing your table that you're actually going to list out your access patterns and be very specific about all the different patterns you're going to have on your data. And then once you know your access patterns, that's when you go out, you design your primary keys in ways that can handle your access patterns so that make sure that they'll be efficient and they'll perform predictably as your application scales. So let's just walk through this in our gaming application. Let's create our entity relationship diagram. Maybe you've done this before with relational databases, but we have users in our application. So that's one entity. Our users have a one-to-many relationship with inventory, right? Because one user can hold multiple items of inventory. Users also go on quests. So there's a one-to-many relationship between users and quests. And then users can also be the subject of a relationship, right? Because users can belong to guilds. So one guild has many users that belong to it. And those are going to be the 4 entities and the relationships that we have in our application. Now, once you've actually created your entity relationship diagram, that's when you want to go out and list your access patterns out. And I always say, actually do this, sit down, write them down, right? You want to be thorough in this sort of thing. So I'll have a design document that has a table like this, right? And I'll split them out into write access patterns. I have all my different write access patterns, like creating a user, increasing the gold for a user, adding a user to a guild, creating a quest for a user, all sorts of things like that. I'll have another table for my read access patterns, fetch a user, fetch inventory for a user, fetch all the quests for users, things like that. When you're doing this, if you're having trouble sort of thinking about your access patterns, two things that might be helpful to you is, hey, what REST API endpoints am I going to expose in my application? That can help you think of like, hey, what are the units of work or access patterns or use cases that I'm going to have in my application, right? Or maybe you're creating some sort of service class. You want to say, what methods does my service offer to the world that I want to make sure are efficient and easier? The big thing here is you want to be very thorough and specific, right? And if you look at the actual read access patterns I have here, just an example of being thorough, I have one pattern that's, hey, fetch all the quests for a user and get those quests. But I also have another pattern listed that says, fetch the completed quests for a user, right? So I want to make sure I'm just getting all the quests that have been completed, right? So I'm filtering down, and you might think that's the same access pattern, but you might actually need a design for that separately, as we'll see in a little bit. All right, now once you've listed out your access patterns, that's when you go through and actually design your primary keys to handle these access patterns, right? And again, the key point here is you want to access with your primary key and not with those other attributes as much as possible. As you're sort of looking through your access patterns, there are sort of two categories I group them in. In terms of write access patterns, note that these are almost always going to be single item actions where you're working on an individual item, right? Creating a user, increasing gold for a user. You're working on a specific item that you want to be manipulating. Likewise, when you're doing read access patterns, there's some single item patterns there as well. Retrieving an individual user, getting the details for a particular quest. These are all individual item actions. And as we saw earlier, right, your primary key has to be unique for a particular item in your table. So every single record is going to be identified by that primary key. So it's going to be very efficient for DynamoDB to look up things by that individual item. So single item actions, that's going to make up a good amount of the access patterns you have. Again, this is going to be whenever you're reading, creating, manipulating an individual record, right? Getting a user, adding a user to a guild, creating a quest for a user, things like that. When you're doing these single item actions, you have to include the full primary key because it wants to be able to identify the exact item you're working on and efficiently handle that record. And all your write operations are going to be single item actions. All right, I saw one question there. I'll get it. So one question from Alok is, can we change the sort key after table creation? No, you cannot. You cannot change your sort key. Your primary key is going to be fixed after it happens. Now, if you get into the situation where you want to sort of add a new access pattern, we'll talk about that in a second with a pattern called secondary indexes. We'll see that in just a second. You can add in sort of additional access patterns that have a different sort key, things like that. So good question, Alok. All right, so going back, we talked about single item actions. That's when you're working with an individual record. You identify it by the primary key. But if we look at our read access patterns, we also have a number of patterns where we want to read a set of records in a single request, right? Get all the inventory for a user, get all the users in a guild, get all the quests for a user, things like that, right? So let's see how we handle those. And we'll start off with the first one, right? What if I want to retrieve the inventory for a user? Well, if you remember how we modeled out our users table, we actually embedded that inventory within an individual user, right? Using that list attribute type, right? So in this case, all we're doing is using a single item action where we're using that get item action to retrieve that user by their username. And that's getting us that sort of many relationship of all those related inventory items, right? So that's one way you can handle it. But let's look at another way, right? What if we want to fetch all the quests for a user? And we can go back to our table that we have, right? Our quest table. And remember, we have all those records that have, I'll come back to the question. That's a great one too. We have all these records that have the same partition key. And because they have the same partition key, remember Dynamo is distributing your items according to that partition key. So they're going to be sort of a group together by this partition key. And because that, you can use what's called the query operation. And in the query operation, you only have to specify the partition key, and you can get all the records that have that given partition key. So in this case, we can get all the records that have that belong to this user, all the quest records for this particular user. Then within that item collection, those records are going to be ordered according to that sort key, right? So they could be ordered by timestamp, alphabetical, however you want to order it here, but you can actually order records within an item collection. So you get a group by and an order when you're doing that composite primary key. In this particular case, I'm using what's called a ULID, which is a unique time sortable ID. So it gives me an ID that's it's got some uniqueness, but the prefix of it is the timestamp at when it was created. So the first 10 characters are basically an embedded timestamp. You can see that quest started at. They're ordered according to that sort key, which also maps to when that quest was started at. So I get the uniqueness of a UUID, but also get some sorting according to time, which is very nice here. And I can do filtering with that sort key, right? So my partition, I can say, hey, give me all the quests where the username is Amazing Amherst, but maybe I want to say, and that quest ID is between this string and this string, which map to the 1st of January and August 1st, something like that. It's going to filter down to just those particular records. So I can pull in that sort key to help me filter out records that I don't want, right? So the query API, this is an operation you use in Dynamo called the query, very powerful for retrieving sets of records, right? If you want to get all the quests for a user or all the members in a particular guild. When you're doing the query API, you have to include the partition key because remember, we want to route it to the right storage node and narrow it down there. But you can also include sort key conditions on that to help filter even further, right? So you can filter on time range, you can get the most recent, you can filter alphabetically, all sorts of things like that. I want to go back to one question we have. Can we have many-to-many relationships in our entity relationship diagram? Absolutely, you can do that. I think that's a little trickier to model in Dynamo. I'm not going to talk about it in this particular talk, but I have other talks that do, or you can check out the book that do. It depends a little bit on whether you want to use some duplication or things like that. But as we'll see later, there's no join operation in Dynamo. So many-to-manys can be a little trickier, but you absolutely can do them. And I've got some patterns out there. Feel free to hit me up after this if you want to. There's another question about should we use single table design or multi-table design? We're going to get to that after this basic data modeling stuff. So stick with me till then. We're going to do basic data modeling. Then we'll talk a little bit about why you should, or maybe why you wouldn't want to use single table design. So hope that'll help you there. All right, so back to the query API. Again, remember what that's doing is allowing us to read multiple records in a single request. And we saw here that we have those patterns where we want to retrieve multiple records in a request. And we saw two different patterns, right? That embedded pattern where we embedded the inventory into a single user record, but we also saw that query and item collection pattern as well. So when should I use one versus the other? I always say reach for that embedded pattern when you have a small and bounded set of relations, right? So a user is not going to have 1,000 items of inventory, right? They have a helmet, a sword, a shield, different things like that, but maybe 5 or 10 pieces of inventory, not a ton there. So it's going to be bounded. You're not going to have these huge Dynamo items that you keep adding all these records onto. And you're not searching by the relations directly. Dynamo doesn't let you index a list attribute, but I never want to say, hey, go find me that user that's holding this particular axe or something like that. I'm only fetching the user, and then I'm sort of looking at the inventory that user has. So you can use the embedded pattern in that situation. I think more commonly you'll use that item collection and query pattern. This is good when you have a large and unbounded set of relations, right? The number of quests I have, I don't want to limit the number of quests that someone's going to do just because of my item size and things like that. So I'll probably map out each of those quests separately. Same thing with like orders in an e-commerce application. You wouldn't want to embed that on that customer object because it's just going to keep getting bigger and bigger. Also, you might want to fetch by that related item directly, like who did this quest, who made this particular order. All right, so let's head back. Let's head back to our read access patterns. We had one pattern of let's fetch all the users by guild, right? So we want to fetch our user records by this guild attribute. But if you go back to our users table that we had before, we want to access with that primary key, which is our username, and that's how we have one pattern. But we also now have a different access pattern that fetches on a different attribute, this guild attribute, which is an unindexed attribute. How are we going to handle multiple access patterns that are sort of conflicting with each other, right? And that's where Dynamo helps you with a pattern called secondary indexes. And what you can do there is basically declare this on your table, and then data from your table is going to get copied onto separate partitions with a new primary key and allow you to query it that way, right? So if we go back to our table, imagine we want to retrieve our users by their guild, right? We can create a secondary index and we say, hey, I want the partition key for my secondary index to be the guild. That's how they're going to be sort of grouped by. And then I'll use that username as the sort key and the ordering for within that. And if you look at this now, what I have here is I have the exact same data from my table before, but this is in my secondary index and it's rearranged in a different way. I have this different primary key of guild and username, and now I can do that query operation where, hey, if I want to get all the people in that Dynamo Destroyers guild, I can go fetch them very efficiently, right? So that's what secondary indexes are doing with you. They're copying your data onto new partitions, new primary key. I say a new primary key. It's not a true primary key because they're not going to maintain uniqueness for you on that secondary index like they would on your main table, but it's close enough in most aspects. Now, secondary indexes allow for read-based operations. You can do queries, you can do scans against your secondary index, but you can't write to your secondary index. All your writes have to go into your main table and then are sort of replicated out to those secondary indexes that allow you to do reads there. And again, the key point here is you can use these to handle multiple access patterns on the same item. One other interesting thing about secondary indexes is they can actually help you provide filtering using a pattern called a sparse index. So let's go back to those last two access patterns I talked about before, how we have fetch quests for users, and we also have fetch completed quests for users, right? And that last one is the same as the first one, but it needs to filter out some of those records, right? If we're querying all the quests for a particular user, we actually only want to get the records that have a quest completed at date. We want to exclude this record that doesn't have a quest completed because it's not completed. And as you get more and more quests, you might be retrieving a ton of data and just throwing a lot of it away, which is going to be inefficient. So what we could do here is create a secondary index using that username as partition key, that quest completed at as the sort key. And Dynamo is only going to copy records into your secondary index if they have both elements of that primary key. So any quest here that's not completed, that doesn't have that quest completed at date, is going to get filtered out. And now you can see I only have my completed quests here. And that's what that sparse index can do for you. So that's the data modeling takeaway section, or that's the basic data modeling section. A few takeaways here. Like, make sure you understand your access patterns and you model for those specifically, because that's how you're going to be successful with DynamoDB. You have to rely on your primary keys. That's what you want to use for all your access patterns. And then you can use secondary index to access your data in different ways if you need to. But in both cases, you're still using that primary key, especially that partition key, to get to the right storage node very efficiently. We talked about relationships and how you can embed those relationships onto a single item, or you can use that item collection pattern and query operation to handle relationships. And then we showed different ways to filter your data, right? You can filter with that partition key. On that quest table, I was filtering with the partition key saying, hey, give me all the quests that belong to this user, and including the partition key. Or you can filter using that sort key on that query operation where I say all the quests for this user between this time range to only filter down to those particular quests. Or I can filter with that sparse index pattern where I create a secondary index, and any records that don't have the elements of that secondary index's primary key are going to get filtered out of my table. The key point with Dynamo and the way you work with Dynamo is two things, right? You want to limit the number of requests you're making to Dynamo, and especially sequential requests. You don't want to be sort of fetching some records, looking at something like that, making other fetches to Dynamo, looking at something like that, and doing this sort of waterfall of requests. And you also want to limit the amount of discarded data, right? Ideally, you're going to make one request to handle a use case, and you're going to use your primary key, maybe a sparse index, whatever, to get only the items you need. You don't have to pull a bunch of records in and then filter them out in your application memory. That's the best way to sort of be working with DynamoDB. And that leads me into this next section, which is about single table design. We had a question about that before. If you start to learn about DynamoDB, you might see this single table design pattern come up. So I want to talk first of all, like, what is single table design? How do you do it? What are some of the principles? And then let's talk about like why you might use it. Why do you see this pushed a little bit? What are the benefits of it? And then my favorite point, like what single table design actually teaches you with DynamoDB. So let's start off with what is single table design. And basically what you're doing here is you're putting multiple heterogeneous entities into a single DynamoDB table, right? If you look at the DynamoDB documentation, it talks about how NoSQL design is different. And it actually says you should maintain as few tables as possible in a DynamoDB application, right? So if we go back to our ERD and we have those 4 different entities, usually you would create 4 different tables in a relational database, but Dynamo thinks, hey, combine those into one. And it doesn't think combine those into one by removing some of those entities from your application, but actually combining users and inventory, quests and guilds all into a single table. And you might think, hey, we already did this a little bit, right? We had users and inventory in that same table. If you look at our users table, we have our user record, but then embedded within our user, we have our inventory as well. So like, is that a little bit of single table design? I'd say not quite, right? So we want to be putting multiple different entities into a single DynamoDB table, but we also want to be using generic primary key names as part of this design, right? So rather than using primary key names like username and quest ID, we're going to be using more generic names. So I'll sort of take our 2 tables that we had before and combine them into a single table and sort of walk through some of the principles that we have there. Let's start off with just some of our user records. We have 2 of them here, Amrith and myself. A couple things to call out. First of all, if you look at the primary key, notice that we're using that generic primary key pattern, right? Instead of using username and quest ID, we're just using PK for partition key and SK for short key as the names for our primary key attributes. If you look at the values for these attributes, notice that they're kind of funky as well. They could be a few different values combined together and separated by a hashtag. In this case, it also has the type, prepending it, and different things like that. Let's add some quest records into our table now. We still have our 2 user records. You can see Amrith, you can see myself, but now we've added these 3 new quest records into our single table design as well. A couple things to note here. Notice that the sort key pattern for the quest record is going to be different than the sort key for a user, right? This is going to use a quest ID in that. So just a slightly different pattern there as well. Also, if you look at the attributes, I often include like a type attribute on my items. So then if I have the AWS SDK reaching out, retrieving some items from Dynamo, it's easier for them to sort of deserialize them into objects in my application by discriminating based on type there to figure out, what type of object it is. Also notice that these records have attributes that are relevant to the different type of item, right? User has user type attributes like class and inventory and guild, or a quest has quest-like attributes like quest name, quest start at, quest completed at. Because DynamoDB is schemaless, I don't have to declare those all up front, and they can each have their own unique attributes there. So that's the basic what is single table design. Let's think about why single table design, because that's kind of weird, right? It's very different from how we do modeling in a relational database where we have our nice normalized tables. So why do we do this? And I come up with three and maybe 4 reasons. The first reason you might want to do single table design is it can improve performance by resulting in fewer requests, right? If we go back to our single table design here, notice that we have item collections set up, right? We have multiple records that have the same partition key. But even within our item collection, we have item collections that are composed of different types of entities, right? We have this item collection that has a user record and also has a couple of quest records, right? And what this could be is maybe we need to, we have an access pattern that says fetch all the quests for a particular user, but we also want that user record to help sort of decorate that quest with information about the user. And in a relational database, this would be a join that you would need to do, but Dynamo doesn't have joins. So what you're doing here is basically pre-joining your data. You're joining it at write time. So they're located near each other when they write. And now it's going to be a consistent operation when you read those records. You don't have to perform that compute of joining every single time. They're already joined together, and it's going to be a very efficient operation that way. So that's the first reason, right? It can improve your performance by resulting in fewer requests. Another thing it can do is reduce costs for you. And to understand that, let's go in a little bit into DynamoDB billing. Dynamo is interesting. It's a fully managed service, and it also bills you very differently than a relational database, right? You're going to be paying for reads and writes directly rather than resources, right? A traditional database is going to make you pay for CPU, for RAM, for IOPS, all that stuff. Dynamo is going to make you pay for what are called read capacity units, RCUs, and write capacity units, WCUs. And this is actually based on how much data you're reading and writing to and from your DynamoDB database, right? One thing to note is the writes are charged for both your main table and your secondary index. So one way I want to show where single table design might be a benefit here is through this billing model, right? Let's go back to that user that we had in our users table before. If you look at that user record, notice that a lot of those attributes are small and fast moving attributes, right? They're smaller than a kilobyte. The class, the gold, total time, and guild, very small attributes, not going to take up a lot of data, but they also change quite quickly. Right? Every time I pick up some gold, I have to go increment that gold counter. And like I was saying, every 30 seconds, we're incrementing that total play time. So you're incrementing that counter quite frequently. In addition to those small, fast moving attributes, we also have this large, slow moving attribute, right? This inventory. It's not changing very frequently. You're not going to be changing your inventory very often, but because it's this array of objects, it could be a very large attribute, right? Let's see how that actually affects our billing. One thing that's great about DynamoDB billing, because you're paying for reads and writes directly, I always tell people, you can do the math and figure out different access patterns, or at least predict what your costs are going to be. So let's go ahead and do the math here on this single table design. Here's our situation, right? We have this 4 kilobyte user item that we're going to be messing with. And again, that's less than a kilobyte of core data and then about 3 kilobytes of inventory data. Let's say we have 3 secondary indexes. We have our main table and a couple other ways we want to access this user as well. So we have those secondary indexes. And then our total play time is going to get updated every 30 seconds as we just keep track of this user. If we do the math on that, 1 hour of playtime is going to cost about 2,000 write capacity units. And the math here is going to be 4 write capacity units, because it's 1 WCU for each kilobyte of your item, times 4 targets, because you have your main table and those 3 secondary indexes. And then you're doing 120 writes, right? Because you're doing 2 writes a minute for an hour. But if we look at that usage, right, a lot of these writes are wasted because we have this giant inventory record that's not changing very much and also isn't really used in our secondary indexes. And we're replicating it out to our secondary indexes that don't really need that inventory item, right? So we can see, is there a better way we can model this table? We could do that maybe with single table design here, right? Where we're splitting that user record into this small, fast moving user attributes, right? That has gold, total playtime, guild, things like that, things that are core to that user and might change pretty quickly, but are ultimately pretty small. And then we have this larger, slow-moving inventory record there as well. And now if we go back and do the math, now instead of a 4 kilobyte user item, we just have a 1 kilobyte user item, right? And that's going to take our write capacity down under 500 write capacity units. And we've significantly reduced the amount of write capacity we're dealing with there. And the key here is we didn't need that inventory and all those other access patterns, but you might say, hey, it mixes up the access pattern where we do need to fetch the user in that inventory record. But using single table design, we can still do this, right? We can put them in the same item collection. So now when we're fetching that user and need to get all the user details along with that inventory, we can do that with the query operation and construct our user that way. So that's that second benefit of single table design. It can reduce your cost for you by helping you sort of vertically partition your data in different ways. Last benefit here is it's going to give you a lower maintenance burden, right? A lot of people think, I have 20 tables in my relational database. What's the difference? But all those 20 tables are going to be in a single piece of infrastructure that you need to manage. But each DynamoDB table you have is a different piece of infrastructure. It needs to have its own alarms, its own capacity, all that sort of thing. And, it's fully managed for you, but you still need to maintain capacity for it. And it can just lower that maintenance burden for you. So those are all like the hard benefits of single table design. My actually bonus benefit is I think it forces you to think about DynamoDB correctly, right? If someone's picking up Dynamo for the first time and they see the term table, they think, I know tables. I've been working with relational databases forever, and they model it the exact same way as a relational database. And that's not how you should be working with Dynamo, right? So when they hear, hey, you should be doing single table design with Dynamo, they think, okay, I wouldn't even know how to begin to do single table design in a relational database, put all my entities in a single table. So now I need to learn something here, right? And now you realize you need to think about your access patterns, not data normalization, right? You need to think about latency. How can I reduce the number of requests by maybe pre-joining my data in different ways? Helps you think about costs and the shape of your data and how that affects your ultimate bill with DynamoDB. So here's my big takeaway here. I like single table design. I think it's great. I think there are some times where you might want to have a couple different applications, but you should absolutely learn the mechanics and the theory, but don't feel boxed in with that particular design. All right, so that's single table design. I want to talk one more thing around consistency, constraints, and transactions. I don't know if we'll have much time for questions, but I'm going to burn through this quickly. Let's see. Oh, one thing we talked earlier about how Dynamo has all these different partitions for your data, but even within an individual partition, that's actually going to be replicated 3 times, right? So there's going to be 3 copies of each piece of data across multiple availability zones. So let's look at one of those sets of data here a little more closely and just the interactions in that, right? We have 3 different instances that are sort of replicating data. We'll call that a replica group. Now, we have 3 different sets of data, but when a read happens to Dynamo, how does that actually work, right? We talked about the request router earlier. Let's say a user comes and wants to get that amazing AMR3 user record. It's going to go to that request router and based on that partition key, find out which replica group it needs to hit. And by default, it's just going to hit any of those 3 nodes in the replica group. And any of those nodes can serve the read and return that back to you. So that's how reads work by default. But writes are a little bit different, right? When you're doing a write operation, so you want to update, there's actually a leader within your replica group. And that leader is in charge of the writes for that replica group. So now that request router is going to route that request to the leader in your particular replica group. That leader is going to make that write locally. It's going to reach out to the other nodes in your replica group and tell them to write it. As soon as one of those other follower nodes in your replica group commits it, then the leader is going to say, okay, this is good. I'm going to return that, acknowledge it back to the client there. And the problem here is there could be a little bit of lag on that failing node. So imagine you had a read request come in around that same time, right after that write has been accepted, but before it's been replicated to that third node. Maybe that read hits that third node. This could actually be a stale read. And this is what's called, this is where if you hear about eventual consistency, where that sort of issue can come in. So just a sense, just like a high level review of how Dynamo and data consistency works. Each partition is going to be replicated to 3 nodes across these 3 AZs. That's called the replica group. Any node can serve a read by default, but the leader has to process the write operation, right? And that write must be accepted by 2 out of 3 nodes before acknowledging to the client. So why does Dynamo use a strong leader? Because Cassandra, which is actually based on the original Dynamo that was internal to Amazon, doesn't use a strong leader. It uses a leaderless model. I think there are actually some really key benefits to using the strong leader model that are kind of subtle, but are really huge. First benefit is that you can avoid eventual consistency on your reads by going to the leader, right? So go back to this. We saw that we could occasionally get a stale read when we're making reads from our database, but maybe that's unacceptable in our application. If that's the case, when you're doing a read request, you can specify, hey, I want a consistent read. Consistent read equals true. And now when that request goes to the request router, it knows it has to hit the leader node in that particular replica group, and you're going to get the most up-to-date piece of data for your application. So that's one benefit on the read side, but I think the real benefits are on the write side, right? Because there's one canonical version of each item. That leader is maintaining what that item actually looks like. Again, in Cassandra, which has this leaderless model, you can have multiple nodes that accept a write within a particular replica group. And now you might have conflicting updates. You might have to figure out how to do reconciliation between them. Maybe it's doing the last write wins, but maybe it's pushing it down to the application layer, and you sort of have to figure that out. And that's really difficult to reason about when you're working with your data. Additionally, because there's one canonical version of each item, you get cheap and easy conditional writes. And conditional writes are super huge. I always tell people when you're doing your write access patterns, list out which conditions you want to maintain, right? When you're creating a user, you don't want to have a user with the same username, right? So you want to make sure there's not a user with the same username. Think of all these conditions you want to maintain as you're writing your data. It's going to help your sanity there. So examples of condition expressions, how they're useful, right? If you want to assert the existence of an item, if a user is like selling a piece of inventory, you want to assert they actually have that piece of inventory before you give them credit for it, right? Or maybe you need to assert uniqueness or non-existence of a particular item by saying, hey, if I'm creating a new user, make sure there's not a record with this same username, right? You can also assert constraints based on other attributes in the item. You identify the record with that primary key and make other assertions based on the current status of that item. And the key benefit here is there's no latency penalty to doing condition expressions. So you can add in condition expressions to your write operations, and it's not going to cost you any more. It's actually going to be faster if that condition fails, because now it doesn't have to handle the writes to the replica nodes. So that leader can handle that really quickly. And because that's a fast operation with the condition expressions, you can do transactions, and transactions are huge, right? So DynamoDB transactions, these came out in 2018, greatly simplified certain access patterns where you want to operate on multiple items in a single all or nothing operation, right? If I'm working in my game and two users are sort of trading with each other, you want to make sure that one user has the weapon, the other user has enough gold as you're operating this, or as you're performing this operation, right? Super beneficial to use that. You can also use this for idempotency. So you can include an idempotency token in your DynamoDB transaction to make sure you're not sort of double processing or double counting operations. With transactions, the big key there is always watch out for contention. This is true in relational database or NoSQL. You don't want to involve an item in a transaction if it has very high contention, because you're going to be thrashing all over the place. So just the main consistency takeaways, and I'm going to close it out. I'll answer as many questions as I can in 5 minutes. Make sure you're using condition expressions to maintain constraints in your data. It's going to help you maintain your sanity. Very cheap and easy. It's not going to cost you any in terms of dollars or latency to handle that. It can help you maintain uniqueness, prevent double assignment, all that sorts of things. If you have constraints across multiple items, that's where you pull in DynamoDB transactions. But again, watch out for contention there, because you don't want to be thrashing around. There's also going to be an additional cost associated with transactions that you'll need to think about there. And then finally, if you have consistency issues on the read side, you can use that consistent read operation if you truly need it. Note that this is not available on global secondary indexes. Those are eventually consistent, and you can only make eventually consistent reads on global secondary indexes. All right, so summary and takeaways here. Biggest thing I want you to take away here is NoSQL data modeling is different than relational database modeling. Don't bring the exact same practices to NoSQL, or you're going to have a bad time, right? Take the time to learn DynamoDB concepts, learn how to model in DynamoDB. And part of that is learning the underlying infrastructure and understanding how request routers and storage node works and how they're using that partition key and why that's so important in your data. And once you understand that, now you understand the API design of Dynamo, why they give you single item actions, which require the full primary key, or they give you that query operation, which requires the partition key. It all makes sense to you, and it doesn't feel restrictive. You understand what they're doing there, understand all that stuff. And the last thing I'd say is, like, man, there's so much operational excellence by that DynamoDB team. That's a multi-tenant service that's been baking for 12 years now, 10 years now. They've got huge numbers of requests operating against that thing, and dedicated teams to handling it. And you're just going to get significantly higher availability on that than you can get by running your own database or avoiding vendor lock in that way. So lean on that, I think, as much as possible, and spend time on building something that matters to your users. And that's all I have. I saw a few questions. If we want to pop any of those up, I can buzz through those quickly, and anything else as well.
Yeah, all right, Alex. So I think we have a couple of questions from your session. Yeah, I mean, it was pretty interesting for everyone. So I think we have one from MJ Zone. So I'll just pin it onto the chat on the video. So he says, if you have a GraphQL API, does it still make sense to use the single table design? What are your thoughts on it, Alex?
That's a great question, and one I get a lot. I actually differ with Rick Houlihan, who's like the DynamoDB OG on this. He's all single table all the time. I think GraphQL, because of the way it works, because how it's got sort of the sequential resolvers, because just by default, by how it works, because you want flexibility in your API, things like that, I think it's less necessary for that. I have a post on my blog about this. I also have a post on the AWS blog about this, and talking about the different trade-offs of using single table with GraphQL APIs. So check that out. But I think that's a different case. It's harder because in GraphQL, you don't know your access patterns as specifically up front, especially if it's the variability in the queries. And I think that you lose some of the benefits of single table in that case.
All right, awesome. I hope that clears up your question, MJ Zone. And I think we have time for one more question, Alex, because we are running a bit short on time also. So the last question is from Alok Kumar. So he says that encryption is by default, or do we need to apply it for each table that we are creating?
That is a good question, and I cannot remember what the default setting here is, but you can absolutely set it. And I believe you can use an AWS managed key. You can also bring your own key if you want to do that sort of stuff. So they make it super easy to encrypt if you do. I can't remember what the default. My guess is it's encrypted by default, but I'm not positive on that one.
All right, awesome. So I think we can do one more question then. So yeah, again, another question. Last one by Mohammed. Can we arrange single and multiple ERP diagrams? I don't think I'm not following on that. Do you have any input on that, Alex?
I don't quite understand that one, Mohammed. If you want to reach out to me on Twitter, email, something like that, and if you have a question, I'd be happy to sort of take that one offline on that one.
All right, awesome. So yeah, I think we can do one more if we have time. I think it's still 10:44. So yeah, so here, this is from another one from Alo. Can we change the sort key after table creation?
Yeah, that's what we talked about a little bit earlier. So you can't change the sort key after table creation. That primary key is set in stone. But now that we've covered secondary indexes, one thing you can do is add secondary indexes after the table has been created. So if you decide, oh man, I wish I had a different sort key for some read-based access pattern, you can add that after the table's been created. It's going to backfill all that data for you and keep it up to date for you going forward.
All right, awesome. So yeah, we just added Trihana onto the screen. I'll just take a question off. So yeah.
Okay, thank you, Alex, for the wonderful session, and we learned a lot about DynamoDB. So now it's time to give your brain muscles some exercise and answer some questions. So please welcome our quiz master for the day, Chamira Dulanga, who is the AWS community builder and active member of Colombo user group. So Chamira, over to you.
Thank you very much, Trihana. Hope you guys can hear me. Today we have a bit different format for the quizzes, and actually we are conducting a quiz tournament. So there are three quizzes throughout the day, and each question will have 10 questions, and you will get 15 seconds to answer for one question. And to score in the quiz, you should be correct and you should be fast as well to get the maximum number of points for a single question. And we have some exciting gift ready for you, and each quiz will have a one winner, and we will combine the score of all the three quizzes and come up with a single winner as an overall winner for the whole tournament. So overall there will be four exciting prizes for you to grab up. So with this new format, you can always make a point for participating in all three quizzes. So without further ado, I will move on to starting the quiz. And if you haven't registered yet, you can use the link in our stream and get registered for the quiz. So I will wait like another couple of seconds if anyone is getting registered. Okay, so we have around 114 registrations for the quiz one now. So let's get started with the quiz, I guess, since we need to run on the schedule as well. So guys, now we will start the quiz one of our quiz tournament. Good luck. Okay guys, now you should see our question. So quiz is started. So at the end of the three questions, we have Lalisha leading the leaders board. Yeah, so we will move on to the fourth question, and now the leaderboard has changed drastically compared to the what we had in previous question.
Okay, we have a new winner, like a leader.
So guys, as you can see, leaderboard is changing very rapidly. So you need to be quick for your answers, not only correct. So there are many guys with same number of points, but they are just different by milliseconds of time. Currently, Imanta is leading the leaderboard, and Yasit is very close to it in terms of time duration. And now we have again a change in the leaderboard in the quiz. Yasit is now leading, and just now it changed again. Now Vinay Prashant is leading the leaderboard. So guys, this is the final question. Let's see who will win the first quiz of AWS Community Sri Lanka 2021. So guys, that marks the end of our first quiz, and the winner is Yasit Samaravikrama. So Yasit, congratulations for winning the first quiz of AWS Community Sri Lanka 2022. And we have very close contest between Imanta, Vinay, and Kalana and other guys. So So others don't be worried. So we have a overall quiz winner. We will be selecting an overall quiz winner at the end of the day. So keep joining with us. There are 2 more quizzes, so you can accumulate your quiz score using those 2 quizzes and win the overall gift as well. So you can find our agenda from our AWS user group.lk website, and we will keep sharing our agenda through the chat as well. So the second quiz will commence at 1 p.m. Sri Lankan time, and the third quiz will commence at 4:15 Sri Lankan time. So I invite you guys to keep with us and join with those upcoming session and the 2 quizzes as well. So thank you again for joining with us, and over to you, Trahana.
Yes, yes. Congratulations, Yasit, once again, and the AWS team will get back to you with your gift, and you will be rewarded with a wonderful gift pack with AWS SAG and other details in it. So we will get back to you regarding the gift as well. So we encourage you to participate in this tournament quizzes so that you could win a lot of AWS related swag and the community day related branded stuff. With we have lined up a lot of wonderful gift packs for you guys to win. So stay with us during this day. Thank you. So we will be back with another session shortly. Hi guys, we are back. So our next session is conducted by the most youngest AWS community builder in Sri Lanka, and he's also an experienced cloud developer and a serverless enthusiast and a technical writer. This session focuses building on scalable and loosely coupled backends with AWS serverless. So here to provide an intuitive insight about the limits of scalability and architect serverless applications to ensure they serve the mission critical workloads. So without further ado, please welcome Lakidu Hewavasam, the most youngest community builder in Sri Lanka. Thank you. Over to you, Lakidu.
All right, hi guys. I'm sorry, I just had a bit of a technical glitch over there. I just dropped out, my Wi-Fi went away, but now I'm back. So yeah, let me just upload my presentation. So yeah, can anyone add my presentation to the screen, guys? All right. Awesome. So yeah, hi guys. I hope you all have had a great time so far. So I was just listening in on Alex's session. So I noticed that he talked about key aspects of DynamoDB, which is going to be pretty useful for this session because when you're talking about building a scalable serverless application, so the main place you would have a bit of a issue is with data as well. But when you have that kind of knowledge jumping into this session, it's going to be quite helpful to understand these concepts and find out where they all fit in when you take a look at the entire bigger picture. So we're going to be talking about building scalable and loosely coupled backends with AWS serverless. But before we just jump in, I'm just going to give you a brief introduction about myself. So in my day job, I'm basically a software engineer at Enlia, where I mainly focus on building production-ready AWS serverless workflows on a daily basis. And apart from that, I'm also an AWS community builder in the serverless category. And in my free time, I like to make technical content on YouTube or blog, or even if I have a lot of time, I would just casually contribute on Stack Overflow with any random question I find. So the outline for this presentation, so essentially we're going to be talking about the introduction to serverless. So basically, so the people who are joining here today who are not quite aware on serverless, well, this is your time to understand what the hype is all about, because I'm going to be talking about serverless and why it's being used and why people have migrated onto serverless. And we are also going to be taking a look at some common patterns or some common implementations of serverless, mainly the shift to serverless and how people got started with it. And we're going to talk about the several problems that they faced and what are some of the ways. Like, so essentially, this is where the concept of loosely coupling and decoupling your applications comes in, where it helps you build a quite robust, resilient, and scalable applications really quick. So to start, serverless. Now, what is serverless? Like, what's the big hype all about? So serverless, if you take a look at it in a nutshell, it's just a cloud computing execution model where it kind of provisions and manages your underlying server behind the scenes. So it's offshored onto a cloud vendor, and they provision and manage it and scale up those resources on an on-demand basis. So essentially what this happens is it kind of abstracts all the added complexity from either a developer or an operations person or an operations team, where they do not have to kind of maintain your infrastructure, where they do not have to maintain what OS your servers are running, how are the performances, what's the fault tolerance on it. So you don't have to maintain all that. That's kind of being managed by the cloud vendor. So for those of you who are quite familiar with EC2 might understand that when you first provision an EC2, you would have to kind of take a look at what's the OS you're running and how much storage you want on it and what's the networking you want. So you might have to configure all of that. But when you take a look at AWS serverless, you just have to focus on providing a business value to your customer while the cloud vendor takes care of all of those complexities. And one such service that AWS offers, quite literally one of the very first serverless offerings, is through AWS Lambda, where it's essentially a compute service that allows you to execute code on an on-demand basis. So I've used a lot of buzzwords here, like on-demand basis, and you don't have to provision or manage anything. So all of these hype words are why people have chosen to adopt a more serverless first approach. So you might hear people going like, hey, we should design this in a serverless first approach, where we think about what you can serverless first, and then you figure out what can't be solved with serverless, and then figure out another way for it. So the main reason is you don't have to provision any servers or manage it. All of it is offshored to the cloud vendor, and they take care of it. So it's a fully managed solution. And it also provides an on-demand scalability. So essentially what happens here is it provides an on-demand scaling. So when you can, for example, as Alex talked about DynamoDB, so it's another serverless database. So today you can be serving one customer. You could be serving one customer for all you have. And tomorrow that same service is able to scale up to serve about 100 or 100 million or 100 billion users without any performance loss, so without any scalability issues. And these services are all highly available. Now, when you take a look at DynamoDB, for instance, it replicates your data automatically across 3 availability zones. So those kind of serverless availability management is quite interesting and quite important for organizations, because they have to make sure that their services are available when customers want it. And the next is the cost factor. Now, when you adopt a more serverless first approach, you don't have to pay for idle because you only pay for what you use. For example, even if you take a look at Lambda or DynamoDB, you would pay for the execution time on the Lambda or the consumed throughput for the DynamoDB. And with that, you essentially cut down on your costs. So rather than provisioning something for an entire month, you would only pay for what you have used for that month, and which is quite beneficial for all organizations. And that's why they have kind of started the shift onto serverless. But you should always understand that using serverless, it does not mean that you have 100% guarantee on, your services are going to be serving 1 million, 2 million users today and 100 billion users tomorrow. That won't happen. It will only happen based on the way you architect your solution. If you have come up with a really bad architecture which does not scale well, there is it will be really difficult for your services to serve that kind of demand without experiencing some kind of a performance bottleneck or even a timeout. So with that, it's quite important to understand that scalability is not something that is 100% guaranteed. Developers have to play a part in it too. And this is where we talk about the kind of early implementations, like when people were just getting started with this buzzword, this is the kind of patterns that they adopted. So the first kind of approach that people thought of was the Lambda monolith. So this is essentially where you put the entire chunk or your entire application onto your a single Lambda function, and you would expose something like an API gateway and route all the requests onto that single Lambda function. Now, on one way, it actually works. Like, I mean, your application works and all of the requests are being served. Nothing happens. That's you might be serving 100 customers today, and yeah, that's all good. All Lambda is able to scale up and meet that demand, and it gets everything done. But let's assume that tomorrow you have suddenly 100 million users coming into your application at the same time. And these operations that you perform in your single Lambda, you might have some kind of operations where you kind of fetch something from S3 where you get an object, or something you might be creating a PDF file, you might be zipping something. Those are all highly resource intensive and take some time. And even if you're accessing a third-party AWS service, so for example, if you are accessing something like a parameter store, that all those requests behind the scenes all execute under an HTTP request. So those still add latency onto your responses. So there is no way that you can guarantee that this request will finish in this much time and be able to serve without hitting a Lambda bottleneck or Lambda concurrency limit or something. We are going to take a further look at this implementation down the line. So until then, let's just talk about the next one, which is the synchronous invocation. So synchronous invocations are another pattern that many people have thought, okay, now initially I implemented my application and I completely coupled all of my code onto it. Now, with that approach, you can see that your code was completely coupled. Every operation was aware of what's happening. And sometimes you might not be able to scale it, and you might not be able to extend your code, modify it without having some kind of breaking change on it. So what people decided to do was they decided to split these kind of operations. So example, if you had something like an operation where you first had an S3 operation where you persisted an object, and then you take that URL and persist it on a DynamoDB. And then what happens is people kind of added that within the same Lambda. So they kind of added these synchronous operations and synchronous invocations. And then what they noticed was, hey, I am performing a lot of synchronous invocations on my API, and these all at the same amount of time. And they all have like a sort of waiting going on, a sequential wait before the next request is processed. So that also sort of came up with another pattern. And then people decided, hey, I'm not going to have any of my code within a Lambda. I'm just going to split it up and have several services, several Lambda functions. And I'm going to chain it. I'm going to chain it in a way that this Lambda will call A, will call B, B will call C, and so on. So that's another pattern that many people adopt. So if you were taking a look at a Lambda monolith, so a Lambda monolith, as I discussed earlier, is essentially where you have an entire chunk of your application on a single Lambda. This is very common in people migrating from EC2 instances. They try to add all of their Lambda function, all of the application code on a single Lambda and expect it to perform the same way that it would on an EC2 instance. That doesn't work like that, because Lambda operates completely in a different executional manner than an EC2. And when a Lambda operates in such way, you might have to implement some kind of switch case logic and add some kind of handler code and kind of make your main execution handler function cleaner, and then add more kind of code just to have a kind of workflow created there. But with this approach, many people started to hit problems with scaling. This is because Lambda, of course, has a concurrency limit. This is not per function. This is per Lambda service. So for the Lambda service, you have 1,000 concurrency limit at any given time. And when this happens, as I talked about before, you might have an S3, SSM, or all those third-party services communicating. This will ultimately speed up, increase your response time, and will ultimately slow down the response cycle, and will cause Lambda to scale to meet that demand, to meet that workload, to meet that million workload that you're serving at. So there is a chance that you might run out of concurrency limit, and you might hit a concurrency limit, and Lambda will start scaling linearly at that point. That means that it might scale as this finishes. It might try to push it and throttle the limit, throttle the request, and try to push it as it comes. And with these kind of approaches, many high demanding applications would suffer severe bottlenecks in terms of performance, where the customers would end up getting high latency responses, or not getting errors, or just be getting errors on their requests. And then you have synchronous invocation. So synchronous invocations are when Lambda functions try to perform operations that can take a lot of time in a sequential manner. So sometimes these operations can be performed parallelly, or you might actually want it to happen one after the other. So for example, in this operation, we have a Lambda function writing to S3, and then it would take that URL and persist it back onto DynamoDB with the URL. Now, this is something that needs to happen sequentially, because you need that URL. But if you implement it in a way like this, so when you have the Lambda function first going and putting it on the S3 and getting a response, so you can see that it adds a latency at this point. You have to wait. That Lambda function will wait until this response finishes. And then again, this Lambda function will call DynamoDB, persist the item, and then come back. But this is very minimal, because if you have architected it right, DynamoDB would be able to serve you millisecond latency responses. But if you take a look at persisting something like a 1 gigabyte or 2 gigabyte file on S3, it would take quite a lot of time. So because of that, this Lambda function would ultimately take a longer time to finish its operation. And in a way, what it does is it adds latency to your response cycle, and it also creates tightly coupled code, because one action of your operation depends solely on the execution of the other. So if this happens, only this will happen. And this is also quite problematic when it comes to error handling. So if you go back to this diagram, let's say that you persisted it onto an S3, and when you try to write that file onto DynamoDB, you get an error saying the key value does not exist, or the invalid partition and sort key combinations, or something like that. Now, what happens here is you will have to again retry the request. And unless you have not added some kind of error handling code saying that, hey, is this file already in S3? You might end up adding it again. That might take another time. So in a way, it kind of adds spaghetti code onto your error handling logic. Or if you have not added it, it might just be some kind of improper error handling as well. And with this synchronous invocation approach, you should also understand that you are bound to hit one of these timeouts. Either an API gateway timeout, which is 29 seconds. So if you're uploading something like a 5-6 gigabyte file, there's a high chance that you might hit this limit. And then you might also have a Lambda maximum timeout. So if you're invoking this operation from a third-party service other than the API gateway, you might be able to hit a 15-minute timeout. And with that also, sometimes if you are lucky, if your file is not that big, or if your operation is not that resource intensive, you might be able to get away with it. But as your application scales in requests and users, this kind of approach kind of causes a lot of problems to many production grade applications. And then you have the Lambda invocation, so Lambda calling another Lambda function. Now, in the first two approaches, they decided, hey, my code is too coupled. I have to find a way to decouple it. I have to find a way to isolate this code and figure out how I can improve the performance and everything. So what they did was, I took it from AWS itself. So this is kind of another Lambda where they have an operation for order management. So you create an order, you process it, and then you create an invoice. And with this, they would have 3 Lambdas, and each Lambda would possibly pass in a self-contained message where that Lambda would have enough information to process it on its own. And then it would have create an invoice. Now, what's missing here is you are still performing this operation synchronously. So what would happen here? Now, let's say that the create invoice. So let's say you're taking like a huge library, you're using a really huge library to compute your PDFs. It would take up, it would roughly, let's assume that it would take about 45 seconds to compile this huge PDF with a bill and email it and so on and so forth. And when you're processing the payment, it would also, you have to contact the payment gateway, and then you have to authorize the requests and do all of that stuff from their end. So ultimately, this would also add latency. And when you add latency like this, you could see that ultimately the main invocation pace, the first worker or the first Lambda takes a really big time to finish its operation. So the customer would ultimately have to wait a long time just to get their response. In a way, this is quite problematic and does not deliver a nice UX. And also, it tightly couples your code. Again, though we assume that we have completely distributed our architecture there, you are actually creating another tight coupling because you are making a Lambda wait on another Lambda. And ultimately, the forward-facing Lambda would have to wait until the slowest performing Lambda finishes its operation. And thus, it would cause a lot of scalability issues, and you would possibly hit a concurrency execution limit, or it will ultimately use more concurrency than needed as well. So yeah, now we talked about these problems, these first level implementations. It's just lambda. Like people just assume that people who are getting started, like even I too myself, when I got started with serverless, I just thought that serverless was just a Lambda is the savior, Lambda is just our hero for everything. But no, Lambda is just part of the entire serverless ecosystem provided by AWS. In fact, there's a lot of serverless solutions that you can use to completely loosely couple your application and ultimately provide these scalability measures to and bring your application up to a certain level where it's more usable to a user. And not only that, but with these services also you can implement more patterns like resiliency and availability and high fault tolerance and so on. So how can you do better actually? Like, how can we do better? Like, we talked about the common implementations, what were the problems, and then we discussed that Lambda is just a part of this big picture of serverless. So my kind of advice is you should consider transitioning to an asynchronous approach where necessary, where it would offer you better scalability and a much more less coupling towards each application component that you have. And the first approach that I want to talk to you about is an SQS, which is essentially AWS's way of saying, hey, this is our take on a serverless queue. So it's essentially a simple queuing service where it offers queues to decouple and distribute your system. And the biggest benefit of this SQS queue is that it supports up to 120,000 messages or in-flight messages. So in SQS, an in-flight message is essentially something we call as a message that's being processed by a consumer, by someone who's using that message. So this is currently being consumed. So you could have 120,000 of those messages that are currently ongoing, and you could have an almost infinite level of messages stored within the queue that have not yet begun processing. So even if your application from the front end or from the client side, from the forward-facing Lambda, would send around a million requests, the queue would be able to take all of those requests and provide it independently and process it independently from its consumers and scale as this load increases without just invoking, okay, I need a million Lambdas right now. So without that, it would take its time and introduce something we call a differing operation, where it would take its time and process it. And how you would implement this pattern is, so this pattern, what we call is, with the SQS, you can implement this pattern we call queue-based load leveling. So essentially, queue-based load leveling is where you add an SQS queue between your long-running operations. So you balance the load via a queue. So that is essentially what this pattern means. So in your forward API gateway, you would essentially have a Lambda function that would process something. It would do some validation or something like that. And then if you want, you could have like a DynamoDB table to, let's say you want the client to know when the operation is done. So you would probably have something like a state mapped with the ID with the message saying that it's still processing, and you would return it. And you would push it to the queue and then return the response saying, hey, this message is now being processed in the queue. Now SQS comes into play And SQS will independently create event subscriptions. So event subscriptions are essentially these services that consume these messages. So one common implementation is through Lambda. So with Lambda will continuously poll these messages from the queue, and it will process it as the messages come. It won't just directly take everything. It will take its time, and it will collect these messages via SQS with the concept we call batching. So by default, SQS can support up to 10,000 messages or 6 megabytes, whichever comes first. And by default, SQS will always push 10 messages at a time. And when these messages go, Lambda can scale up to 60 instances per minute. So that's 60 Lambda functions processing 10 records each. So that's quite a lot of records that are being processed per minute. So that itself shows that it scales up. It does scale up. It does not deprive performance or anything, but it scales up taking its own time. Like as the queue will give the data, it will process it. So that is where we talk about processors messages at its own pace while allowing you to preserve your scaling limits. And you should also talk about error handling here. Now with the queue, now these asynchronous processes, the clients must at some point know if their operation succeeded or not. So how do you do this with a queue? So with a queue, you can additionally have something we call as a dead letter queue. Okay, we have a question. So here, Lakinder, how do we return the responses to the user if we process the request asynchronously? Okay, so yeah, that's a good question, MJ Zone. So ideally, if you are processing it asynchronously, you would ideally, so as I talked about it with the Lambda function, you could initially have like an ID and you would persist it onto DynamoDB, and then you would push it to the queue and then return it. And with that initial process, we would have an state here as processing. So with that processing status, you would send it to the queue, and the queue would process it on its own. And then we would ultimately, after the process finishes, we would take that request ID that we hit it with the DynamoDB, and we can have like a status where we manually say, hey, this process is completed. And with this, you could either extend this architecture and add another SNS topic here where it completely directly pushes the notification back to the client with the new ID that becomes processed. Or from the client's end, you could implement another endpoint to kind of poll the request periodically. So roughly, you could have like a collection of IDs present at the client side. And every 5 to 10 seconds or something, depending on how quickly your operation occurs, you could continue polling it from the client end, saying, hey, for this ID, what's the status? Are you done yet? So you keep asking the service, are you done? If so, give me the data. So you do that. Or as I mentioned, you could push from SNS directly onto the client. So with this Lambda, you could fire an SNS topic and directly push it to the client, and you could maintain an SNS subscription over there. So yeah, I hope that clarifies your question. So that was a good question. And yeah, so one tip or few tips that I can give you to kind of help implement this architecture is when you go about implementing an SQ, consider looking at the delay seconds. So delay seconds is mainly talking about how many seconds should I wait before I give you a message. So if you are Lambda, or if your operations take about, let's say, around 1 hour or 2 hours to go, and you get a lot of messages, you get around a bulk amount of messages, then Lambda scaling up would also help. But at some point, you would have to be like, hey, now I should kind of delay this message, because there's no point pushing it to a Lambda, because there's kind of messages that are already being processed. I know for a fact that it won't finish at this time. So you can add like a delay second saying, after this amount of time, give the next message. So you could do that based on your use case. And the batch size. So batching is quite important, and it will help you process a lot of records parallelly. So since you have support up to 10,000 messages, you could just figure out what's the sweet spot for you. And also take a look at the retention period. So with the queue, you can set up a parameter that we call the retention period. So that's essentially where we say, how long am I supposed to keep the messages in my queue? So if your operation, let's say you are trying to download an 8K video, and you're gonna take it, and then you're gonna download it first, and then you're gonna compress it, or you're gonna compress it into different formats. You're gonna compress it to 360p, 720, and 1080, and so on and so forth. You're gonna just create new videos with different formats. Now that would ideally take, I think I have seen when I upload YouTube videos, it takes about roughly about 2-3 hours or 4 hours just to get the 1080p video up if it's like around 30 minutes. So that shows that these operations take a lot of time. So with that, you can say from the queue, delete this message after this amount of time, because I know at that point it will finish operating. So yeah, so that's kind of a tip with queue-based load leveling. And then you can also implement something that we call as fanning out. This is with SNS, which is one of the very first messaging services offered by AWS, which is completely fully serverless. And it allows you to implement a pub/sub approach, where we call it, you can kind of call it as something like a distributed observer pattern. And the best part of this is you have these topics. These topics can accept a wide variety of messages. And each of these topics would have kind of a subscription. So currently SNS supports up to 12.5 million subscriptions per SNS topic. So I think that's quite a lot. And I think it would be more than enough for your application, unless you have some kind of really high demanding application that 12.5 does not meet your needs. And then what it does is, the Lambda function, again at the API gateway level, it would invoke and it would do some kind of operation. And then it would create the self-contained message. So all the information that another user might need is there on that message itself. So then you could push it to an SNS topic, and that SNS topic will immediately fire it to all of its subscriptions. So what have we done here? We have completely decoupled this approach. We have completely eliminated of saying who sent me this message, who else is involved in this message. So we are completely forgetting about it. Instead, we are giving a self-contained message saying, hey, this is what you're supposed to do. This is what you can do with it, and this is how you should do it. So this Lambda will know how to do it, and we should tell what it needs to do it. So ultimately, you can use it in cases where if you have, like, let's say you have like an API gateway, you process something, and then you have to create a notification. So you could create an SMS topic like on notification, push or something. And then you could have like several subscriptions there. You could have on SendGrid push, on Twilio push, on SCS push, and on MailChimp. So you can have several messaging services, and you could add different lambdas to it and let them process their service independently. Now, you might wonder, why have we done that? Why can't we just add all the processing on one function? I mean, that's a good question, because the first thing I have to understand is SNS processes the message immediately, and it processes it with the entire process. So even if you have to run into an error at some point, let's say you have sent an emails, done the messaging and done Twilio, and now you want to put some in-depth notification, and that runs into an error somehow. And now SCS has the automatic retry option. So SNS will automatically retry your request up to 3 times. It will just directly keep pushing with an exponential backoff for 3 times until it says this has gone for 3 times and you can't process it anymore. Now, what that happens is, when that happens, you execute the entire process. So you would ultimately execute sending an email, sending an Twilio SMS. You would send everything again, where your customers would get 2-3 notifications at the same time, and ultimately you fail your purpose. So in that way, you could kind of fan out these approaches and decouple them or loosely couple them, where they are not aware of who else is communicating with who. And you could kind of say, hey, this is your job. Your job is to send a message from Twilio. Your job is to send a message from SNS, from SCS, and so on. And also, one other important thing to understand is these operations that I just talked about, sending a notification to Twilio, SendGrid, MailChimp, all of this can take its own time, because we do not know how their backends scale. If they take a long time to process our request, our Lambda would ultimately take a long time processing it, and ultimately the SNS topic would create a bottleneck with the Lambda again. And because of that, you can choose a fanning out approach, saying, hey, you take your time and you just send this notification, and so on and so forth. But it's also important to understand that you should do this with performance in mind, because as you keep fanning out, you ultimately add more cold start delays, because all of these lambdas need to initialize. And you also add more costs, because all these lambdas execute parallelly, and you would hand up more costs. But if you compare it with the actual invocation cost of one lambda and compare it with the 3 costs, and if these costs are manageable for you, if these are bearable for you, you can go ahead and implement a more fanning out approach. And that is another way of implementing a nice decoupled approach where these services do not know anything about each other. Plus, they also have the ability to scale on their own. And one thing I forgot to mention here is there's a concept we call fire and forget implementation. So that means SNS, after it finishes its 3 retries, this message will disappear from it. There is no retention on it. So unlike SQS, which keeps retrying it infinitely until the message is deleted from the queue or pushed to a dead letter, SNS will discard the message after 3 times unless you configure it also. So you should keep that in mind. So if you want to take it one step further and add error handling or some error message processing onto this workflow, you can consider a pattern that we call topic queue chaining. So topic queue chaining combines the best of both worlds. It ultimately combines the use of SNS and SQS, where you have the same process here. So you take an SNS topic, you push it to the lambdas, but instead of pushing it to the lambdas, you push it to 3 queues that contain event subscriptions to these lambda functions. And what happens here is these lambda functions would then poll the queue and ask for data as it comes, and it would process it and at its own pace also. And you can also further enhance these queues and add independent dead letter queues. So in case these operations run into an error, you could be like, after you try 3 times, consider pushing it to a dead letter queue because there must be something wrong with this lambda that you have to take a look at. So that way you can preserve these messages, and once you debug and fix the error, you can start a dead letter queue redrive and push these messages back onto the queue so that they'll be processed by the lambda again, and ultimately notifications will get delayed, but it will get sent again. So yeah, so that's another fine pattern that you can implement, and ultimately bring scalability also, because when you bring a queue in, you ultimately buffer the load rather than directly pushing it. You again you let lambda scale with the way it consumes its resources. So the SQS doesn't necessarily give the burst onto the lambda. So that way you allow it to scale again while maintaining another nicely loosely coupled implementation as well. And you might also have to consider looking at the dead letter queue retention period here. So you might have to consider processing or something. You might have to consider having like a maximum retention period because you might take some time to find the error or something of that sort. So you can pretty neatly implement a nice resilient architecture here where you have you completely eliminate the way your messages kind of disappear from the SNS after it's retry. So this is kind of another implementation that I took from AWS, an AWS workshop, where they implement a way of decoupling microservices and implementing an asynchronous and scalable approach. So where here essentially it's about this ride sharing application, where after you complete a ride, there's another forward-facing queue here, which will act like a unicorn service where it manages all the other microservices. And from there, that Lambda service, it will fire an SNS topic and it will push data onto the topic, and it utilizes message-based filtering. So on these Lambdas or these data will get sent if these conditions are met. And with the queue, it communicates these microservices where you have the customer notification service, accounting service, and the ride service, and the other services as well, where these services don't get fired because of these conditions. So in a way, you implement these distributed communication while maintaining a much more scalable approach. So you can have around 100,000 requests here, but still after it pushes it into the queue, this queue will take its time to process it while allowing you to nicely scale it as you go. So yeah, so that's all I actually had to present for you today. And I think one thing that I should tell you is serverless is not something that is 100% scalable, but because of your implementation choices. So based on its documentation or based on the official definition, yeah, serverless will offer limitless scalability. But ultimately, it depends on how you implement it. If you choose a poor design, you won't get any benefit out of it. And you should also find out the sweet spot between implementing a distributed architecture. So if you just go back to the diagram here, you'll notice there's a lot of application components going around. Even in this, there's a lot of queues, there's a lot of dead letters, there's a lot of lambdas. So ultimately, it would be really hard for you to find the sweet spot on, hey, where can I find the error now? So if there's an error, how do you find it? So always keep observability in mind when you start to implement such distributed architectures, because you need to find out the entire data flow if you want to debug an error. And keep in mind of the performance, because when you talk about Lambda invocations, you can have cold starts and so on. That will add more delay to your request on the initial invocation time. And based on the recent announcements from Reinvent, so I thought I'd talk about that also in this. Now, previously, when you wanted this kind of message-based filtering or fine-grained approach, you would consider using EventBridge and its intelligent routing services. But now you could have this is kind of like a food for thought for you. You could, with the recent announcements, you could now implement message-based filtering on SNS with the complete message body. So it's no longer limited to adding message attributes. So with that, that's a choice for you to think about how you're going to decide if you want to use this event bridge or if you want to use SNS. But luckily, you don't have to think too hard about it, because in the evening, you're going to be hearing from a serverless hero who's going to be talking about choosing the right messaging service for your solution. So yeah, so that's quite an interesting approach there. And then if you are trying to manage some kind of an orchestration workflow, rather than doing it using if else in your Lambda, consider using something like a step function. And always think about building synchronous architectures when it's needed. Don't just implement an asynchronous approach when you can easily do a synchronous approach there. So for example, if you have a simple Lambda function just fetching something or persisting something onto a DynamoDB table, you don't have to talk about converting into an asynchronous approach, because DynamoDB on its own offers you single-digit millisecond latency. So that's kind of a waste of resources if you are thinking of making it into an asynchronous approach. So yeah, so those are the kind of thoughts that I wanted to leave you with at the end of this session. And yeah, so if you have any questions, you can reach out to me on Twitter, or you can check out my blog, and you can connect with me on LinkedIn as well. So I don't think they are a bit visible. So that's something that must have happened when I was presenting it on the StreamYard platform. I'm not too sure, but yeah, you can connect with me on those socials if you would like to know more. So yeah, so thank you, everyone.
Okay, so Lakindo, thank you very much for sharing your knowledge on this conference. And although you are the youngest community builder in Sri Lanka, you have great knowledge in working with serverless, and I think it's really valuable to share your hands-on experience with others as well. So once again, thank you very much, Lakindo, for sharing your knowledge on this session. And with that session ends, we will be move on to a lunch break. So we had 3 sessions and 1 quiz so far. So you guys all can have a little break for yourself and have a snack and a drink. And please get back around 12:15. So we will be starting our next session on 12:15 sharp. It's also another interesting session. So a bit different from what we had so far. Guys, we will continue our conference from 12:15 onwards, and there will be 2 more quizzes coming up. So enjoy your break.
All right. Hello, everybody. So welcome back. I hope you had a good lunch and all ready for the second part of our Community Day session series. So quick recap from what happened from the morning. So we had our keynote by Derek Bingham. So he discussed about how to build the communities and what is the community builder program and how you can also enroll in it. That was a really good session. So you guys can also be part of the community and also be part of our AWS user group Colombo, Sri Lanka as well. And then we had Alex Debris, who did a deep dive session on DynamoDB. So I think it's super informative, and I hope you guys learned a lot about DynamoDB in that session. And then we had a serverless session. So Lakindu Hewasam, he's the youngest community builder from Sri Lanka. He did a fantastic session about serverless. So now after lunch, we would like to change gears and go for a security related session. So that will be done by none other than another AWS community builder. And he's particularly in the security and identity category. He's a tech blogger. So let me introduce our next speaker, Lahiru Hewawasam. He's the lead and the global security operations at Axiata Digital Labs. So I hope you guys will enjoy this session as well. So let me hand it over to Lahiru now. Lahiru, over to you.
Thank you very much, Manoj, for that lovely introduction. So let me share my slides and let's get started. So now, all right. So what we're going to do today is we're going to look into a couple of key aspects of security in AWS, right? And in particularly, like we'll be looking into zero trust. Now, in the recent times, zero trust has been a big buzzword, and AWS has been at the forefront of its innovation, and they have also adopted a lot of technologies to help customers adopt zero trust. So that's what we're going to talk about today. Now, a little about myself. I am Lahiru Hewawasam. I'm the lead global cybersecurity operations at Axiata Digital Labs. I'm an AWS community builder, a zero trust advocate, and a technical content creator. Moving on, what we'll cover today is we'll go into an introduction of what zero trust is, why we need zero trust, certain zero trust principles that we need to follow, the capabilities of the zero trust model, and how does zero trust look on AWS. And we'll be taking a serverless spin on zero trust and how you can adopt zero trust within your serverless deployments. So diving right into our session, what is zero trust? Now, the zero trust concept focuses its effort on securing and applying security controls based on identities, but while moving away from the perimeterized approach. So basically, it'll look into securing data without any boundaries. Now, why do I say without any boundaries? Now, that's because in the modern day, we have had a lot of changes to our work environment. Right? We've moved from the traditional office environment to working from home, or actually working from anywhere. So then a perimeterized approach is inadequate, because where do we define the perimeter? Is it your home perimeter? Is it the organization? Is it the building that you're in? That doesn't really work, right? And especially when you're moving to cloud, where do you define a perimeter? Is it the region or the service, right? So another reason why we want to integrate zero trust is that trust-based relationships can cause compromises. Because if you trust anything that is coming in from a trusted location, maybe your internal network range, right? An attacker can get into your internal network range and launch more attacks from that range because it's trusted, right? You might not have the necessary security controls implemented there, or you might have an exception there, right? So you got to think about all that. This also reduces complexity and costs for security controls because it actually streamlines the implementation of your security controls and techniques. Also allows businesses to innovate and use innovative technologies freely without any restriction. Because we have already established a ground of security or like a baseline, companies can come in and use innovative technologies. So if let's say our company wants to use AI or ML from AWS, they can directly come in and enable these services and run because the same sort of principles apply. Right? It's more like adopting the same principles into our technologies stack that we have at the moment. Next is enabling employees to access their assets from anywhere, right? Like I just said. Also, Zero Trust enables adherence to regulations with stringent controls such as PCI, ISO, GDPR, because the core component of all these standards and control or like regulations is stringent controls. And this is what we focus on while we're implementing Zero Trust. Next, we have our Zero Trust principles. Now, these are the 5 golden principles that you would need to know when implementing Zero Trust, right? Or this is what Zero Trust brings into your organization when we go on this journey. First of all, never trust, always verify. It's very important that you do this because this is the core concept of Zero Trust. Always verify each and every request that's coming in. Right? Make decisions based on transaction risk and not on network location, like we discussed previously. Right? Log and monitor as much as possible. So if you have logging and monitoring services such as CloudTrail, CloudWatch, enable them and use them. Right? Also, microsegmentation. Right? Don't have everything in one flat network or one flat subnet. Have them separate. Have them talk to each other through a gateway. Right? Also, finally, apply automation and orchestration to simplify routine security tasks, right? So that's also very important because it reduces the burden on the analysts and the staff itself. All these capabilities that we just discussed are summarized into this diagram, right? So as you can see, all the components that we just spoke about are split into 5 different pillars. They are identity, device, network, application or workload, and data. So what we're trying to protect are all these 5 pillars. And how we're going to do that is by gaining visibility and analytics, applying automation and orchestration, and having good governance. So that's actually a very important aspect of any security program. So that's something that we need to keep in mind. Here we are going to look into, I'm not too sure if you can see this properly, but let me see if I can zoom in. Okay, so I'm sorry for the small diagram, but here we are looking into a sample architecture of how a user will connect to our AWS resources, right, when they're working from home or from their office. Right? So here we are going to look into how the user is authenticated, how the requests are authenticated, and how we can actually go about exposing our legacy applications that we have in our existing environment to our users. Now, the traditional way of doing this is by using a VPN. Yes, that is correct. That is true. That you can do that. However, now, what if you don't have to actually expose the application via VPN, and what if you can provide a native web look and feel or like web approach when accessing these applications? So this is where AppStream comes in. This is where workspaces come in, right? So that's all the innovative services that AWS provides that we can leverage to easily expose our legacy applications securely to our remote workers or remote users. Right? Next, we have our traditional web applications that's mentioned on the top portion. So So AWS provides a vast range of security tools such as AWS Shield, AWS WAF, and AWS CloudFront for your security and CDN needs. So you can utilize all these services to actually have a more streamlined and secure way of exposing web services directly to the internet or specific regions, right? So if you look at the diagram in the middle, like this one, very closely, you can see that the EC2 instances, even though they are running the EC2 instances in one single subnet, but here we can have different security groups to isolate them from one another. So this is in the case that one is compromised, or one is left exposed. It does not affect the other EC2 instances running around it. Right? That's basically where we implement containment to make it easier for us to isolate EC2 instances or even control network access. Next, we have the EC2 instances fetching data from the DynamoDB table, which is actually authenticated and encrypted using AWS KMS and AWS Secrets Manager, Parameter Store, and all that. Right? We have additional security services that we use on a day-to-day basis to actually gain more visibility. So one of those services is Amazon Guard Duty. Amazon Guard Duty uses machine learning and a lot of advanced techniques to actually detect threats and alert our users or our engineers. Right? A cool thing about Guard Duty is where you can use AWS Lambda to perform automation. So AWS Lambda is actually a serverless service. I think Lakindu discussed it previously in depth. So you can use these services to actually automate our responses. So let's say if you want to isolate an instance, you can write a Lambda to actually perform the steps that you would in isolating an instance. Right? So stuff like that will actually help you in the long run to reduce the burden and to actually have a more reactive security team. So these are some of the services that are available from AWS to actually begin or start your Zero Trust journey. So on the top left corner, you have remote connectivity for users. Like I discussed, we have Amazon Workspaces, and we have AppStream. This is for exposing your applications to the internet without even having to directly expose the legacy application. So it creates a containerized and web feel to it. So it's easier for everyone to view and use the applications. It also gives the workspaces gives the users a desktop or managed desktop on the cloud so that they can do their work. So that's also something interesting that we can use. Next, we have external applications or exposing applications to the internet. So we have AWS WAF, Load Balancer, CloudFront, Shield, Route 53. So all these services can be used when you're exposing an application, right? You can also have your AWS Firewall Manager. That's also something that you can use. If you want to connect VPCs in between two accounts, but you don't want to expose them publicly, you can use AWS Private Link. For network access, while you're in the VPC area, you have VPC network ACLs, you have internet gateways that you can use, and also your basic security groups. In the middle, we have visibility and threat detection. Now, in my opinion, this is a very predominant area that we need to focus on, because threat detection and visibility will change our security architecture and the way that we actually respond to security events or incidents. Amazon Guard Duty, Amazon Inspector are two different solutions, right? Amazon Guard Duty actually talks about threat detection. However, Amazon Inspector looks at vulnerability management and vulnerability detection in your EC2 instances and all that. Next, we have Amazon Detective that is used during incident response and triage activities. Next, you have Amazon Macie. That's actually used for data classification and data discovery. And you have Amazon AWS Security Hub, which is your consolidated hub that connects Amazon GuardDuty and all that. However, it's not a fully fledged SIM. I would say that it's a cloud security posture management tool that you can actually utilize to have a top-down view of your resources. So like I said, identity plays a huge role in Zero Trust. Therefore, we can't forget IAM, directory service, and Cognito. They are the backbone of the identity that AWS provides, or the identity service that AWS provides. So we will look into how we can utilize them in our Zero Trust adoption. Right? Again, encryption at rest and as the data is moving via the internet plays a huge role in keeping our data safe. So for that, we can use AWS KMS, Secrets Manager, Cloud HSM, and also sometimes AWS parameters too that is within the AWS Systems Manager. Like I said, log management is actually a crucial part when it comes to Zero Trust and security as well. So AWS CloudTrail, CloudWatch is essential tools that you can use. Couple them with SNS or EventBridge, and you have yourself a different solution that you can use to actually get alerts. Again, run automated responses using Lambdas and other automation techniques that you can use. And AWS Config. So AWS Config gives you a top-down approach of your resources, and it actually helps you track the compliance of each resource that you have. So let's say if you want to have all your S3 buckets, but you don't need to have public access. So you can have an AWS config rule that actually looks at your S3 buckets and gives you an alert, or maybe even performs an auto remediation action whenever someone were to expose an AWS Amazon S3 bucket publicly. So stuff like that is very intuitive and will help ease the load on your security team and your basically your compute team. Right? Automation, AWS Lambda, and Systems Manager is your go-to tools. So we'll discuss how we can use all this further down the line during the presentation. Next, so what we'll do now is we will look into how Zero Trust can be applied using these services that we just discussed, right? So we'll split the 5 pillars, and then we'll look into how each pillar will look like in Zero Trust. So first we have our identity pillar. So the best practices for implementing Zero Trust, or like a good starting point, is to use single sign-on where possible. Right? AWS recommends that you use single sign-on using your corporate directory. So mostly it'll be Active Directory or Azure AD. So you can use that, or you can bring your corporate identity to AWS rather than maintaining a dedicated AWS IAM user. Right? Also, next we have a saying, always create roles for specific use cases. Right? Don't share roles between Lambda or maybe even 2 Lambdas. Have different roles defined so that permissions aren't shared between them. That will actually reduce the attack surface and the capabilities of that Lambda, even during a compromise, right? Do not share roles or users. Like I said, do not use the root account for anything other than your maintenance or like your billing activities, right? Use separate accounts for different use cases. Now, if you have use cases such as management, security operations, have different AWS accounts. Don't use the same account to configure all these services. So that's something that is very crucial. Always provide least privilege access, right? So if a Lambda only requires to read from a DynamoDB table, only provide that access. Don't provide write or any other access that is there, because that will significantly damage your security posture. Also, whenever possible, configure permission boundaries, because this will actually stop any additional permissions from being given to that specific role or IAM role, right? So for this, you can use SCPs or service control policies. That's actually something that you need to look at while you're talking about the identity and how you can actually improve these aspects. So next we have our device category, or like your device pillar. Right? So devices are notorious for getting compromised, and especially with this remote workforce, this extends the threat landscape. Now, what can we do? We can either give them VPN access or legacy VPN access, or do something very innovative and expose legacy applications via secure services such as workspaces or Amazon AppStream. By doing this, you're not directly giving access to the AWS resource. However, you're providing a graphical interface for the user to work. However, the device doesn't really directly interact with the service itself. So that in that way, you're creating a gap between the compromised workspace, compromised device, and your actual resources. Also, something that I would like to highlight is IoT revolutionizes the tech industry and also introduces new challenges. So AWS has its own way of dealing with it, which is the IoT Device Defender. So you can actually use this to have secure gateways and all that. So that's also new technology that is being introduced at the moment. Network. Now, the network is actually the underlying backbone of any service, right? Securely exposing applications is crucial, because if you expose a legacy or a vulnerable application, then you're asking for trouble and you're asking for attackers to actually breach or compromise it. Now, a compromise might not mean a huge deal, but in the large and organization scales, it is a significant. It will have a significant impact, because it can mean you'll have to pay fines or regulation fines in such cases as well. So when you're exposing these applications, you have to provide adequate protection, right? So this is where AWS Shield and AWS WAF comes in to actually protect the payloads and the services that are being exposed. Also, only expose what is needed. So if you only want the web application to be exposed, only expose those specific ports and not the entire set of ports, right? Ensure private connectivity between VPCs. Don't actually expose the VPCs publicly. If you have VPCs and if you want to connect them privately, don't expose them publicly unless absolutely necessary, right? Next, we have the application and workloads pillar. So with AWS, it's very easy to do all this. However, customers must remember that they have to protect their own applications. Just because you're running your application workload on the cloud or your EC2 instance on the cloud doesn't mean that AWS provides security for your applications. You have to provide that for yourself. This is where AWS provides these services. Now, Amazon Guard Duty is a great way of detecting breaches or detecting security incidents to help identify data breaches, right? Also, implement cloud security posture management. This is something a lot of companies overlook. Just because they secure their EC2 instances doesn't mean that their Amazon account or other Amazon services are secure. So utilize the services such as Amazon Inspector or Amazon AWS Security Hub to actually give this added security or added benefit. Right? Another point or another key aspect that I usually see is users tend to overlook regional services. So, for example, what do I mean by regional service? Now, let's take Amazon Guard Duty, for example. If you have Amazon Guard Duty running in US East 1 region, right? That service only detects threats for the specific region. You have to apply that to the other regions that you're using. Just because you enable it on one region doesn't mean that the service is automatically doesn't mean that it's automatically activated on the other regions. So that's something that is very important. Next, we have data. Basics come first when you're dealing with data. Ensure that the data is classified. This is where Amazon Macy will come in to actually detect and classify your data on your S3 buckets. Ensure the data is encrypted. You can use the AWS KMS or AWS Secrets Manager to actually handle the keys for these encryptions, right? Also, when you're using S3 or any other service, only allow what is necessary, right? What I mean by this is only allow access that is absolutely necessary. Let's say if you have an S3 bucket that has public access, but you only need access to a specific region, ensure that you can only give access to a specific region rather than exposing everything publicly, right? Also, if you don't have to have public access, don't have public access. Have internal access, right? Also, another pitfall that we see some of the times is do not hard code secrets within your code. It might be easier, but utilize AWS services such as your secrets manager or parameter store to actually store these secrets and fetch them during the application runtime. Next, we have visibility and analytics. In my opinion, visibility and analytics will change your security game. If you have log collection enabled, that is a great start. So enable log collection as well as analytics. So log collection is one thing. However, if it actually enables you to analyze and gain more visibility, that will change how you look at the data that is being collected. Right? Enable all traffic is monitored. That's crucial because you need to know what is going on with your infrastructure at any given time. Right? Configure metrics and alarms. Right? You can use CloudWatch alarms or CloudWatch rules to actually enable all these alarms for a specific threshold, or maybe even certain histogram and all that sort of stuff, right? So use these services to gain visibility so that you know what is going on within your infrastructure, right? Next, we have, hold on, sorry, yep, there we go. Next, we have automation and orchestration. Again, you can create automatic remediation based on the alarms that you have configured. However, you have to enable, you have to ensure that there are no false positives when triggering automation workflows, because that can cause a whole lot of operational issues if you trigger a workflow for a false positive alarm. Let's say if an EC2 instance is not really compromised, but if you isolate it, that's going to affect your business. Right? So please make sure that you have no false positives when running workflows. Next, and the last slide for the pillars, or the last pillar, is governance. Ensure security compliance. Right? You can use AWS config, AWS Amazon Inspector to actually enable security compliance. You can use these services to adhere to a specific compliance. Maybe that's GDPR, PCI, or maybe an ISO, anything, right? So use these services to actually audit all your resources so that you have a uniform compliance across all your AWS resources. Also, enable security best practices using AWS config. There are a bunch of predefined rules that you can use. Utilize them, right? Like the example that I just gave, the S3 bucket being exposed publicly. You can use those predefined rules and customize them to your needs. And audit resource configurations, right? That is automatically done using these two services that I just mentioned. Also, you can utilize AWS Audit Manager to make things much more fluid and easier. And another cool service that AWS offers is AWS Artifact. If your organization requires a certain compliance from AWS, you can directly head over to AWS Artifact, and they will have a list of certifications and regulations that AWS or specific services adhere to, right? So that's a repository of all the necessary documents that you will need to actually present to your auditors or whoever requires these compliances from you. Now that we've actually gone through the whole traditional EC2 related or maybe like service related zero trust pillars, we'll look into a bit more specific approach to serverless and how you can apply zero trust on serverless workloads. Like I said, these principles are more or less similar, so therefore you'll see a lot of them repeating. However, this can also be used with other components. So first of all, we have identity. Implement the least privilege. Right? If a Lambda or DynamoDB requires specific access, only grant that access and nothing more or nothing less. Audit and remove unnecessary permissions using IAM Access Advisor. It's very important that you use the tools and services that are there and that are actually available from AWS, right? So IAM Access Advisor is one of these tools where you can actually view all the permissions that are granted for a specific role and remove them if they're not being used on a daily basis or if they're not even used at all. You can also use Access Analyzer to generate specific role permissions. So if you don't know what you need, you can actually give a specific permission that you think is necessary, and you can use the Access Analyzer to actually create a specific role for you based on the consumption or based on the utilization that the Lambda basically did, right? Set up permission boundaries using service control policies where applicable. It's very important, like we discussed. Always have a boundary where your roles are capped at so that they don't get any excessive permissions. Use roles instead of long-term credentials such as access keys and usernames. So without having dedicated access keys, you can have a role instead so that they can elevate their privilege when they need to do a certain task. Create single-purpose functions with dedicated IAM roles. Right? Don't have a function don't have a role that is used with multiple functions. Right? If you have a specific function that performs, let's say, a put action against your S3 bucket, have that specific role defined rather than sharing that role amongst a lot of other functions that may have S3 access, DynamoDB access. Don't do that. Have a specific role for each function. Next, we have the network aspect. So use AWS WAF to inspect and protect against web-based threats. So AWS WAF will inspect any inbound connections so that threats will not get in to your Lambda or whatever service that you're serving. Create private API endpoints when public access is not required, like we discussed. Always limit the access to external entities. Use security groups to control outbound access of a Lambda. This is something that we don't really see being done. Always use security groups to restrict outbound access. Use network ACLs to restrict access to the VPCs and whatever the components that are there on the VPC. Again, audit Lambda VPC logs. So this is automatically done by AWS Guard Duty, Amazon Guard Duty, because it actually looks at the VPN, DNS, and other logs for its analysis. Always use an API gateway to perform basic validation of API requests. It's very important that you don't serve unauthenticated requests. You need to make sure that you authenticate all the requests before it even comes in to your service. So these are some of the miscellaneous or other aspects that you can consider when you're implementing or when you're going through zero trust with serverless functions. you can ensure that you must ensure that your code on the Lambda is not vulnerable. So you can use integrations such as SNCC to detect code or open source dependencies. Use AWS Secrets Manager and parameter store to prevent hard coding secrets. Audit the use of these secrets. That is something that we don't really see on a enterprise level, because there can be so many keys or secrets that are being used. So audit these secrets to identify misuse. If you see something that is not actually there, or like if you see an anomaly, raise it and investigate further, because that might be a compromise of sorts. And also rotate secrets frequently. And this is very interesting, because if you use AWS Secrets Manager, you can actually do this automatically for AWS native services. However, if it's not AWS native services, then you might have to go ahead and rotate them manually. Right? So now let's wrap this session up with some key takeaways that I would like to impart. Never trust, always verify. That's the foundation of zero trust. So always make sure that you verify every request before allowing them. Never allow explicit access. Always ensure that always ensure that explicit access is not granted. Always ensure that there are siloed access, right? Ensure that each component supports each other, right? Don't just go and enable services. Don't just enable services just for the sake of enabling services. Make sure that you have a sound security architecture when you're doing this, and have a streamlined security model. See that we have a question from MJ Zone. Hello. Is enabling WAF a good set with a good set of security rules sufficient for serverless? Yes. So if you're exposing a serverless instance such as Lambda, so I would say WAF is a good starting point. However, don't stop there, right? You got to protect yourself against DDoS and always have restrictive controls, even though you have WAF protecting your HTTP requests, right? Also, so it depends, right? So parameter store for secrets or secret manager. Now, parameter store and secrets manager are two different things. However, they can be used to achieve the same goal. In this sense, if you have more AWS native services, it's best to use secrets manager. However, if you don't have a lot of AWS native services and such, and if you have a lot of parameters that you manage, then parameter store is a good option. And I think I've seen a recent article from Jan that will be speaking today, who has actually considered both of them, considering the cost aspect and the usability of both the parameter store and secret manager. So that's a good article that you can read. Yeah, but basically it depends on what you actually use these tools for. Yeah. So one final word that I would like to leave with is zero trust is not it's not simple. It's a technical journey. So if you find yourself implementing zero trust and you find yourself coming across a lot of challenges in changing the way that things work, that is expected. So focus on the little goals and small victories, and that's how you build on to the zero trust journey. So always keep innovating, and yeah, always adopt a lot of new features and technologies as well. That will help. Okay, so if you use another question, if you use CloudFront in the front of the don't forget it. Yes, so I would need to check on that because I'm not too sure about the default configuration. But yes, I think CloudFront gives you a certain level of DDoS protection when you apply that. Need to get back to you on that. Okay. So yeah, I think done with the session now.
Thank you very much, Lahiru. There is no doubt that security is one of the most important aspects in modern day applications, and traditional security measurements are going obsolete. I think this zero trust approach you discussed is something new to most of us, and I believe we found it very interesting. Once again, Lahiru, thank you very much for joining with us today and sharing your knowledge on security and identity with us.
Thank you very much.
Okay, guys, moving on. We have our second quiz coming up. And to be clear, so this is the separate quiz, but it is a part of our quiz tournament. And we will be selecting an individual winner for this quiz as well. And all the marks you scored from the previous quiz will be accumulated toward this one to find out who is the winner of the quiz tournament. Okay, guys, so let's wait a couple of minutes until just guys join now. If you are not registered yet, you can register using the link, which will I post in the chat again. Yeah, so you can see the link right at the bottom of your screen. So until you guys are getting registered, then we have some updates for you. So this is the first day of our AWS community, AWS Day, Sri Lanka 2022. And tomorrow we have another exciting day planned for you. And tomorrow we will have a serverless workshop, which is conducted by serverless hero Manoj Fernando. And there you will get the chance to get hands-on experience and interactively work and build something of your own. It is a great chance to brush up your knowledge on serverless. And if you are new to serverless, you can also join that session and learn how to work with serverless. So it is a beginner-friendly workshop. So you can go to our meetup page and get registered there. I think there are a few spots left yet. It is on first come first serve basis, so don't be late. Try to get registered as soon as possible for that event as well tomorrow. All right, guys. So I think now we can start our second quiz. The starting time has already passed 12:55. And this time you will get 20 seconds to answer the question. There will be 10 questions, and same as the previous, you have to be correct and fast to answer the question to get the maximum point of the question. Okay, guys, so now we will start the question quiz from our end. Okay, guys, so now you should see the leaderboard of the quiz, and the first question will appear soon. This time we are seeing few different names at the top of the leaderboard, and there is Vinay Prashant. I remember he's got the third place in the previous quiz as well. Okay, so now the leader of this quiz is currently Dureksha Vasala, and we have really close competitors in the second and third place. So now we are up to the seventh question of the quiz, and still Dureksha Vasala is leading the leaders board, and we have few changes in the second and third places respectively. So we have the last two questions, and it seems Dureksha Vasal is building a quite big lead from the rest of the group. Let's see how it goes in these last two questions. So guys, we are into the last question of the second quiz. So far we have Dureksha, Mohammed, and Makrendran in the first three places. Let's see how this finishes. Okay guys, so that marked the end of our second quiz. As you can see, Dureksha Vasala, you are the winner of the second quiz of AWS Community Day 2022. And our team will contact you through the email you provided when you register for the event. And with your gift and asking the details, we need to send you the gift. And we will post an update about the overall leaderboard in our LinkedIn and Facebook pages soon. So if you haven't followed them, go ahead and quickly follow those two pages, and we will be posting an update there soon. So we have a few more minutes left till we start our next session. So we will be back in sharp at 1:50 with our next session. So until then, we have an exciting session coming up. So until then, keep with us, guys.
Welcome back, guys, after the short break. So, our next session is conducted by an individual who is the leader of the AWS Auckland user group. He is also an APN ambassador and works as a lead consultant at CMD Solutions Auckland, New Zealand. The session mainly focuses on serverless architectures and provides insight about the good, bad, and the ugly serverless use cases and the patterns to ensure your serverless applications are built to last. So, please welcome Geetika Guruge for our next session. Thank you. Over to you, Geetika.
Hey, thanks, Trana. Thank you. So, cool. So, hi, good afternoon, and welcome to the session. And I hope you are all comfortable in front of your screens and had something for lunch, and hopefully not sleepy. Hopefully. Anyway, so I'm Geetika Guruge, and I work as a consultant for APN partner called CMD Solutions, and based in Auckland, New Zealand. A bit of a background about me. So I started as a software engineer back in the day, like early 2000s, and to be honest, at that time I knew nothing about infrastructure. It was always someone else's problem. But then, being through all these buzzwords like Agile, Scrum, DevOps, and eventually cloud. So my day job right now involves helping people to either migrate into AWS or architect their workloads to be more cloud native. And also, my main passion is around serverless technologies, and of course, I believe a day where we can make no ops a reality. But that's of course a discussion for another day. So let's move on. And so today, let's take a bit of a look around some of the goods, bads, and about serverless architectures, essentially. And we'll start by looking at how we evolved into serverless at the first place. And then let's talk about why serverless is good, or in other words, like why people should move to serverless. And then, of course, we'll take a brief look at some of the limitations in this paradigm. And then the main part of the presentation where serverless can get really ugly. So we'll be taking a look at some of the anti-patterns here. And as I said, this will be the main part of the presentation, if you ask me. And then finally, we'll wrap it up with a few parting thoughts. So how did we get here? I'd say it's a bit of an evolution, and this is by no means a comprehensive history lesson, but then just setting the context, of course. So back in the day, the system administrator would prepare a physical server for software to be deployed, and this would involve installing the operating system, associate device drivers, making sure that there was enough memory, disk, and processor available, and installing any prerequisites and things like that. They would also take care of hardware upgrades and so forth. So this is known as a bare metal environment. And there's a strong coupling between the physical hardware and the deployed software here. And the key factor here is that the unit of deployment was an actual server. And then we moved on to virtual machines. So now, instead of deploying right into a given piece of hardware, developers were able to target a simulated server. This led to lots of flexibilities with upgrades and migrations, as well as like not having to worry about small hardware variations and things like that. This, of course, made deployments a lot more repeatable and flexible, and it also enabled, say, system administrators to begin decoupling software from hardware. So now, if there was a hardware failure, sysadmin could migrate the virtual machine into a different hardware, so then they could avoid issues. And sysadministrators could also host more than one virtual machine on a given physical server. However, virtual machines still had some limitations and overhead. Say, for better or worse, they pretended to be an actual server. What that means is, like, if you log into a virtual machine, you would see the OS, and you would have control of the OS. So you would still believe that you are in a server, and this wasn't always needed. And the key factor here is the unit of deployment was the virtual machine. And then the follow-up from the virtual machines was the containerized deployment. So this is when various containerized platforms or technologies like Docker and things were born. And these technologies enable sysadmin to section off an OS to have different applications running on the same system, so without them interfering with each other. So it also led developers to have a lightweight environment, so that closely matched to the production environment. So this led to more consistent operations between environments. And additionally, a lot of tooling has been developed to ease creating and maintaining these containers. So many companies use these to improve their development and deployment cadences. And the key factor again here is the unit of deployment is now a container. So then we came to the serverless paradigm, so which promises to give us another layer of abstraction, which is the code itself. With this new level of abstraction, so we don't need to be concerned of where our code is deployed or hosted. We just write our code and deploy it, and then we don't worry about the underlying infrastructure. So that's how we came to serverless. And then we move to the next slide. So here you can see how this evolution has helped developers to focus more on the actual business logic and of course decreasing the concern of underlying infrastructure and deployment configuration. So now that we have the option of building serverless, why should we? Or rather, what's so good about this, right? So is it just another buzzword? So one of the biggest reasons to move to serverless is that it gives me on-demand infrastructure. So I don't have to keep running a server to accept that one single request I may or may not get, right? And I can simply deploy my code in a Lambda and then be assured that when a request is finally received, my code will execute. And then, of course, the money factor. So yes, the cloud in general, you pay for what you use. But if you are running a server for 24/7, then you are paying for that server for all the time. But with serverless architectures, you will only be paying for the time that your code is being executed. And of course, for the number of times you call your function and things like that. So, and then of course, like there's no AWS presentation is complete without that reference to undifferentiated heavy lifting. So what it really means is that you have abstracted out all the underlying concerns. Your team has more time to focus on improving your code, what matters to your company. So those generic tasks, such as taking care of the servers and keeping them up to date, patching them and things like that, will be taken care of for you. However, but in my opinion, the biggest motivation for the serverless architecture is that overall developer experience it gives your dev team. So now you can be certain that your development environment is as same as the production environment in terms of underlying infrastructure and things like that. So that's what's good about it. And then, so it's so great, right? And then let's move everything to serverless. But not so fast. As with anything, it has a fair few limitations as well. So to start off with, like you've got timeouts. Say Lambdas, that's the main serverless component we'll be talking in this presentation. It has a 15-minute timeout. So of course, it has come a long way from that 5-minute timeout when it was introduced in 2014, if I'm not mistaken. So there is a fair bit of an improvement, but still the bottom line is you have to be absolutely certain that your code will complete its execution under 15 minutes. And given that you'll be writing single responsibility functions, by nature, your overall architecture will get complicated too soon. So we will see what I mean in the next few slides when we talk about those anti-patterns. But then, yeah, it gets too complicated too soon. And another headache of building Lambdas is that dependency management. So any common libraries would need to be packaged with the individual Lambda, so which is a terrible and inefficient way of managing code. There are some improvements in this area, such as like you can use Lambda layers, and then now you can use container images for Lambdas. But the bottom line here is that it can get out of hand if you don't plan for it properly. And the single biggest downside for Lambdas, in my opinion, is that not all workloads are stateless. So ideally, you'd want your Lambda to be stateless, and any state-related data should be externalized. But in the interest of performance and efficiency, and there are some use cases, you'd much rather maintain that within your code. So in these cases, Lambdas may not be your best option. So now that we've looked at the good and the bad sides of serverless, so let's dig into some anti-patterns, or rather where it gets really ugly. I've seen this implemented at numerous places like big, small corporates, and in almost all situations, it was a hangover from that monolithic architecture they were trying to break apart. So let's look into that, and then so if I look at like name them, so that Lambda monolith, so I'd call it a Lambda lith, and then the Lambda as an orchestrator, and Lambda pinball, again, and invocation loops, and Lambdas calling other Lambdas, and synchronous waiting. So all these, like, and more importantly, we look at why it gets ugly, and also have a quick look at how we can fix them if we can. So the Lambda monolith or Lambda lith. So when developers lift and shift their code into Lambdas, so they end up writing that one big Lambda, which would take care of all the application logic. So this may be a good starting point, don't get me wrong, but very soon this becomes an overhead and it eats into your development efficiency. So as you can see, that the main downsides are like the package sizes, like that now your Lambda would do a lot of work. So chances are you'll have to package lots of dependencies together with it. And then comes the privilege issues. Right? So if you look at this example diagram given, so you have this Lambda monolith application, and it is writing to a DynamoDB table as well as a S3 bucket. So the IAM role attached to your Lambda would need to have permission to both S3 and Dynamo. So which is not essentially that least privilege, following that least privilege principle. So if you break apart this Lambda into two single responsibility Lambdas, then you can have IAM roles attached to those with single responsibility and with least privilege. So that permission issue. And then, of course, the usual culprits, the upgradability, maintainability, code reuse, and the challenges of unit testing, because you are not just doing one function, so you are doing multiple things in that monolith. So to avoid building a monolith or Lambda monolith, you can always split your application logic into multiple functions and have separate Lambdas to do this. So if you're writing a web application, for an example, so that bottom right-hand corner diagram, so you can, a good starting point would be to have separate Lambdas to handle different API gateway routes. So gets would be directed to one Lambda, puts and the deletes would be another Lambda, and things like that. So, and then the next one is using Lambda as an orchestrator. So this I've seen quite a bit over the years. And so if you take an example to explain this, say this is a typical order workflow. So you have a customer, it's placing an order, so we accept that order from a, say, API gateway, and then that would send the request into a Lambda, which is our orchestrator essentially, and that Lambda would talk to or notify the restaurant, and then the restaurant accept the order, and the system or the Lambda would notify back to the customer, and eventually the food is delivered to the customer. And if you want to maintain the state and also look into what happened to the orders down the line, so you would most likely want to have some records in the DynamoDB table or somewhere. So that Lambda would be writing every time something changes, Lambda would be writing to the DynamoDB table. So you can see like number of lines going to and from this Lambda. And this, mind you, this is even before you start considering payment workflows or any error handling logics or retry logics. So this gets ugly very soon. So we said writing your workflow in a single Lambda is a bad idea. So here's the same workflow, and now it is split into multiple single responsibility Lambdas. And I'm not going to go through all these 15 steps, but then the idea is it's the same workflow. Now it is split into multiple single responsibility Lambdas. And if you look closely, they are loosely coupled as well. So best practice, right? So they are talking about SQS, SNS, or event bridge. So looks great. But I would call this a Lambda pinball. So once you receive a request from the front end, it will be bounced around to various Lambdas, and you're lucky if you see some response at the other end. So imagine troubleshooting what happened to a hungry customer's order at 10 p.m. in the night, right? So That's not going to be fun. So this is where you can use step functions. So where you'd still write single responsibility functions, and the state machine is managed in the form of a easily readable JSON file. And you'll get that added advantage of rerunning the same state machine after a failure and black magic like that as well. So move to step function. So if you have a workflow, moving to a step function would be the right way forward. So the next anti-pattern we'll talk about is invocation loops. So AWS services generate events that can invoke Lambda functions, and Lambda functions can send messages to AWS services. So generally speaking, service or resource that invokes a Lambda function should be different to the service or resource that function outputs to. So that's a fair bit of words. So let's go to that example. So I have my Lambda function, which gets triggered through an event, and then it puts an object into the S3 bucket. And then that same Lambda function is configured to be triggered of an S3 event, S3 put object event. So it gets triggered again, and then it will put an object into the bucket. And now that another put object event is triggered, so the Lambda is triggered again. So you can see where we are going. So this essentially becomes an infinite loop. So imagine an infinite loop in a traditional application. So where you'll eventually crash your application with an out-of-memory error, right? But AWS is elastic. So your Lambda will automatically scale. And as any other service, it will write to. So for example, S3 have near infinite scalability. So it would happily execute this loop. And then at the end of the month, you'll get a bill shock. So in order to avoid such situations, so as I said before, make sure that the service invokes the Lambda is different to the service that the function outputs to. But then if there may be real use cases where you want to do this, like if you really want to do that, at least use a positive trigger. For example, in this case, using metadata of that put object event to trigger the Lambda only in the first S3 put object, not anymore. And also use reserve concurrency for Lambda. So then you can manage that scale, like it won't scale out of hand. And then, of course, use alarms, CloudWatch. So that is essentially observability. So that way you know when it happens. And also you can even automate that some circuit breakers there. So avoid invocation loops. That's the takeaway, I guess. So the next is calling Lambdas within Lambdas. So here we have, say, create order function, which calls a process payment function, which in turn calls a create invoice function. So while this synchronous flow will work within a single application on a server, it's a fair way of implementing that. But then in a serverless distributed architecture, this introduces some avoidable problems. Say, for example, cost. So your outermost function, that create order function, now runs for the entirety of your workflow execution, which is additional cost, which you really don't have to pay. And then obviously this makes error handling more complex. Say, for example, error in create invoice function would require you to maybe revoke a payment or reverse a payment. So that you have to take into consideration of that error handling logic within payment function and things like that. So also this introduces tight coupling. Say you can't easily change a contract of a downstream function without affecting the outer functions. And availability of your entire workflow is now limited by the slowest function. And then, of course, this limits your ability to scale as well, because that given the concurrency of all functions has to be equal. So that in a traditional server-based application, these limitations may be unavoidable. And you'd say it is what it is, like you're quite used to be building like that. But in a distributed serverless world, you don't have to do that. You can easily overcome these, say by decoupling the functions, say via queue or SNS topic or even an event bridge. So try to decouple functions as much as possible. And then the synchronous waiting. So this is the last sentiment we'll be talking today. So that is essentially, for example, in this case, we have a Lambda function which has two responsibilities. One is to write to S3 bucket, and the other is to write to a DynamoDB table. So if you execute them sequentially, the first action you write to the S3 bucket, and you wait for it to return, and then you write to the DynamoDB table, wait for it to return. At this point only, the Lambda would return. So your Lambda would be waiting for both those synchronous functions. That essentially that means you are paying for that whole time of that Lambda is running. So if these tasks are independent, you can run them in parallel. So this way, your wait time is just the time taken by the longest activity. That's essentially the bottom left-hand side of the diagram. So that is, so you have an event, your Lambda is triggered. It will, at the same time, it will put the object into S3 bucket and also write an item into DynamoDB table. And then you wait for the response. And once you receive the second response, which is the slowest function, whichever, and then you return the Lambda. But in case if you can't run them parallelly, if you have to run them sequentially, then you can move to an event-driven pattern, where which is the bottom right-hand side of the diagram. So that is, so you have an event, you action the first execution, which is to put object in the S3 bucket, and then your second Lambda, which has another single responsibility to write an item to DynamoDB, will be triggered off that S3 event. So you are essentially writing single responsibility lambdas and hooking them with event-driven architecture. So look into that. So I think so. This is what we learn. Like these are the key takeaways I'd like to you to take away from today's session. So the first is Lambda is not a silver bullet. So you can't use it to magically modernize your legacy code. You need to re-architect your workflows to make it cloud native and ideally event driven. And also, like I know we didn't talk about this much, but if you are going down the serverless path, treat observability as a first-class citizen. So in a traditional application, you'll have all your logs you can get in one single file, most likely. But and also the execution is sequential. But in a distributed serverless world, your execution is scattered, and then your logs are as well. So think about observability when you are designing a workload, that is from the beginning, and collect and manage logs, traces, and metrics really well. And finally, the serverless is not just Lambda. Yes, that's the mostly used development building block you would use, but everything from, say, API Gateway, SQS, SNS, Event Bridge, and even DynamoDB are serverless components at your disposal to build that next generation cloud native applications. So, and that's it, folks. Thank you. So, do we have any questions? Or?
Hey, Geetika. Thank you very much for the interesting session and very informative. And we have actually two questions. So one of the questions from Lakindu, what are your thoughts on patterns like topic queue chaining? Would you recommend it?
Well, I'm going to give that classic answer. It depends, right? So chaining is ideally you should try to avoid as much chaining as possible. So that's my personal opinion. But then again, depending on your use case, sometimes that may be the only way forward. But what I'd do is I'd look into if someone comes up with a use case and they think, okay, we want to chain topic queues, I'd look at it in a different angle, like why? Is there any other way of doing this? Say introducing, say, event bus or something like that. So it depends, unfortunately.
Yeah. Okay, there's another question. What are your thoughts about service-to-service integration and keeping Lambda with the glue code?
Yes, that's a good option because lambdas, like it or not, so it is that Swiss Army knife of AWS. Like whatever you want to do, any ugly work you want to do, chuck it on a lambda and run it. But then, if you have a service-to-service integration, I think you can avoid that lambda layer altogether, and then because that's essentially that's event-driven, right? So you have one service emitting an event, and if you can trigger another service out of that event, then why would you want another layer in the middle? So yes, if you have the option, I would go for that. But again, I think that solutions architect in me says it depends.
Yeah, like always, it depends on the situation, like about the variables that we need to consider. Yeah. Okay, are there any other questions? Yeah, so apparently there are no other questions. So thank you very much, Geetika, for that interesting session with those use cases and sharing your experience. Yeah, so thank you very much, and we hope to see you.
Thank you, and thanks for reaching out on this. And yeah, keep up the good work, guys. I'll be in touch. Yeah.
Thank you, Geetika. Thanks once again. All right, guys. So with that, I think our next session is scheduled at 2 p.m. So we have about 20 minutes for the next session. So I suggest you guys maybe grab a coffee or something. So we'll start the next session at 2 p.m., which is going to be another security session. So Arshad Sakaria will do another security sessions related to securing your network using AWS network firewall. That's an interesting topic, and we are looking forward to that. So until then, grab something, grab coffee or something, and we'll see you at 2 p.m. Thanks, guys. Hey guys, so welcome back. So before we move on with the SAC session related to security, I just want to give a quick update about the overall quiz status. As you all know, as Chamira mentioned, we are going to have 3 quizzes, and out of those 3, we had already 2 quizzes, and each quiz has its own winner. But I think you all are aware that we are going to choose an overall winner out of these 3 quizzes as well. So right now, what you can see in the screen is that leaderboard, that the overall quiz leaderboard. So we have Vinay, Prashant leading the board right now with 13 points, and then Imanta in the 2nd place, and Yasit at the 3rd place. So we are going to have one more quiz, guys. So it will happen around, let me see, around, so that will happen around 4:15 p.m. in Sri Lanka time or in IST. So super excited to have that quiz as well, and then we will see what are the changes in this overall quiz leaderboard. So without further ado, let me hand it over to Lahiru, who will give a quick intro about our next speaker, Zach. Lahiru, over to you.
Thank you very much, Manoj. So, let me turn some stuff on. All right. So, our next session is conducted by an individual who is an experienced cloud professional and an AWS community builder. Now, this session focuses on the security aspect of cloud networking and how the AWS network firewall plays its part in securing the cloud assets. So here to provide an intuitive insight and how it all works and some real life, real world use cases, please welcome Arshad.
Hi, Lahiru.
Hi there, Arshad. How are you doing?
To be honest, not good. I lost my voice after the reinvent, so I think too much party in Vegas. Yeah. Glad it's not COVID, but yeah, kind of cold and lost my voice.
Yeah, let's take it easy.
Yeah,
let's have
I
some
think
break.
I'm not the only one going through this now.
Definitely.
I heard a couple of people having going through the same year.
Exactly. So over to you, Zach. You do your thing.
Sure.
And all the best.
Can you share my screen?
Yes.
Perfect. Beautiful. Yeah. So hi everyone. I'm Arshad Zakaria, so aka Zach. So I am part of plenty of communities, Sri Lanka DevOps community and Singapore AWS user group, and recently I joined Wellington user group. So I'm located in Wellington, New Zealand, and I'm a senior engineer for Xero. There's a QR code. There are a couple of blogs, and I do my own podcast. If you want to listen, just go ahead and check anything about DevOps. Yeah. So today's agenda is like this. We are going to we are going to talk about network firewall. But before that, sorry, we need some few of the things to cover before we jump into the firewall. So I'll be going through each and everything. Like basically, I will be covering like overall because it's a deep area, a vast area of stuffs there already. But I'll be covering almost which I can within these 45 minutes. But if you need any extra like information, anything help, just reach me out. I'm more than happy to help. So yes. So the problem is statement, right? So when it comes to the AWS network, I mean the VPC, okay, if you're having a small business or a startup or a few couple of AWS accounts or a couple of AWS VPCs, is fine. You can easily manage. Yes, you can store everything in the code, or like IAC, and for the governance part and rest of things are very pretty easy because you will be having a couple of VPCs and a couple of other resources related to the AWS networking. But what about a complicated VP setup? What about the multiple VPCs in multiple accounts, like overall the organization? So you think it's easy? No, it's very hard to do that, because there are a couple of VPCs we can name it as, right? So we can have like internet-facing VPCs. We can have like intranet VPCs, which is like totally does not connect to the internet. I mean, like the internet gateway or net gateway, totally isolated from the internet. And we may have like hybrid VPCs as well. So when it comes to like multiple VPCs, it's very hard to manage it. Yeah. So multiple accounts, TGW peerings. So if you hear about transit gateways, so like interpreting with transit gateways, and maybe VPC peerings. I think some are still using VPC peerings, but I do prefer transit gateways, which is awesome. Yeah, very hard to manage it, right? And when it comes to governance and monitoring, you want to track like what's going through the traffic, and gets all the logs to analyze and check any of the vulnerable things are going through the network, because network is one of the key pillar in your entire infrastructure. And you may think, okay, so we have security groups, we have NACLs to manage this, right? So, but right, there's a limit numbers of security groups and rules you can assign for particular resources. And you think managing security groups are easy if it comes to like 100,000 nodes, very hard, right? So these are the problems currently we are having. So, and let's see how we can rectify these things using the network firewall in the latest slides. So as I mentioned before, this is kind of advanced topic we are going to talk about. So I hope if you have like a prerequisite knowledge about like regarding VPCs, transit gateways, route tables, VPC endpoints, AWS infrastructure overall, like basic knowledge, and firewalls and rules. So, but don't worry, I'll try to explain much as I possible to simplify it. But later on, if you have a question, I'm more than happy to help. So let's talk about the AWS private link, which is the technologies behind the VPC endpoints. So this diagram you see, right? I hope later we'll be sharing the slides, so you can click those links and go and check the resources. The right side, there's a VPC endpoint services, and the left side there's VPC endpoint. So what this mean is, okay, let's assume you have a software application, and you want to provide this application some maybe an API endpoint or something like that to via a private link without the internet. You want to share with it like a private network within AWS. Then you think it's easy to setting up multiple TGWs, multiple peerings. So it's bit not manageable, right? The long run. So this is a good service which can use, like you can have a NLB up front and set up a VPC endpoint services to top of that. And you can allow your, for example, a B2B, business to business, your customers, AWS account to allow these access these endpoint services. And basically you can allow your customers to access the services which you're providing using a private connection using the VPC endpoint. So this one does not need any related peerings or TGW, so it's very easy to configure. So before we go to the network firewall, it's really we should understand what is a gateway load balancer. If you haven't heard about gateway load balancer, you can check the link later. So basically, this concept basically came to the market mainly for the appliances, like other vendors, like mainly for security vendors like Trend Micro, Palo Alto, Fortinet, you name it. Like there are so many vendors in the market. You can find the AWS marketplace. So I'm just telling, I'm just giving you the names, but I'm not paid for those things. Like, so yeah. So how this gateway load balance is working. So basically, front of the gateway load balancer, basically again it's a there's endpoint, like we mentioned before, and so gateway load balance is a single entry, and it's a single entry and single exit point. You can see the diagram. So it's same entry, it's entering, and the exit all same. So it's doing this Geneve encapsulation for the traffic packets, and it's going to the application. Maybe, okay, let's assume we have a network so let's assume we have a firewall, a third-party network firewall, which is managed by any other vendor, or maybe your own one. You have your own license, and you're setting up in your EC2 instance, and you're setting up this gateway load balancer to in and out. So basically, this will use network interfaces in AWS, and it's very easy. So once it's done, you would basically set up your route tables and basic things, you do in VPC route tables, and the subnets are going in and out traffic. So you can basically managing it. So this is our gateway load balancer, how it's work. So why this important? This very easy to scalable, since this will be running on inside EC2 instance, right? So you can set up scaling, and so you can reduce some cost. So this is just think as it's a EC2 instance front of the load balancer, but it is a gateway load balancer, which will be working as a single entry and exit point for your network traffic, and mainly using by appliances. So there's a link between AWS network firewall and the AWS gateway load balancer. That's why I was mentioning about the gateway load balancer before. So basically, it's powered by AWS network firewall is powered by AWS gateway load balancer. The same technology is using, but the key difference is we don't have to manage the firewall or anything. AWS is managing everything like infrastructure, but we have the rights. We have the access to manage the firewall rules and the policies in the firewall, but the infrastructure level, with the computing and stuff, we don't have to manage it. So when you deploy the firewall, you have to mention that what are the subnet you're gonna, how many subnets you want, and how many available zones you're going to deploy. So it will create each and every available zone with an endpoint. So if you have if you want to have like a 4 rounds, and you want more than 2 endpoints for redundancy purposes, so you can deploy for 2 available zones. So you can make sure that, okay, you have once a backup. And what are the key difference between these two? I mentioned before, AWS gateway load balancer, you have to manage your infrastructure and your what are the appliances you're going to use, your EC2 instance and stuff. But AWS network firewall, Amazon is managing those things. So what's a network firewall? So it's pretty simple. It's a firewall, obviously, but it's managed by AWS. So very easy to deploy to your account. And if you have multiple accounts, you can easily deploy. There are multiple deployments methods are there. I'm not going to cover all the methods because it's a very, very vast area, as I mentioned. It's like a long page of the documentation available in AWS Docs. There are so many methods of deployment methods available to deploy in a way. So I'll be covering one of the demos. So it's basically, I'm going to explain how it's working. So yes, so what are the traffics like, right? Okay, your TGW traffics, and you have VPC to VPC, the traffic is traveling, and your egress traffic, like the internet, if you want to, the traffic is going out and in, right? So those things you can monitor here, and you can put some rules if you want to block or allow, or you can count. You can set some other rules, like all the logs are stored in CloudWatch, so there are events you can trigger. So you can build some alerting mechanism, or remedifying, if you want to remediate some rules to block these things, so you can automate it. So it's there are so many open areas are there. So mainly network firewall, right? It's OSI layer 3 network, and 7 is application traffic filter. If you're familiar with OSI layers, you know what are these layers are. As I mentioned, network layer and application layer, right? So traffic filter like SSH, ICMP protocol. Those protocols, like in the network layer, you can monitor, allow, block. So we'll be doing a demo later. I'll show you how to block and allow those things from that protocol. And from the application layer, it's pretty awesome. You can block specific domains. For example, in your network, you want to block some of the mining domains, or some other unknown websites. To you want to block some vulnerable sites, you can just block it. Or else you can go other way. You can allow specific URLs which are only allowed by your security team to use inside your network, and block rest of the other URLs. So that way, I think it's pretty easy to manage. So you know which are the URLs you want. And for example, if you're building a content image, or you're running npm package, so there's a specific multiple URLs are there to pull. So which will really help to monitor these things. And there's so many things can be done. And the special part which I love is most like more number of rules. So when you're talking about security groups, there are very less numbers you can manage, and it's very, very hard. But here it's very easy to manage, and there are so many number of rules we can use, specifically what you want. And it's inspect traffic between VPC. So inbound, outbound, intra traffic. It will do the inspection. And you can get some manage rules. So later I'll show you, like we have a couple of rules. So one thing, like we can add our own rule, or else some other vendors, like I mentioned before, they give on the rule set, not the entire appliance. Make sure the rule set. So the rule sets we can buy from the marketplace, and sorry, we can set up in a network firewall to use those rules. So that's pretty awesome, right? And I must mention one thing here. As I mentioned, it's these firewall endpoints are working at one entry and one exit point. So it can be in a middle. If you for example, if you're setting up in the same VPC and the same subnet or same availability zone, you want to put everything together, it won't work. Like you have to separate the this network firewall VPC in a separate VPC. So make sure it's in the middle. It can be a source or destination. It should be in the middle. It's because it's the traffic will go through the firewall. So few more things, right? So this doesn't support few things, like the network firewall. Sorry, my slides got messed up. Sorry for that. So how the network firewall works. So high level, you can see this this diagram here. So you have something called some policies and some rule groups to the run through these, whatever the what we call as a rule engine, to filter your traffic. And the firewall will connect to TGWs, your VPN gateways, direct connect, so on. What other sources are coming from sources and the destination. And this one supports by AWS Firewall Manager. So one single entry point. If you have multiple firewalls, you can manage those things. And the best part, right? I love logs. I love digging. So you can ship the logs to the S3 or CloudWatch. Then after that, if you have the logs, you can, if you are using any other third-party vendors for logging, log analytics, you can use this S3 bucket or CloudWatch, create a stream, and you can export the log. So that's pretty awesome. And sorry, I was going to mention before, this AWS Network Firewall does not currently support DPI, so which called DPI deep packet inspection. So for encrypted traffic, right, it doesn't support, like, obviously. It's I had a couple of scenarios previously, so we had discussion with the AWS team as well. So currently it's not supporting. If you're looking for something like that, it's not ready. It's clearly mentioned on their website that it's not supporting for the DPI. And yes, so this is the main hierarchy of the firewall, how it works. So it's basically simple. You have source and destination. You have a rule engine. So whatever the traffic is coming, it's inspect, block, or allow, and it will monitor, and it can be sent to the logs will be shipped to somewhere else. Fine. So this is a single AZ setup, how it's done. You can see the numbers, right? Yes. So yes. So you see from the number one, the workload and the protected subnet. You can see in the the bottom one, you can see the protected subnet. I hope you can see, right? I think the slides are very small. I'm so sorry for that. So okay, the bottom the subnet block, which is the protected subnet, and there's another one called firewall subnet, and we have internet gateway ingress route table. So basically, what will happen always when the firewall receives any any traffic, right? So the route tables will basically, what will happen, you see the route table and the bottom route table, it will the 0000/0 means any traffic, it will send to the VPC EID. VPC EID means VPC endpoint ID, which is the VPC endpoint of the network firewall. I'll repeat again because it's a bit confusing if you're not familiar with route tables much. So whatever the traffic, it's going to the out of the the internet or any other traffic it's looking for, which is 000/0, it is going to the VPC endpoint ID. So basically it will go, that means of the VPC endpoint of the network firewall. So the network firewall will do all the magic, the rules. So later, the next slide, I will go deep into that rule part, because I divided into two slides because it's a bit confusing. So this is the network hierarchy. I will go to the rules later. So the network firewall will do all the magic, like what are the packet filtering, or like what are things going on in the network. And so in this case, it won't go to the internet. Then the firewall subnet what will do, it says, okay, now it's filtered, done. So this guy wants to go to the internet, so it's sent to the internet gateway again. So once it's back, so it's basically the route table will be what will happen. It will again send to the you see, right, the top internet gateway ingress route table. So the private IP address of 10.0.0.0/24. What will happen? It will send again back to the network firewall, and it will filter again, and it will go to the specific destination. So basically, if you set up this network properly, there's no any loopholes. Wherever you go, it should go through the firewall. So no worry. Later on, I have a big slide to show. Like I have designed my own diagram to make it easier to understand. But just understand, if you have an instance or any resources, it will go through the network firewall using the endpoints and through the route tables. And when it's returning back the traffic, it will go back again to the AWS firewall through the route tables and going back to the instance. So this is the inspection part, like I was mentioning. So in the middle, you can see the rule engine, right? So see, the computer subnet instance, the firewall subnet is there. So basically, incoming packet, it's in rule engine will inspect and pass it to the instance. Again, outgoing packets, it will inspect in the rule engine, it will pass it. So when you go to the rule engine, the third block, you see, right? If you have like stateless engines, like stateless rules, will it check whether drop, or if not, what I do always forward to the stateful. So it will check whether the rules are okay. Can we pass it? Yes, then we'll pass it. If not, it will drop. So it's basically a yes and no. With the rule sets, like a flow chart, it will check whether it's comply or not. Then it will drop it, or just it will send it. So let me explain again. What will the rule engine does here? And incoming packets, it will filter through the rule engine. If it's okay, it will pass. If not, it will drop. Again, the outgoing packets, it will inspect and check. If it's okay, it will pass. And if not, it will just drop it off. So it's a demo time. I think I have enough time, hopefully. So this is very small, but don't worry. I have my Lucid chart. I love Lucid chart. Okay. So before I zoom in, I will explain you here. I hope everyone can see it. Don't worry about the text. I will zoom in when I was explaining. So in this left side, right? So basically, this is an AWS account, which I call my dev account. So nothing much. We have EC2 instance. Is a name it as a private subnet. So the CIDR is for 10.1.0.0/16. That's for our dev account. And there's only one VPC there. So I have my infra account. Infra account, I have a couple of VPCs. So this is my app VPC. So the app VPC is like 10.2.0. So remember, right? Dev app VPC is like 10.1.0. This is 2.0. And let's go to the root table later. And we have egress VPC. And we have inspection VPC. So the firewall is deployed in this inspection VPC. And we have one TGW setup, transit gateway, because I want to peer my VPCs from here to this account. So let me walk through a scenario. Okay, the dev account machine wants to access this app VPC in the infra account. Okay, so let's join with me. Let me walk through the root of it. So this root table, right? This workload subnet, it wants to access some of the URL there, but let's assume it knows the DNS name or the IP address of the our app subnet of the infra account. Then we have a rule: any address, please go to the TGW ID. So TGW ID means TGW attachment of the this account. So go to the my dev account quickly. One more thing, I'm using this TGW, and I have shared this TGW with this account. There's a thing called RAM, Resource Access Manager. So you can share using your TGWs using that one. So go to the VPC. I'm so sorry about my voice. It's very hard to talk. Sorry. So this is a shared one. So see, it's a different account ID. I have a different account ID. It's basically my infra account ID. So I have a TGW attachment. Okay. And which is here. So basically, if I go to my root tables, so this is my TGW attachment. So basically, which is the one I'm attaching here. Okay, so let's go. So this EC2 instance want to access that traffic. Okay, if it's following, so it will go to this TGW, right? So this is associated with this one. So what will happen? We have two transit gateway route tables. Okay, so this is a bit confusing to most of the people. If you're new to TGWs, don't worry. Basically, these are not the route tables we're talking about here. These are TGW route tables. So this one is associated with this inspection route table. So let me go to that one. So inspection route table. So this is one of the attachment here, which is this one. So so it's associated here with this route table, and it routes to here. So basically, this attachment is, if I open it, you'll see it's a firewall inspection VPC. So what I'm trying to say is, whatever the traffic is coming here, it will check here, and it's looking for some address in here. Okay, some 10.2.5.0 something. Let's assume like that. So whatever traffic comes, it asking the inspection VPC to, it asking this the route table to send the traffic to the inspection VPC. So here, okay. So inspection VPC. So it's attached to this another route table, which is again 000. So I know there are so many routes are going here and there, like kind of a ball passing, but it's how it works. It's checking. Okay, I know I want to go to now this particular IP address. So where can I looking for? So this route table is telling, okay, you can do that, but you have to go to the VPC endpoint, this AZ ID. So which is basically this network firewall endpoint. Okay, then endpoint is taking that, like we talk about the rule engine. It's everything is done. Then firewall route table will try to now send the traffic back. Then it will ask, okay, I am looking for this IP. At least now can I go? Okay, no worries. Now go back to the TGW ID. So this one is now associate with this firewall route table. Okay. Now I think most of you guys already got it, what I'm trying to say now. So it will check, okay, 10.2.0. Oh, it's app VPC attachment of the infra account. Okay, 2.0. Oh, where is it? Okay, here. So the traffic will come here. So see, right? There's no any chance it can miss it, because it's enforced the security here. You see, right? Nobody can escape. So it has to go through that, or else it's dropped. Before I go to the live demo, I have 15 more minutes. So I will show another scenario, make it to understand for you guys. Now, this dev app server in the infra account wants to go to the internet. Maybe want to clone public container image from the Docker Hub. Okay, so it needs internet access. No worries, fine. So so first thing, it will ask the network. Okay, I want to access docker.io. So I want to clone some repo. So this route table is saying, no worries, you can do that. You just go to the TGW. Okay, so this one is associate with, we'll go this line. Again, we are coming to here. Okay, then again asking, okay, I want to access the docker.io. Okay, no worries, it's saying go to the inspection VPC. So again, same story. This person was telling, okay, I can help, but don't worry, just go to, we have to go to the security, like the airport security. We have to scan you. So just please go through this, and it will go through the firewall. Then it will ask, okay, go to the TGW again. So this person will take care rest of it. So it will come here, and you see here, right? The 00. So any IP that means of internet, it's connected to the egress attachment. It's basically which is my internet gateway and NAT gateway setup here. So any traffic, it's filled with NAT. So NAT is basically is going to the internet gateway. So here you see, right, I have mentioned here the 10.0008. That means if the incoming reverse traffic is coming from the internet, it should route through back to the whatever source back. So if the traffic is coming back again, it will go here, 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 and back to the same here, and here, 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 and here, and here. So see, right, it's the same like you're going through security, like airport security. You cannot escape. So if you're deployed like this way, I'm not telling you this is the perfect method to deploy, but this is a most simplest way I could explain, or I could come up with to explain this. So since we don't have much time, we'll go to show live demo. I'm in the infra account. So maybe later on we'll do another day how to deploy the firewall and see, right? Because without the basics, it's very hard to understand sometimes deploying part. So I think we can talk with Manoj and the rest of the group. We can have another separate session, like a 1 hour session, deploy and go deep dive. So this is my firewall, and still no rules. So later I'll be adding some rules. So this is like no firewall rules at all now. So if you see the firewall details, so you see, right, for US East 1A, I have endpoint created. So this is the endpoint I am using in my route tables to send the traffic in and out. Okay, so let's go to, I have a jump host. So this jump host is created inside, inside my public subnet, because I want to SSH it and I want to access it. So even though it's same, right, because if you're in the public subnet and if you want SSH, it will go to the same. If you're looking for some local IP address, again, it will go through here, here, here. It will go the same route. So it's also going through the firewall. So I'm going to jump into the jump host. Okay, I'm in the jump host now. So I think I have some. Okay, this is my dev machine IP, which is here. So you can see I managed to SSH into dev IP. Fine. And so my infra account IP, this one here, it's the SSH port. I change it to a different port, like 2222. The reason I want to show you guys, it's basically tracking the protocol, which protocol you're using. So I'm in there. So I'm going to just call and see, right, I'm getting a 200 here, so I can curl to Google as well. Nice. So let's close this session, and let's go to the firewall. So here, right, I was mentioning, so you can add manage firewall and unmanaged one. So manage firewall means if you go here, you have like AWS provided firewall rules are there as well here, and you can get some firewall from the marketplace as well. Sorry, it's a bug in the console. Let me go back. So I have two firewall rules here. Let me open one by one and show you. The first one, it's basically it's a stateful rule. Mainly what I'm trying to say is here, if the domain is .google.com, the traffic inspection can be HTTP or HTTPS. Please deny. Don't allow it. And the source ID IP should be like 10.0.0/8. I'm using the 8 subnet here, so it will cover my 16 subnets. And the other part, basically, I'm asking SSH protocol, any source, any destination, any ports, any destination port, any direction, action is drop. So any direction means like which direction, like so let's add this and see what will happen. So it will take some time to apply these changes, even though it's here. So let's back. EC2 console. I hope the rules are applied now. Okay, while applying, I will open the CloudWatch because we don't have much time. Sorry. So I have like one for alert, one for flow. So flow is basically like it will log all the flow logs, but I love this alert part. So today is Tuesday 6, right? Still no any logs. So this one was actually testing yesterday. Now let's going to jump into this one. And nice. Now we are going to SSH into the both instances. Okay, with port 2 and 2. You see, definitely will get a timeout. It's not connecting at all now, so I'm just canceling it. Nope. Fine. Okay, let me close it. Let's go to this one. Okay, while it's loading, I'm going to remove the block SSH one. It will take some time to, like it's not real time. So hopefully it will take some time to, oops. Okay, we'll come back to later logs. Let me SSH again. Now remember, we have the block, the policy. The rule group is for block the Google. Okay, nice. Now I manage to SSH it. And I'm going to go. Let's go first. Docker.com. Okay, you see, I'm 200 for Docker. Fine. For Google, which is supposed to block. So here, it's blocked. So it should be alerted in a while. So once there, so you can see here new log group created. So basically this one, oh nice. So here it's saying this source IP trying to access this destination IP. This from my jump host. This is the dev account IP because it's 10.1 using port 22. The protocol is SSH. It's even seeing the client, and it's awesome, right? So you have all this block of data, and here, see here, right? It's a port 22. Here it says port 222. So because basically it's the protocol is same. It doesn't matter which port you're using. It will block. You cannot escape. Let me check my domain log also here. Since I have 3 minutes, hopefully I can get that log here so I can show you guys. So I'm planning to write an article. Same thing since I set up this lab. I'll try to put more in detail, and if I try to do another video, I'll do it and share with you guys as well. So because I know you cannot explain this thing like within a few minutes, but I wanted to try a hierarchically what's its important, what are the important areas, and what are the resources you can get. So at least I hope you have some idea that there are some services like this in AWS that you can use it. I'll give my blog. Come on. I have 2 more minutes, no worries. I'm gonna wait till the log.
So, Zach, while we wait for the logs to populate, can we answer some questions?
Yeah, sure.
Awesome. So I think MJ Zone posted, hey Arshad, what are your thoughts about using VPC share to share subnets amongst AWS accounts? Do you see any security issues with the approach?
The new thing, right? VP sharing, right? So am I answer the correct question? The VP sharing option, right? Yeah. I mean, like, it's good, right? Because I think we should get rid of VPC peering. Personally, I believe it's my personal opinion. I think it's pretty old now. Yes, it helped us a lot. But one more thing, right? AWS Network Firewall doesn't support VPC peering. Sorry, I forgot to mention that. VPC peering doesn't support for this one as well. So yeah, it's a good option as well. But it's again depends on your requirement. Cannot say this is the exact thing because the cost matters as well. But go for the most simplest one and most reliable, most security. Yeah.
Awesome.
And I'm not a network specialist, so if you need some deep dive regarding this domain, I can get one of my friends or colleague to answer that. Yeah.
We have another question, Zach. If deep packet inspection is required, what are the other options available? Because I think you mentioned that.
Yes. If you have money, you can do it. Yes. That's why I was explaining about the gateway load balancer. So you can have your own gateway load balancer, and you can do that using, as I mentioned, other vendors like Palo Alto. Those providers are having these firewall services, but it's pretty expensive.
Not too sure if we have time, but can the network firewall be used for microsegmentation?
I'm not much familiar with that area, so you can contact one of the Palo Alto. I think they definitely help you, but I'm sorry. But if I can get that back to you, I'll get back to you.
No worries. Thank you very much. Much appreciated.
No worries. Because I'm not a network guy. I'm more into DevOps, but I wanted to show this because I thought it's very important part for today's session.
Very important, very intriguing as well.
Oh, where are my logs? Okay, never mind. I'm going to show the logs from yesterday.
Okay.
Maybe the connection is still live. No, right? I just exited here. Fine. Okay, fine. So I'll try to get my log yesterday. The domain. No, this one. Okay, here. So it's something like this. So the protocol TLS, right? So basically, I was accessing like HTTPS to access google.com. So it's saying matching TLS denial list. So FKDNS. So I denied this specifically to this google.com. So it's basically blocked from the firewall, and it's logging here. So that's I want to show. I don't know why that the log is not appearing there, but this is what I was like expecting.
All right, awesome, Zach. So
Yep.
that's like a pretty insightful
all.
session for like everyone who's watching. I mean, securing your network, I mean, that has to be really important these days, given the situation like with remote work and everything. So you need to have security enforced. So I think all the viewers out there would like greatly benefit from this session, and I hope that everyone will take home something from this. And yes, like it was a pleasure to have you on this event, and thank you for joining with us.
Thank you.
All right, awesome. Bye, Zach. All right, guys. So that was a nice, interesting session from Zach. And next up, we have a really special guest who's coming to speak about choosing the right messaging service for your serverless workloads. So we're gonna have Yan Shui, who's gonna be who's a serverless hero. He's one of the very first serverless heroes. In fact, he's been a hero since 2018, and he's also a developer advocate at Lumigo, and he's also running his own business, and he's also a serverless consultant in that. So he's a pretty serverless guru. So he's the guy to learn from. So over to you, Yan. So yeah, I'll just add you onto this stream now. Okay.
Thanks, Lakindu. So let me share my screen. Oh, hold on. Try capturing the screen. Oh, sorry. Some screen sharing permission issues, I think.
All right, no
give me 1 sec. Let me. I might have to restart Chrome or something to give you permission to my screen sharing. Just 1 sec. I'll be back.
No.
Okay, so I think now I should be sharing. Can you see my screen? Yes, okay. Can you see my screen now?
All good, yeah.
Okay, cool. All right. Yeah, sorry about that. And thanks everyone for joining me on this talk on how to choose the right messaging service for your serverless workload. So back in the day, I studied computer science at university. And one of the things that I really sort of kind of enjoy learning was about data structures. You get taught about things like the big O notation and the difference between what is an NP problem versus an NP hard versus an NP complete, which are skills that I haven't really used since I've gone into my professional career. But what it did give me was a framework to really think about software complexity. So if you look at fast forward today, I've been using AWS since 2010. And as mentioned earlier, I'm a developer advocate for Lumigo, and I spend half my time doing that. And the other half of my time I spend as a independent consultant, where I help other companies adopt serverless. So in my sort of line of work, on a day-to-day basis, I work with a lot of different AWS services. And I strongly believe that understanding how all of these different services work is just as important as understanding different data structures and knowing when to say use an array versus a linked list. And event-driven architectures is a pretty hot topic these days. And the key word here being driven, because our application, they are built in such a way nowadays that it's going to do something useful when it receives an event. Now, the event is the thing that's going to drive our application to do something, to do what we want it to do. And this question is that, okay, what do we use to receive these events and what do we use to send these events? And as far as AWS goes, EventBridge is kind of the king here. It's kind of the de facto choice you will have when it comes to building event-driven architectures. And Event Bus in the event architecture is the heart of the event-driven architecture. It lets us, keep the publishers and the consumers of these events loosely coupled, thanks to the fact that you can do content-based filtering with EventBridge. And nowadays you can do that with SNS as well. They've just announced that before reInvent. And so you can have consumers decide what events they care about and listen for those events without having to constantly ask the publishers to please add some attributes to your messages and so on, as was the case with SNS previously. But if you zone out of your architecture for a second here, your application may be made up of many different services. Each one of them has got its own domain, and they're sharing information about what's going on inside the application with each other by publishing events to EventBridge, and then the consumers would react to those events that have been raised elsewhere. And if we were to look into one of your services, you may see that this whole event-driven sort of business is a business logic is also inside this particular service as well. But for different kind of workloads within your services, you may have slightly different requirements in terms of the things that you're going to need to capture and trigger your business logic. You may have different functional requirements. But sometimes you also have non-functional requirements as well. For example, you may need first in, first out to make sure that the event for an, say, e-commerce order is processed sequentially. Or maybe you need the ability to replay events, which may be the case for an event-sourced system where you make a bug fix and you need to replay the previous events to get to the correct current state for a user. And you also have to think about some of these non-functional requirements, like how does your choice of messaging service here affect the scalability and the cost of your application. And these are all important things that you have to think about in the real world. And because AWS offers quite a few different messaging services that can all kind of do the job here, these are just a few of the services that come to mind. There's also other things like MSK, the managed Kafka service, as well as Amazon's ActiveMQ, and maybe half a dozen other services that can all act as the hub that receives events and then forward it to consumers. And I think in general, knowing how to pick the right AWS service for your workload is a very, very valuable skill to have. And it goes back to the point I made earlier that AWS services are the new data structures, and you need to know how they work, when to use them in order to get the most value out of AWS. So for the next, say, 20 or 30 minutes, let's do some mental exercise and think about how our choices are going to affect our application. And for the sake of simplicity, I'm just going to focus on SNS, SQS, EventBridge, and Kinesis, because these are the most popular messaging services in AWS. And we can start by thinking about how our choice of the messaging service is going to affect our scalability. And when it comes to scalability here, we have to consider the scaling constraints on the messaging service itself. And I think the best way to master that is just to Google, say, EventBridge quotas or SNS quotas or whatever service quotas, because AWS has done a pretty good job of publishing for each service the different quotas, and you have a separate documentation page with some explanation for what each of these quotas mean, as well as the default values you have for each region, and whether or not those quota values, those default values can be raised via support ticket, or if you just go to the service quotas console in your AWS console. So for EventBridge, for instance, the most relevant quota for scalability is the number of put events requests that you can make per second per region. And this page is going to tell you the default limits, what they are by region. And once you've got a sort of decent understanding of the relevant quotas that you need to think about for the service you're using, you can also go to the service quotas page in your AWS console, which is going to tell you the current value for your account. And you can also make a request in this console here to raise the quota value for your account as well, so that you can raise the number of pull requests you can make per second, and so on against the EventBridge. Besides understanding the constraints, the scaling constraints for the messaging service itself, assuming that you're building serverless, you're using, say, Lambda functions to receive events from EventBridge and then perform some business logic, you also have to understand how the messaging service is going to interplay with Lambda's concurrency and how that's going to scale with throughput. So if you put the Lambda concurrency and the message per second on X and the Y axis, then things like SNS and the EventBridge, which invoke Lambda functions asynchronously and with as much as parallelism as possible. So if we were to publish say 100 messages to a SNS topic concurrently, then it's going to try to create 100 concurrent Lambda invocations to handle those 100 messages, so there's no batching, and the concurrency is going to grow linearly with the number of concurrent messages that the SNS receives, which can be great if we're after maximum throughput for our application. Whereas with SQS, on the other hand, concurrency is controlled by the number of pollers that the Lambda service is going to run on your behalf, which starts at 5, and you can only go up by 60, so adding 60 more pollers per minute when it needs to scale, because there's more messages coming into the backlog, up to a maximum of just 1,000 concurrent pollers. So with SQS, the concurrency of your function is going to go up much more gradually compared to SNS and the EventBridge, partly because you get messages that are batched, but also because the concurrency is limited by the number of pollers, which only grows by 60 per minute. And then you've got things like Kinesis, where by default you have one concurrency for every shard. So the concurrency is going to go up in the pretty discrete steps. Basically, every time you add a new shard to the stream to handle more messages, then it's going to add another one unit of concurrency for the Lambda subscribers. And for those of you who are not familiar with Kinesis, basically with every shard, you can ingest up to 1 meg of data or 1,000 messages per second. So you can handle a lot of messages with a fairly small number of shards. But you can actually configure this nowadays with the event source mappings to allow up to 10 concurrent Lambda executions for each shard. So that means you can process messages quicker. And the nice thing is that it also guarantees the records inside the shard are still processed in order at the partition key level. So it's quite a nice feature that allows you to increase the parallelism without sacrificing this first in, first out ordering. So depending on your setting, you can actually increase the Lambda concurrency and how quickly it goes up as you add more shards using this setting. And usually being able to control, being able to use more Lambda concurrency to process messages faster is a good thing, except when it's not, because sometimes we do need to control the amount of concurrency we're using, because we have Lambda functions that are infinitely scalable, but then we may be talking to some downstream systems that just can't scale very quickly or to a very high degree of concurrency. So imagine if you're using SNS and we receive the batch of messages, and then SNS creates a whole bunch of Lambda invocations because the Lambda scales up automatically, which is great. But then all of our functions are now talking to some downstream system which can't handle the load. And so any sort of extra or excess traffic the downstream can't handle is going to come back as an error. The good thing for us is that as an async invocation, we also get the built-in retries. So all of these failed invocations is going to be automatically retried later on because that's just what you get with Lambda and async invocations. So chances are they will eventually succeed with the retry. However, if your spike in traffic is now sustained over a longer period of time, so even if you got retries, those retries are just adding more traffic later, and they're still going to error because it's more than the downstream can handle. So eventually we're going to exhaust the maximum of retries, and then eventually we have to use delta queues to capture those events that we just couldn't process, so that we don't lose them forever as well. And this is where, in the case of Kinesis, the behavior is quite different, because any spikes in traffic that we experience is going to be amortized and they'll just be processed later. So whatever maximum throughput we can process based on the number of shards we have and the concurrency we configured per shard, and therefore there's only going to be so many concurrent Lambda executions happening at the same time and talking to the downstream system. So we can essentially create this maximum throughput for our application so that it doesn't exceed what the downstream can handle. So any spikes in traffic that we experience will just be amortized with Kinesis and the settings that you use. So in general, if you're looking for maximum throughput, then you should consider using things like SNS or EventBridge. But if on the other extreme, you want precise control of your concurrency, then you should consider using Kinesis instead, where you can control the Lambda concurrency with the number of shards as well as the concurrency per shard. And in between, you've got a spectrum of other services that scales up the Lambda concurrency at different kind of speeds as the throughput goes up. And you got things like DynamoDB streams that goes up a bit more gradually, and then the SQS goes a little bit faster, but not quite as much as something like SNS or EventBridge. So you can really kind of manage the concurrency that way. But with Lambda, there's also another mechanism you can actually use to manage the Lambda concurrency, or at least the maximum concurrency you want to use. So if you use Lambda's reserve concurrency on the function, you can limit how many concurrent executions you can have for a particular function. So this is a really useful option to have when you have, say, maybe one or two functions where you need to sort of worry about this because they're talking to some legacy downstream. So you can use reserve concurrency, which also acts as the maximum concurrency for a given function. But because reserve concurrencies are taken out of the available regional concurrency for all of your Lambda functions, so it makes them quite tricky to use broadly across many functions, because it forces you to kind of micromanage the concurrency for individual functions, and it's really easy for you to make mistakes and either over provision or under provision your reserve concurrency and leaving not enough sort of a pooled concurrency for the rest of your functions. So that maybe you allocate too much of the available concurrencies to one function, but then suddenly you've got a spike of API calls and your API functions doesn't have enough concurrency to scale into, and so they're going to get throttled and you're going to cause problems with your users that are trying to hit your website. So this is really like a solution that you can use for specific functions rather than a general strategy for all of your functions. So scaling, so that's the scaling, but usually you have to, when you think about scaling, you also have to think about cost as well, because the two often goes hand in hand. And when you think about cost, you always have to think about, you also have to factor into account the scaling that you expect to deal with, the amount of throughput you expect to deal with. because that's going to make a big difference in terms of what makes sense for your workload. So if you're assuming, say, you're sending 1 message a second for a whole month, this is roughly how much you can spend with each of these services. So in a low throughput scenario like this, where Kinesis is going to charge you a baseline in terms of shard hours, it can look a lot more expensive. And with nowadays, you can also, but that's with Kinesis on demand. Nowadays, you can also have Kinesis to the auto scaling as well. So you can use Kinesis. Sorry, that was a provision. You can use Kinesis on demand as well, which you don't pay for shard hours, but you pay for stream hours instead. And so if we add that to our sort of list, you can see how it compares with the others at this really low message throughput of 1 message per second. So it still looks quite expensive compared to the others, but expensive here is still a relative term because you're talking about $10 more, or maybe in this case, $20 more than the other services. But if we were to scale your throughput up to say 1,000 messages a second, then for a whole month, then things like SNS and SQS and EventBridge can become a lot more expensive quickly in absolute terms. And Kinesis is still a lot cheaper, even if with the on-demand mode is a lot more expensive now than the provision mode, because the reason for Kinesis being a lot cheaper is because the cost per million API calls is much lower than the other services, even if it's charging you a baseline cost for having the stream or having a certain number of shards. And that's a good rule of thumb to remember, that services that charge by uptime tend to be orders of magnitude cheaper when you're running at scale, but they can tend to be more expensive when you don't have a lot of throughput. And this is something that's very much on the minds of the engineers at Wauli, who's the national broadcaster in Finland. So I spoke with some of the engineers a while back, and they have this system for ingesting and analyzing over, I think, 500 million user interactions a day at a peak of about 600,000 messages per minute. So, fairly a decent throughput. And I spoke with Anahit Pogosova, who came on my podcast, and she worked on this particular system. Like the rest of her team, she's a big fan of serverless, but because of the amount of throughput and scaling we're dealing with here, they decided to use Fargate and Kinesis for this particular workload. Both of these decisions were driven by the throughput the system have to handle, and they have to do this in a cost-efficient way. And you may also notice that there's like SQS queue here is somehow in the mix. And the reason for that is here as a fallback, so that if Kinesis was to go down for whatever reason, they won't lose any events. The application would just push the events to SQS instead, and then process them later when the Kinesis is back online. So that gives me a nice segue to talk about error handling and the need to understand how the system is going to behave when something goes wrong. And one of the great things about using Lambda to process all of these events with EventBridge is that as an asynchronous invocation, you get up to 2 retries out of the box, and the support for delta queues as well. But the thing with delta queues is that they only capture the event that your function couldn't process, not the context around why they failed. So it's up to you to figure that out. And sometimes you have to go into your logs and search for the relevant log messages to figure out what failed, and therefore to decide if it's safe to reprocess a message from the delta queue. So you typically end up having to do a lot of work yourself to figure out what happened, which can be time consuming and tedious, especially when there's a whole flood of messages in the DL queue. So the Lambda team did something better. They nowadays they give you the Lambda destinations as well, which compared to delta queues, it's got some really good advantages in that it supports not just async invocations, but it supports stream invocations as well. So you can use it on the functions that are processing events from Kinesis and DynamoDBs, but it doesn't support SQS, which you have to use SQS's own DLQ mechanism. And it supports more targets as well. Besides SNS and SQS, you can also use Event Bridge and Lambda as destinations, which can be useful if we want to do some kind of automated recovery logic in the event of a failed message. But the most important thing for me is that with the on failure destination, it's going to capture a lot more information compared to the DLQ, which only captures the message payload itself. Whereas with the destination, it's going to tell you the payload that your function couldn't process, but also captures information about the invocation itself, the number of attempts, and more importantly, the error and stack trace from the last attempt at processing this event, which is going to help you save time from having to go into your logs and try to figure it out yourself. So that's why you should prefer Lambda destinations over DLQs nowadays, although it's possible for you to use both at the same time. But I haven't seen any use case where it would make sense to use both. So if you can think of anything, just feel free to let me know in the comments or in a question or a question box there. But the destinations are great. It has got some problems though. Take, for instance, if you've got a stream-based function for Kinesis, for instance, this is what the on-failure destination is going to capture. So you've got the request and response context, timestamp, shard ID, all that great. But what's not here is the payload body itself. Instead, you have to use the shard ID and the sequence number to go to Kinesis and fetch it yourself before the data is expired from the stream. And if this is the first time you see one of these messages in production, and you have enabled extended retention on your Kinesis stream, there's a good chance that if this happened over the weekend, then no one's paying attention until Monday. And when you come back, data has already expired from the stream, so you end up losing data unless you do something about it to either automatically fetch the data from Kinesis when you see this message, or you enable extended retention on the stream. Another problem is that, as I mentioned earlier, this whole mechanism doesn't even work for SQS functions, which you have to go back to relying on DLQs from SQS. It's its own redrive policy, which means you're back to not having any of those stack errors, messages, and stack trace. Have to look in your logs to figure out why the message failed in the first place, which again gives me another nice segue to talk about observability, which, depending on who you ask, you may hear a different definition. To me, observability is a measure of how well you can infer the internal state of an application just by looking at its external output, which can be the logs, can be any traces that you're catching in the X-ray or some other service, as well as any side effects that you expect the system to perform. So things like stuff being written to DynamoDB or payments processed in PayPal and so on. And within AWS, you have got a distributed tracing solution called X-ray, which I'm sure many of you are familiar with or at least have heard of. So to test how well X-ray can deal with some of these more interesting event-driven systems and the different kinds of messaging service we can use, I put together a quick demo project, which looks a bit like this, where you've got this API function that's going to kind of fan out the message to lots of different targets, including SNS, SQS, SNS and SQS, Kinesis, DynamoDB streams, Event Bridge, and S3 as well, to see whether or not I can actually see one trace in X-ray that captures all of this. And unfortunately, it turns out X-ray just not able to trace through many of these. So my one transaction from the user's perspective produced 6 separate traces. So I know they recently announced the support for SQS, but when I did this at the time, which was a couple of weeks ago now, I guess, X-ray wasn't able to trace through SNS and SQS. But I think that nowadays it might be able to trace through SQS for this messaging for this particular transaction. I need to double check that. But anyway, so in this case, you can see, my one transaction has turned into many different traces, which makes debugging much more challenging especially when you consider that X-Ray has got a pretty conservative sampling policy by default, so that anything beyond, I think, 1 request per second is going to sample them at the 5%. And so I think because of this and the fact that it's really hard to find specific traces in X-Ray means that most people still rely on their logs for debugging and troubleshooting. And it also means that you have to, when you've got this event-driven architectures, you have to have some solution in place to allow you to correlate the logs from different Lambda functions that are processing the user transaction as it goes through SNS, as it goes through Event Bridge, and then Lambda, and then say DynamoDB streams and so on. You have to figure out a way to do that yourself to get your correlation IDs across all of those places so that you can then find everything in one place. And I think that's where third-party vendors like Lumigo can add a lot of value. And for context, this is the same transaction that I see in Lumigo, where you can see all of the sort of components of this transaction is in one place and it's accounted for. And this includes all your SNS and Lambda functions and Event Bridge and DynamoDB streams and Kinesis streams and so on, as well as the SNS to SQS to Lambda, which again, until recently, X-Ray just wasn't able to trace. And I think Lumigo was one of the first vendors that supports this particular transaction. You also see this S3 thing just sitting on its own with Lambda. I'm not sure why that is, but apparently it's a bug in Lumigo and they know about it and working on it. But still, you can see that whole transaction going through Lambda to SNS, so to S3 and then back to Lambda again is still present in the transaction. The nice thing, though, is that you get all the logs from all the different Lambda functions side by side with the transaction diagram. So you don't need to do any correlation IDs yourself. You can just get all of them in one place so that you can quickly figure out, okay, as the message goes through from Lambda function to something else, this is what the logs is telling me. In terms of actually debugging and so kind of inferring the internal state of an application, you can click on any of the icons in this transaction to see the relevant, say for Lambda, the invocation event, the return value. The invocation event is useful here because I see so many functions with the first line being console.log, JSON.stringify events, because when you see the log message, you often want to see what's the invocation payload to get a context of why you see those errors. So with this, you don't need to log it yourself. It's always going to be captured inside Lumigo. You also see the return value, environment variables, log messages, and so on. And all of this is automatically captured. There's no manual instrumentation. You don't have to write anything yourself. And if your function is talking to other services like SNS, Event Bridge, and whatnot, you can just click on those icons in Lumigo, and it's going to show you the message your function sent and the response as well. So it does this for any HTTP request. And also if you use SQL and Redis and so on, and Mongo, you can also trace through those TCP requests as well. So in terms of being able to refer the internal state of an application, you can get that pretty easily with Lumigo. And I think the biggest value add it offers is the fact that there's just no need for manual instrumentation. So I don't have to change my code. Using the server framework, and there's a plugin that lets me configure Lumigo with my project with just 2 lines essentially to configure, to add the plugin, and then to tell it where the Lumigo token is. So as if you've seen, now it adds a lot of support for messaging services, a lot better compared to X-Ray, which is very useful for event-driven architectures. And nowadays, it's not just Lambda, it supports containers as well, but I don't really use containers, so I'm not the right person to speak about that. You can also just go and sign up for free. There's a pretty generous free tier. So all my personal project and as well as my client projects uses Lumigo because it just makes debugging so much easier. So going back to, we've looked at scaling, we looked at cost, we looked at error handling and observability. So ultimately, how does that help us answer the question of what messaging service you should use based on your workload? So when I was looking into this and trying to come up with something, it turns out someone else already kind of did most of the work for me. So I'm just going to give him a shout out here that Magic has put together a really nice decision tree which is in line with basically how I think about these services as well. Like you should use Kinesis for high volume messaging, and you should use EventBridge where you need archive and replay. And although I agree with pretty much everything here, I would probably describe the last step here slightly differently. So if I'm publishing events, and then I shouldn't have to care about, as a publisher, how many subscribers there are. And often when this question comes up, it's really asking if the message you're sending is a task or an event. And it's worth making the distinction here, because an event is you saying, hey, something happened and here are the details. Whereas a task is you telling somebody that, hey, please go and do this thing, and here's information you're going to need. So a task has a very specific recipient in mind, which is why you never have, say, multiple subscribers to given to one SQS queue, because when you send something to SQS, you are expecting some specific thing to be done by a specific component, not some random outcome based on who picked it up. And you often expect some answers back as well when the task is done. So you often see callback patterns here as well when you're using task. Whereas for events, the publisher really shouldn't have to care about who's listening, and my job is to tell the world that something happened, and that's it. And as Magic says here, this chart's going to give you about 90% chance to get the right choice, but there's still a lot of room in that 10% that's left over. For example, what if you need the first in, first out? And when is it ever the right time to use something like DynamoDB streams? So to help you sort of figure your way out in that last 10% of use cases, I put together this quick reference or cheat sheet for the services that we looked at today in terms of if they support ordering, batching, the pricing model, how it interplays with Lambda concurrency, and so on. All of these are trade-offs, but you can also think of them as different Lego pieces that can be combined together for great effect. For example, if you've got a use case that needs ordering, archiving, and replays, then and you want to maximize throughput, then and it's not super high volume, so you're happy to pay per request, then EventBridge is almost everything, but not quite. On the other hand, you have SNS FIFO, which is going to give you ordering by group ID, but it's missing archiving and replay. So what you could do is to combine the two of them together to get what you want. The question is, do you put SNS FIFO before EventBridge, or do you put it after? So if but unfortunately, both of these are actually wrong, because if you put SNS FIFO after, then you're going to lose the ordering when EventBridge forward the message to SNS FIFO. And if you put the EventBridge after SNS FIFO, then you're also going to lose the ordering when the message is delivered to your function. So the right way to do this, how I would actually do it, is by doing the in-ordering processing directly from SNS and then to FIFO, and then through SQS FIFO first, and then going to Lambda function, because you can't have Lambda straight from SNS FIFO for some reason. It's just, it's not allowed. So you have to go through SQS FIFO first and then a Lambda function. And for anything that doesn't care about the ordering, then you go through the second flow where SNS is going to FIFO is going to forward to EventBridge, and then you can then subscribe from EventBridge for any out of order processing. And then for you've got a high volume workload where you need batching and cost efficiency, then Kinesis is a great fit there. But as your Lambda function is processing those events from Kinesis, and you're making state changes, you can still, and you should still send those domain events to EventBridge to say, oh, I've changed a thing, I've updated the user profile, I've credited the user's account, so that other systems in the overall application can listen to those events and do something about them. And oops. And so other services, in your system can consume those events. And even though all of your services may have some kind of event-driven thing going on, and they all use different messaging services for their particular workload, they can and should still exchange and react to events happening elsewhere through EventBridge. And so at the heart of everything, you still have EventBridge as the heart of your event-driven architecture. And that brings me to the end of the talk, and I want to thank you guys very much for being with us. If you want to learn more about the building production-ready serverless applications, then check out my upcoming workshop, which, if you get it right now, also going to give you a free copy of my new course on testing serverless architectures as well. So again, thank you very much. And if you've got any questions, feel free to let me know, and I'm happy to pick them up and answer them now.
Awesome. Thanks, Aaron, for that insightful session. We have 3 questions that we would like for you to answer. So questions are from MJ Zone. Hey, Aaron, how does the Dynamo stream graph look like?
So if your question is about how it looks like in Lumigo, it will be basically just as an icon. So you see a Lambda function pushing to DynamoDB, and then the Lambda function will pick up the event, and so you see them as part of your transaction. So I hope that's what you were asking.
Okay. So let's try to squeeze in 2 other questions.
Sure.
Are there any scalability limits to DynamoDB streams?
Not so much scalability limits that I know of, but the scaling behavior is interesting because with DynamoDB, you have internally partitions, and the number of shards that you have in the stream is determined by the number of partitions, but you can't directly control the number of partitions you have in the table. Is automatically provisioned by the DynamoDB service based on the number of items you have, as well as the size of the table itself. So you don't have as much of control over how it scales the number of shards in the stream. A probably bigger thing to consider when using DynamoDB stream is that there's no extended retention. Retention is maxed at the 24 hours. So if you're using Lambda functions and you're using using Lambda function, you have to think about, okay, what to do when the on-failure destination captures events that you couldn't process. So you have to go back to the stream and capture them, or you have some way to log them yourself so that you don't lose those events. And also you're dealing with events that are DynamoDB events like insert, row updated, row removed. They're not domain events, so I don't think them to be particularly useful. The time when I use DynamoDB typically is when I've got, say, a function that normally have to write to DynamoDB and then do some other thing, which is a distributed transaction. So to do it well, I would probably have to do something like a saga pattern. So DynamoDB comes in very useful there, because that means it allows me to architect the distributed transaction out of the system by moving the second thing my function was normally going to do into the DynamoDB stream function instead, so that I don't have how to think about complicated fallbacks and recovery in my first function.
Yeah. Thank you. One last question before we wrap up. So, in high throughput scenarios, do you recommend Lumigo over Datadog?
I'm not sure about the throughput. Is really a big concern here. I'm pretty sure that both of them can handle that. What I would mostly focus on is just how easy you can debug your application using Datadog. I've used Datadog before. It's great for, I think it works a lot better for containers than it does for serverless for Lambda functions. And I had some concerns about Datadog previously in terms of the pricing model they had for Lambda, which is based on the number of resources you have on top of throughput and all that. Which I think they've changed now, so it's not as crazy with like $5 per function. So you got 100 functions, suddenly you're looking at $500 per month as baseline. So I will still look at just how well it actually supports you in terms of debugging, which I think at least for serverless workloads, Lumigo is still a lot better than the Datadog for my experience. In terms of cost, I also think Datadog just in general quite expensive. My last company we moved from Datadog to New Relic because even though it's a really large company, we still found Datadog to be prohibitively expensive compared to everything else. But they're very popular. There's almost no escape Datadog nowadays, unfortunately.
Okay, so Jan, thank you very much for that insightful session. Talked about Kinesis, Event Bridge, SQS, and SNS, and when to use all these other services. So I hope that everyone else found it insightful and took something out of this presentation. And once again, Jan, thank you for being with us.
Enjoy the rest of the event.
Thank you.
Bye-bye.
Okay, so moving on, we have another intriguing session coming up. Our speaker for this session is a seasoned veteran in creating enterprise data platforms on AWS and an AWS community hero who has significant contributions to the AWS community. This session covers building data lakes on AWS that are capable of scaling up to a petabyte level using AWS Lake Formation. Let's welcome Sanchit to take us through these concepts.
Hey, Larry. How are you guys doing today?
Pretty good, pretty good. We've had some intriguing sessions. Dying to hear what you can say, what you're gonna add.
Right. No, I was at the back end. I mean, there are fantastic lines of speakers. I can see that. So yeah, I mean, I'm really happy to be part of one of them.
So, Sanchit, why don't you just share your screen and then we can get started?
Awesome. Sounds good. Sure.
Sounds good.
Sure. Is my screen visible to you guys?
Let me share that up. Yep.
Okay. Awesome. So, should I go ahead?
Yes, Sanchit, over to you.
Awesome. Thank you so much. So, hello, everyone. Thank you so much for joining. I know this is a working day and this is a warm afternoon. We are right back after reInvent. Lots of enthusiasm around the floor for all the guys who are the fan of AWS that we just finished a pre-invent, and that is wonderful of announcements, I would say. I was privileged enough to be one of the participants for the reInvent. And yeah, if time permits, I'll talk about my experience. But yeah, for today's topic, we'll be talking about what exactly you have to do. What's the myth of data lake and why it takes a month to build data lake and how you can get out of that myth. And you can set up the entire data lake in days, not in months, right? So let's go hit our session right away. So today we'll be focusing about how you don't have to wait for months to build the data lake, but we can do it in days rather than. So when it comes to the speaker standpoint, I think organizers did a fantastic job about it. Let me quickly run through it. So my name is Sanchit. I work as a data analytics and cloud practice lead for AWS business at Quantify. From a recognition perspective, I'm an AWS community hero, AWS ambassador, MVP by Multi-Cloud for You, as well as an AWS user group whom I lead. Different speakers. I mean, I've given a talk across different. The best one, I've recently given a talk on modern data strategy, this year's reInvent. Along with that, I've also given a talk across different community days, user groups, as well as AWS Summit India. So if you have not watched any of the sessions, all of my recording I do ensures are there on YouTube. So please, you can log into it and go ahead and watch that after the session. Not now, after the session, please. And yes, you can follow me at LinkedIn, Twitter, and GitHub. I'm more active. Most of the people who are engaged with me, they know LinkedIn is the best place where I can help them. So if you have any questions about the session or any specific technical help, career-related help if you need from my end, I'm happy to help you guys. Please drop me a note on the LinkedIn. I'll try to get back to you as far as possible. So that's about me. When it comes to the agenda, I'll make sure that this 45 minutes is going to be very interesting for you guys, where you learn about data lake formation, different people who deals with lake formation, and as well as DevOps, which is a key thing on how we can have DevOps and data lake merged together. So if you don't know any of this jargons, don't worry a lot. I'll teach you right from A to Z in this 45 minutes. So please bear with me. That's what I'll promise you. So let's quickly start. We have lots to cover today. So let me quickly start around what exactly the data lake is. So if you go back, right, as per my role, I work with different customers. The customers across different industries, right? What I've commonly seen across each of these customers is they have this centralized database warehouse. This is a warehouse around which they do all sorts of their business decision making to ensure how their business is running, how they can optimize, what they should sell, what they should not, what should be the pricing, who are the people they're purchasing their products and all, right? So this is that becomes that database which takes care of all entire thing. Now what they generally do is they take all of that data, the transactional data from this system, and put this into this warehouse via ETL processes and everything. And then they try to run SQL queries or BI tools on top of that warehouse. This works fine if I talk about 10 years or 7 years, or I would say in the past, right? But nowadays, if you talk about the way things have been going around with social media, the different kinds of data we are analyzing and all, this architecture is going out of fashion because of three reasons. Let's understand what are those three reasons. Reason one, data no longer fits into the warehouse. We always think that our data will fit into the warehouse. So whenever I talk to the customers, like all the executives, CEOs, CTOs, they always have a perception my data will fit into the warehouse. But if you really ask to their engineering team, they will say no, data is not fitting. We are doing different cleansing cycles, different kinds of archival process in the backend. So data doesn't fit into the warehouse. It's just your mentality, thought process that it will fit into it. And it's not just a structured data. Now, if I talk about 10 years or 15 years ago, there was no social media presence. No one used to really do like image machine learning and those kinds of stuff, right? But now you're doing social media feeds. You're also having video feeds. You also do application logs, right? So you really try to unleash the true power of data. So data is huge. And if you really, any guys on the call, right? If you really go back and examine your storage layer, you will see there is an incremental increase in your storage by 10x every 5 years. Whichever industry you are, if you really go, even if you're a startup, I assure you there would be some other, if it not 10x, it would be 7x, or it will be more than 10x. On an average, you will see there is a 10x increment every 5 years in your data. So you can understand that what and which velocity we are consuming the data. So it's not going to fit into your warehouse anymore. Second, there are many more people who really wants to consume the data. So previously, as I talk about in the slide one, they were just the business executives who used to run SQL reporting, used to do BI on top of it, like tools, chart, Excel reports. Now it's not that the case. You will see machine learning engineers, you will see data engineers. There is a specific role called as big data engineers, data analysts, machine learning, product managers. These are the different people, personas who really wants to consume the data and get the maximum out of that data. Each one has a different role, right? Like as a product manager, I want to understand who are the people who are consuming my product, how I can make them more better. So you need to really understand that data. So that's why accessibility of data becomes very important. Not only that, along with accessibility, the medium of access also changes. Previously, you're running a SQL query, which used to work fine on the warehouse. But now you're doing a machine learning on top of it. You're doing a scientific analytics, complex algorithms which are running, right? Heavy compute driven. You're also doing real-time analytics like fraud detection you talk about, intruder detections, those kinds of real-time processing you are doing. So there are many personas, many people who wants to consume the data in a different form. So that's why, again, the traditional architecture is not going to work here. And the third and the important thing is more regulatory pressure. How you balance your compliance need along with democratizing the data. So as I start giving the access of my data across the organization to all of those different people who we saw in the previous slide, how we maintain the security and the compliances, right? So people who are very new, broadly, there are two major categories of compliances. One, which are very industry specific. Like if you are coming from healthcare, then things like HIPAA, PHI, or generally SOC 2, which is used in retail insurance. There are many regional things are also there. Like in EU, European countries, they use GDPR. They also have US, specifically West Coast, California, and all those states have started using CCPA. So there are many compliances also. So you need to balance between both, that you need to cater the data to your different personas, as well as you also need to handle your entire compliances, right? You cannot say I'm not going to handle one of them. That's not possible. So it is a tricky game to handle. And with one central system, it is much more impossible that you not only provide them different methods of accessibility, different personas, even scale elastic with proper security and governance. That's exactly where we see a need of data lake that comes into it, right? What people generally wants is a central storage. They really don't care what you do, right? They want one central storage, like how the warehouse is, which is cost effective, which scales, cater to different personas, provide different accessibility of mediums, as well as is cost effective. This is the 5 things what data lake provides, and that is one of the reason why world is really looking forward. Every customer, you're talking about startup or a mid-scale organization or an enterprise, they are all building a data lakes now. Where they are building a data lakes is a question, whether they are building on AWS on the cloud or they're building on premise, but they do have data lake. The only previous traditional data warehouse system does not suffice here. That's where you need to open up and go to the next level, which allows you to serve all of these 5 needs, right? So if I clearly read around what is data lake, and this is just a layman language, this is, I won't see a standard definition of data lake. I just want to make sure that you understand what is data lake rather than the technical definition. So data lake is a centralized repository that allows you to store all the structured, unstructured data and cater the data to different personas at scale, with scales and a cost effective way. So that's exactly what your data lake is. Now, what previously, as I mentioned, people were using the entire warehouse jargon. They moved out from this warehouse to data lake. What they started having this data lake perspective, right? So data lake used to filter all of these needs. It provides you relational, non-relational databases. It used to scale terabytes, provides different machine learning things around it, work on data without any data movement, and design for low cost. This were all we saw in the previous slide. And this is why we are using data lake, right? For many of the organizations, whether you are not directly being working on data lake or not, but you will see your organization is using data lake and providing all sorts of things. But the big challenge that comes is there's too many things what you need to handle. If you see on the right side, there are too many things. Like there is structured data, unstructured data, there is warehouse, data lake, cataloging. I mean, what are you going to do? I mean, it's very important for us also, but why can't we just simplify this? Why can't we just simplify and just ensure that it's just data processing or understanding or exploring the data what we do, right? So there exactly we saw a change which allow people to adopt data lake very quickly on the cloud. So previously, if you talk about data lake, building data lake on the traditional data platform, it used to take easily 6 months to a year on them, right? Still it takes based on the complexity, but for a simple data lake also, it used to take easily 6 to 8 months on premise, where you see a game changer when it comes to the cloud. If you saw in the previous session also, Jan mentioned very clearly that it's more of a Lego brick. Same is the fundamental of AWS. Wherever you go, whether you're going serverless, whether it's machine learning or data analytics, it's very important that AWS provides things Lego brick. So you don't have to build a heavy bulky system at day one. You can keep evolving over time and keep adding new services like a puzzle, Lego puzzle kind of a thing, right? So you can only build at the start. If you're a very small organization, maybe of 10 people want to understand the data, you can simply build like a very simple on-premise, like a data lake where you just consolidate all your data. You don't add any sorts of machine learning, QuickSight or EMR and those kinds of stuff, right? You can simply consolidate all the data and may only use Athena. That is also possible. And as you evolve, you move from Athena to Redshift, then you have QuickSight, SageMaker, and EMR, which can be an evolving journey, right? But the important thing what is how you focus to build a robust, scalable, and cost-effective single point of focus. So this single point of focus, which is the data lake, is more important. If you don't design your data lake properly, wherever you're doing, whether it's on premise or on the cloud, you're not design your data platform very effective. So it's very important that anywhere you go, whether you go on AWS as a game changer, they'll provide different services which will work very well if you have designed your entire storage on S3 as a robust, flexible, and it can scale. If you have designed something, like very simple example is, you would have heard something term called as partition of the data. If you don't partition your data itself, or you just keep storing for years and ages of data into one thing, it will not scale. It will there, but the query which will be consumed maybe by Rathina or Redshift or QuickSight will not give you the optimal performance. So it is very important that you fundamentally design your data lake, and then all of the other services at the top can be evolving in nature. But the game changer has been that with the adoption of cloud, data lake has really accelerated. So previously, which used to take 6 to 8 months, now can be easily built into 1 to 2 months. So that has been significantly reduced the cycle which is required for implementation of the data lake. But my question is, why even you want to spend a month or two, right? I mean, you want to just understand your data, consolidate data, understand that data. Why you even want to spend like 1 or 2 months? You're going to lose your business in 1 or 2 months, right? So that's exactly what we will be focusing here, that how exactly you can build this entire framework, what I just talked about, that fundamentally a very centralized, cost-effective storage layer, which is nothing but S3, consolidate data into S3 and can implement maybe Athena, QuickSight on top of it in weeks. But before we get into that, exactly what is that secret sauce looks like, or what is that service, let's understand that in order to build a data lake, what are the typical steps that comes up, right? Because that's how you will correlate once we go to the demo or once we go to that service which help us to enable. So overall, there are 3 steps, I would say: ingestion, cleansing, security, and analytics. So if you go back in the previous slide also, right? In the previous slide also, I mentioned one is the process of the ingestion, where you are getting the data from different of your systems, structured, unstructured, real-time data feeds, right? IoT streams. You get all the data and store into your S3, which is the centralized, your single point of contact. That is part 1. The part 2 is then how you secure the data onto the S3 bucket. That is step 2. And step 3 is this entire services, which is nothing but the advanced analytics, whether you query the data, you do machine learning, visualization, you do big data processing and all other stuff, right? So this is exact the 3 steps is: set up the storage, cleanse, prep, and catalog that data, which is nothing but organize the data. Then you apply the security based on different people and personas. You cannot allow someone, let's say an employee, to start going and querying the financial data of the organization, right? Or maybe the HR data, which includes the PI, I mean, sensitive information. So how you define the role-based kind of security. And third comes is the entire analytics, that how you do machine learning and advanced analytics on top of that. So these are the 3 steps. Do remember it: ingestion and cleaning, security, and advanced analytics. Now let's understand how exactly AWS lake formation help us. So that service which help us to build data lake very fast is nothing but called as a lake formation. So with the help of AWS services lake formation, you can fast track your entire journey of building the data lake in days rather than in months. Behind the scene, AWS has designed what exactly the lake formation is. If you, in the demo I'll show you, you are leveraging the same services. You're using S3, you are using Glue, if you want to use Athena or Redshift, you're using the same sets of services. Lake formation has helped us by templatizing and avoiding common of the things, right? Common of the process is what we do. Lake formation has helped us to automate that and help us to accelerate our journey. Like in terms of, let's say, how we can leverage machine learning based cleansing the data, how we can implement this security. Those all kinds of features and functionality lake formation provides in a single easy click, which help us to build the entire data lake in days rather than in months. So that's exactly the lake formation service is all about. And you will see that you will sense that entire thing what I'm talking about when we go into the demo in next few slides. But if I take the previous 3 processes what we have done and try to map with the people, like who are those people who will be dealing, right? Because when this entire demo, I want to really focus based on the users, right? Because processes are there, but processes are generally done by the users. So who are those users and how they will envision lake formation, which is more important? Because as an audience, someone would be from within your group, someone comes from a security background, some will be more data analyst, some will be more data engineer standpoint. So how exactly you will think the lake formation will help from your perspective? So there are 3 things which I feel, and there is 4th role also, but 3 things which I see is data engineer, who's responsible for ingestion of data, cleansing and transformation, which is nothing but the phase 1 what we saw in the previous slide, ingestion and cleansing. This data stewards. The data stewards is responsible for the security part of it. The third is the data analytics, a data analyst, which is responsible. Data analyst you talk about, or machine learning engineers, or data scientists, which are responsible for doing the advanced analytics. There is one more role which you will see, which is outside to this service, is a DevOps. I will have one more section talk about it, but for now, just to remember, there are 3 personas: data engineers, data stewards, and data analyst. Let's understand how exactly they will see the entire lake formation magic for them. So before we go into that, let's exactly understand how lake formation works, right? So in the previous slide, when it comes to the game changer, we understood that you can bring all of your data, your structured, unstructured, real-time data on S3 as a single layer. And we all know S3 is a very robust service from a nature perspective, highly scalable and cost effective. So by default, you already solve many of your issues. Then you can cleanse the data. You can easily cleanse the data, and you can build the entire, enable the data engineering perspective. Next, you can build a centralized thing. So now what exactly lake formation changes is, these are exact thing: the glue, the blueprint, ML transformation, data catalog, and access control. So these are the things what we need in terms of your entire stuff, right? So if I go back, these are the things what you need in terms of building your entire solution stack. Like you need your glue for processing, you need the blueprint of the glue, the workflow and all, some sort of an ML transform, data catalog, and access control. Now, lake formation has made it centralized. So instead of going through each service at a time, they centralized this, right? And recently they also announced more integration with it, which I'll talk about at the end of the session. So now you don't have to go, let's say, how I configure my glue data catalog, how I configure my S3 permissions, how I configure my EMR, or how I configure my Redshift spectrum. They try to consolidate all of that security in one go. So not only they're templatizing all sorts of other cleansing process, they also squeeze the security under one glass pen, right? Which makes it more easy that instead of going all of the services, ensuring they have been right or not, configured securely or not, you can do it right from the lake formation itself. That helps us to accelerate your journey. And at the last, you can enable all different services, which is discovery, analysis, sharing, and you can integrate all of those tools by different people and personas, which you will see in the demo, which will go. So all of these services will consume the permission given by lake formation and leverage the data which is stored in the S3. So this is how the entire working model will operate, which you will see in the demo itself. We'll try to ingest the data into S3, have lake formation, and finally have Athena on top of it. Now we'll move towards demo. And as I mentioned, I will try to break down the demo into 3 personas perspective. So the demo I have already looking at the entire thing from this. I want to cover the more of the fundamentals and all. I've tried to capture the demo in a recorded format, and I'll share you the code and everything, which you can try at your end and let me know if you have any questions. I can take that up offline. I'll try to visualize the entire demo based on 3 personas. So as I mentioned, one is the data engineers who's responsible for ingestion and cleaning. Second is the security, data stewards. And third is the entire analytics and ML guy, right? So this person, what is going to do, it's going to blueprint and simply ingest that data. The second one is centralized, gives the permission of it. And third, data analytics will be use the right tools or services which is required around it, right? So let's understand first what exactly is required in terms of the building the data lake from a data engineering perspective.
Hi, Sanchit. Sorry to barge in. I think your presentation slides are not visible.
Yeah, one second. Is my screen visible?
Yes, now it is. Thank you.
Awesome. Thanks for remembering. So now let's understand the steps to implement AWS lake formations. So we'll have three persona base. We just explore the three personas, right? Ingestion and cleansing, security, analytics, and ML. So we'll try to first look into how exactly the lake formation will work from a data engineering perspective. So you can register the data. What we'll do is we'll take an S3 as a storage layer. We'll register the bucket, have lake formation to create the entire S3 bucket, import the data from the source, and then you can have the direct access of that data. And then you can not only do that, but you will also have the blueprints, right? So blueprints are nothing but the repetitive methods. As I mentioned, lake formation makes it very easy from a repetitive standpoint. So if you want to repeat this, obviously, I mean, what you do is one-time load, historic load, right? Where you take all the data and any new data that keeps coming, which is the incremental thing. So lake formation will help you to support both the historic as well as incremental. From a demo perspective, I'll focus on the historic part of it. But again, there are very clear instructions are there on the console itself, which you can run this incremental also for your ongoing stuff. And from a log perspective, I think you can, these are the sources which you can take any of them when it comes to it, right? Any of the standard one which you can directly ingest. So for, it's not that mean that lake formation can only support these sources. These are available, I would say, without even writing the code. But again, if you have any specific, let's say some legacy warehouses like Teradata, Netezza, those kinds of stuff, right? Legacy databases, you can design your own blueprint also, and you can do it. So lake formation is very flexible. Either you can reuse what is provided by lake formation, or you can generate your own. So that's from that perspective. So do remember what's exactly the blueprint standpoint. Now we will go into the demo from a data engineering perspective. Who's responsible for ingestion of the data, cleansing it, and as well as cataloging the data. But before we really go into the demo, do remember there are a couple of things what we will also do in the demo, which is more fundamental, I would say. So this is what we will be doing. So first step, what we will be doing is we will be going ahead and we will be launching a cloud formation template, right? I just want to be sure that the entire demo, what we have, we focus purely on the functionalities rather than the basics. So this, what we'll first do is we'll launch the entire cloud formation template. Here we are providing the name of the cloud formation template, the different parameters. You don't need to change any of the parameters which comes with this, will be by default been there. And then select yes. This cloud formation template, and this is a repo, GitHub repo, where you can have the entire your code, right? So I will give the link of this repo in the chat after the session. So these are the different kinds of resources which will be spent by the entire cloud formation, and this is the schema of the RDS which will be the source for us. So this RDS data we will be capturing and putting it into the S3 bucket with help of the lake formation. This entire cloud formation will spin up all different resources. It will also spin up 3 different users and all, but it will take like around 25 to 20 minutes. I'll pause that and we'll start again once it is create complete. Now, if you see, we have the RDS endpoint which is acting as our source, and the other stuff. What I will do next here is we will log in into the EC2 instance. This EC2 instance is nothing but like a worker node where we will go log in into RDS and verify whether all my data has been successfully loaded or not into the RDS before I really go and start playing around with the lake formation. So I've provided the password and I will just simply list all the databases, all the tables. So you can see there is already a database there called as TPC. And now I'm using TPC and I will list all the databases in it, all the tables in it. Show tables. So you can see all the tables which I showed you in the GitHub README files are there. And now one second. Sorry, I think there's something was wrong with the video. Give me 1 second. Yeah. So now we can see, what we'll do is next is we'll go to the customer, any of the one of the table, and we'll try to list the table, list the records in that table. So we have done a select star from customer, and this ensures that we not only have the tables created, database created, but we have everything. Now, next, what I will do is we'll try to configure the entire stuff, right? We'll try to configure the lake formation. We have the data in place, so we'll try to configure the lake formation now. So for that, I will switch to the LF admin. So as I mentioned, we have created the entire 3 users here. So we'll switch to LF admin and try to create the lake formation. So admin is responsible for creating the lake formation as well as assigning all the permissions to it. So I'll create a lake formation. As you can see in the database, it is already created around it. So now I will create around the database here, which will be TPC, give the location of S3 where we have this entire data loaded. And what I'll say is I don't need IAM access, only use lake formation. Most of the time people make this mistake. So do ensure that you don't want 2 of them, only use lake formation permissions there. And next I will register the location of it. So first I deploy the lake formation. Now I will register the entire lake formation thing, the permission of the lake formation, right? For the glue and other services also. So this is done, which we have taken care of this. And now I will play around with the blueprint. So as you mentioned, right, blueprint is a templatized method for ingestion of the data. So what I'm doing here is I'm giving the glue connector, which will go to that MySQL database, which we just set up via CloudFormation, and ingest the data out of it and put it into S3 bucket. So the glue will be the one which will be taking care of it. And this is the frequency where you can run on demand, incremental, or in a schedule mode. So here we will be doing the entire glue workflow, and we are giving the IAM roles and other parameters. Now I will start the workflow. It's not started. I'll start the workflow, and this behind the scene, the blueprint has triggered the entire glue workflow, which will be doing all sorts of stuff. So if you see, by now, I've not done any coding. There's only CloudFormation which we have developed, but we have not developed any sorts of glue job, which is doing all sorts of activities. So which includes getting the data out, crawling the data, cleansing the data, and storing into S3 bucket. So this is what we have taken care so far, right? So this will start running now step by step, and you will see there's a green icon which will come. This workflow generally also takes like 5 to 6 minutes for it to finish around. So we'll wait for this one to finish, and you'll see like it'll just finish in couple of few more seconds. And this is doing the entire thing, right? So generally you have that staging, then you have this integration layer, and then you have the transform layer. This workflow is doing the same exact stuff. And now you can see the everything is completed successfully. And if you see that workflow also, the workflow will be successfully completed. So that's what we have done, right? So as a data engineer, we have set up the lake formation, ingest the data, and finish up the crawling and other kind of data. Now we'll go to the next part of the demo, which is more as a security engineer. So this is what we have already taken care, right? So this is what we have taken care as a blueprint, that we have defined the blueprint, perform the ingestion and all. Now we will do as a security guy. So as a security guy, what I will do, as I mentioned in the previous slide also, right? From a theory standpoint, there is already data catalog and access is defined. There will be data analyst who will be consuming via Athena or any different services. But if you remember in the lake formation configuration, I have set up something called as a permission, that you are not allowed to use IAM permissions. You have to use the lake formation permissions. So here we will be using the lake formation permission here. So security engineer will be responsible for doing that. Let's exactly understand how will the security person will be doing. So it will go first to the LF admin. And again, to remind, there are 3 personas I have created. This is the LF admin, where it will go and grant the permission to the other 2 users, the campaign managers or developers. So first I'm defining the permissions for the developer, like what different database, which different tables they can access, right? So I'm defining all sorts of permissions, which is, you can see that it's very easy. I can do it from the UI itself, and all sorts of, not just the tables, but what permissions on the tables. Like I'm just giving only the select permissions. This is for the LF campaign. Now we will define similarly for the other user also. So we'll go ahead and grant this for the second user. We'll repeat the same step. Now we'll go and we'll give the campaign. We'll do the same thing. We'll select the database. And this is all we are doing on the glue catalog database, right? Glue catalog database, glue catalog tables. And I'll give the permission to what they can do on the tables. This is as simple as what in lake formation, right? Otherwise, you have to go at 10 different places, set up IAM permissions, give it to S3 bucket, give it to glue, and those kinds of stuff, right? And this is how you have successfully granted around the permission to the glue thing. Now, next, what we will also be doing as the third step, right? If we go ahead, we will be doing querying around it. So now we have, so far, if I recap around it, I've ingest my data from my source SQL. I've put it into S3 bucket. I have the tables and other things set up. I have the security also defined. Next, I will do as is a analytics on top of it, which I will leverage Athena. So let's see how exactly Athena will work. So I will run 2 sets of queries, one which will fail, one which will pass. And this I will do for both the users. So you will see this entire thing on here on the right top will change. So currently I'm an LF developer. You will also see LF campaign. So this includes, I'll switch between 2 people, the console login, and we'll try to use that. So first I'll go to the Athena. I'll set up the things like the settings for the buckets and other thing, right? So it just stores the logs and other stuff. And now I will run the first query, where as a developer, I can only see 2 tables. And this is I've given in the lake formation. I will run this. I will get the output as expected. Right? I'm not worried about what queries I'm running, but whether I have the permission. Now I will run the second thing, which is just only on the web sales table. which also I should be able to run this as a count because I have the permission for the 2 tables. But I don't have the permission for running the third query. So I will run that queries. And again, all of these queries and everything are part of the entire code repository. I'll give the link in the chat before finishing the session. And here I get an error stating that you don't have the permission to run this. I have not done any sorts of IAM, any sorts of other thing. Now I'll switch this to LF campaign, which is the second user, and we'll repeat the same thing for the LF campaign. Since I have changed the user, which is nothing but the IAM user itself, I've logged in and changed it. I need to provide that again. I'll run the first query, which will work the same way. It will run executely fine because I do have the permissions and all, but I don't have the permission for the second table, which is web page. So when I start running this, it should give me an error that you don't have the permission. Yeah, you don't have the permission. Go and get the permission around it, or you cannot run operation on this table. This ensures that whatever the process I have done end to end, right from getting the data to S3 bucket with glue workflow, catalog and all, or as a data security guy, the securities I've applied to both the personas. And third, as an analytics, what I've done is successfully completed. And this entire thing, what we have done in couple of hours, I would say, this entire thing, what I've done, recorded in hours, not in weeks, not in months, right? That is the power of the lake formation, that it consolidates. The reason of showing this entire demo to you guys is that how easily you can break the data silos, ingest the data, and you can get the data out into S3 and query anything. This is what I've used Athena. You can also use any of this stuff. Now the cherry on cake is like what we have done, this is working fine for one account. But if you want to take this across 2 or 3 accounts, there are services in AWS which you can leverage, like cloud formations or the pipeline. We also leverage cloud formations, right? Which help you to take this to across accounts like dev, stage, UAT. That is data lake ops on AWS. So there are different operations what you need to handle, right? When it comes to data lake, multiple sources, structured, unstructured data, and several other services like the permissions and all the stuff, which can lake formation help you. But even how to automate that, or even things like infrastructure configuration, lake formation will help you to, I would say, not from the provisioning of the resources. Lake formation help you to configure those things, right? Tie up all those resources, tie all those dots. But there are still the requirement to create those dots, right? You need to have the Redshift cluster in place so you can integrate with the lake formation, or you need to have the entire glue job created so you can tie up with glue formation. So still you need DevOps to automate this part of the stuff, which is creating the resources. And last is the automation, how exactly you can blend DevOps and automation together to have your entire data lake stuff in place. So generally, this is how your entire data lakes looks like, right? In general, where you have source, your code repository, which you build, test, deploy, and you monitor. And then you have the entire code pipeline. I'm pretty sure most of the guys on this call will be aware about it, that this is how you will be doing in your software world. But this is how we can also take your same journey to the data lake side of it, right? And this is how your entire thing can look like how exactly you can set up your CI/CD for the data lake. Software part, most of the every person will be doing, right? How exactly it can be done. But this is how you can do for your data lake, where you have the source action, which has all of your code repository, like your SQL script, Python, Scala, your entire sorts of data lake and all. You have the entire same deploy action, test action, you can send approval, and then you can deploy the prod. So that is not a different, right? The whole reason of showing this is that most of the people think that you cannot have CI/CD for data lake, but that's the misconception. You can have that the same thing for data lake, how you can have a software. It's just that you have to fine tune some of the things which is required at your end. And last thing from my side will be how exactly the couple of stuff. This are pretty sure you're doing the same thing for your software. Create different folders, like how you have for component wise, like Redshift, Glue, Athena, Lambda, Kinesis. create different folders and have the common files outside for it. Ensure that you have test scripts, whichever, like you do for your software or application development or DevOps side of the stuff, right? Do have the test scripts not only for testing this entire automation, but even for curating or data population, right? Whether you have loaded the data successfully or not. Ensure that infrastructure is immutable wherever it's feasible. Immutable is that, okay, you can redeploy it and which will change the infrastructure. Last, you can also use code build maybe instead of code deploy to run the scripts, right? In case of data analytics, it is very important that it's code build. You cannot go, but like most of these services, what you have leveraged like Glue, Redshift, or except EMR, they are managed services, so you cannot run code deploy on that. So leverage code build rather than code deploy. That's a small change, I would say, compared to application. But with this best practices, you can leverage, or with best practices of fine tuning, you can leverage a CI/CD pipeline for data lake, and with help of lake formation, you can not only build your entire data lake in, I would say, couple of days, but with help of CI/CD, you can also accelerate your journey to go to the production very fast. So that's about from my session. I hope you like it. I'll share the GitHub link in the chat after the session. But yeah, if you have any questions, any suggestions, please do let me know. Thank you.
Thank you very much, Sanjit, for your session. So since the morning we'll be talking about serverless and security stuff. So you took us into a whole different area with this data lake demo and your presentation. And I would like to especially thank you for the support you gave from the beginning we started organizing this program. So hope to work with you in future sessions as well, Sanjit. So guys, if you have any questions, you can directly contact Sanjit as he mentioned using LinkedIn and other channels. So Shantit, once again, thank you very much for joining with us and sharing your knowledge with us.
Awesome. Thank you so much and have a guys wonderful session. I know tomorrow there's a workshop, so please do join the workshop and enjoy the workshop. Thank you.
You too. Bye. Okay, guys. So now it's time for the third and final quiz of the day. And so far we have conducted 2 quizzes and we have 2 winners. And when talking about the overall leaderboard, we have Vinaya Prashant at the first place. And following him, Imanta, Yasit Samaravikrama, Mohammad Mughis, Sachi Bhagya, Yasant Hednayaka, Dureksha Vasala, Krishan Shamot, Karana Vijayanayaka, Sindhujan Nirmalan, and those guys are the top 10 of the overall tournament so far. So without further ado, I will start our third and final quiz for the day. So let's see how things goes. Okay, guys, now you should see the first question of the quiz. So we are seeing few familiar names once again in the top of the leaderboard. Vinaya Prashant, Nirmalan, Yasit Samar Vikram. So now we are into the fifth question of the final quiz, and we have Vinay Prashant on the first place and Imanta in the third place. So these two are the guys sharing the first and second places in the overall tournament so far. Okay, now we are into the final two quizzes of our AWS Community Day. Okay, guys, so this is the final question. Let's see how the leaderboard shape up after this question. So will we have a new winner for this quiz, or we will have a repeated winner? Okay, guys, so that's marked the end of our final and third quiz for the our AWS Community Day Sri Lanka. And I think we have a new winner for the final quiz. And it would be Aishwarya Sood. So congratulations for you, and our team will contact you through the email you provided for the registration, and continue with the gift you will receive in the meantime. So final results for the tournament will be announced during the wrapping up session around 5 p.m. So please stay joined with us for the announcement, and during that session we will also announce the winners of the referral contest. So that's marked the end of our third and final session. So next up we have another interesting session coming up about the Lahir, over to you. You can start.
No worries. Thank you very much, Amir. And a big congratulations to all the winners. So we've reached the last session for the day. Now, to deliver this session, we have another serverless, AWS serverless hero who has his own podcast. That's a first, right? For today. Now, if that wasn't admirable enough, he goes above and beyond to create a newsletter that talks about AWS, serverless, and all about architectures. So let's welcome Joan Zachariah to take us through building serverless workloads with minimal code and much more. So let me add you to the stream, Zach. Welcome.
Hey,
How are you doing
Lahir.
today?
Doing good. How are you doing?
Very well. We've had a very interesting session, or bunch of sessions today. Hoping that you can finish this day and provide some interesting facts about your topic and what you're supposed to do. What you bring into the table, right? Right.
Awesome. Thanks, Lahiro. Yeah.
Over to you, Zach.
Thank you. So we heard a lot about serverless today in terms of DynamoDB, Lambda functions. Even Sanchit was speaking about data lakes, all of these things, where you had to write a lot of code. So today, I'm going to tell you, okay, you can even do a lot of workloads on serverless with minimal code. And before we get started, a little about me. I'm June Zachariah Noel. I go by the internet name Zach Jones Noel. And I'm a senior developer advocate at Freshworks, recently recognized as AWS Serverless Hero. And I co-organize AWS User Group Bangalore in India. And also, I come from this background of serverless architecture where I've built a lot of apps using serverless architectures on AWS. You can connect with me with the QR code that's there on the slide. You can scan it, connect with me on different social media networks. I'm happy to chat about everything serverless. So today, we will look into what are the current workloads that we run on serverless, and how does direct integrations help us to go from a heavy Lambda function-based serverless workload into a minimal infrastructure-based code so that you can easily manage your applications. And it's just with infrastructure, so it's easy to deploy over different instances of AWS as well. So yes, we were talking about serverless, and today was a lot of serverless sessions. I was super excited to be part and listening to the amazing speakers that we had. But as we see today, a lot of enterprises and a lot of startups are starting to build serverless-based products. Why serverless? Because everyone is going to the fact that it's easily scalable, it's easily available, and you don't have to go through the hassle of managing things. So all things said, the serverless is the road to go to, and you're having a lot of things that's running on serverless. And the very fact from the reInvent that we see that announcements about different services, different new features with the existing services that's helping you build better with serverless, right? So it's super awesome. And looking into the present day workloads, we were looking at workloads such as where you want to build some batch processing, or you want to have some scheduled tasks. Say like you want to have a cron job, and every Monday morning at 9 a.m. you want to send out an email or something like that, where you could use a lot of these AWS services on serverless, and you could design your own architecture. You can orchestrate or choreograph your architectures so that the whole sequence of event flow between different services is maintained. And be it with mobile or web applications, you can build powerful backend systems on serverless with different things like DynamoDB or Lambda functions, step functions. All of these things help you to power your serverless workloads on AWS. You can build a lot of chatbots with Lex, which also integrates with different things like Lambda function, DynamoDB, where it's easy to work with different other services all through a chat. IoT systems, yes, you could build amazing IoT systems which can send or stream data into your Kinesis, or it could be to your Lambda functions or various other things. So it's not the limit, but it's limitless. And the very fact about having different microservices-based architectures, you could have a lot of microservices distributed across multiple services. You could have a purely serverless microservice, or you could even have something that's hybrid. You could be using containers, you could be using EC2 instances. Yes, I like EC2 instances. So all of these things can be easily managed with serverless, where you can have different API gateways or step functions or event bridge. All of this helps you to orchestrate and choreograph your complete architectures. So using these kind of services can help you
to design systems that's powerful, scalable, and always available. So when you're thinking about serverless, the very fact that everybody thinks about, hey, it's Lambda functions. Well, there's a lot more to serverless on AWS. It's not just Lambda functions. Yes, Lambda functions the beginning, but there's more to it. And what if I say to you that, hey, you don't need a Lambda function at times when you have a workload, and it could be without a Lambda function as well. So all of it is an amazing way to build your applications. So yes, when I was telling low code, I am meaning that it's a low application code. So yeah, like I was just mentioning, that you don't have to always have a Lambda function that's importing some packages like Boto3 on Python, or importing AWS SDKs, and doing a lot of API action calls from your Lambda function. Instead, what you could do is you could use different integration patterns, where you could have endpoints from the service itself talk to a specific service. That's what the whole session is about today. So I'm just making the reference here. A big Marvel fan, so I'll try to include Captain America. Coming to serverless patterns, I was speaking about choreography, orchestration, direct integration. All these words have been repeatedly using. So what does these mean, right? Coming to orchestration, when you think about orchestration, you think about a master or somebody who's telling, hey, first the bass, then the trumpets. Similarly, on AWS, you have a service for orchestration, that's step function, that's saying, hey, first this task, and then you go to the next, or you have to branch. All of it is available. The orchestration is one of the integration patterns that we have, where you could have things where it's flowing to step functions, and step function takes care about your complete workload, and it says it completely executes and then returns back you the response. So how amazing is that? Choreography. So when you're working in a choreography based architecture, what you would have to do is you would have to design it such a way that your systems know what they are intended to do. So it could be a choreography between multiple microservices, or it could be Lambda functions alone, or it could even be things like, hey, I have an event coming to my event bridge, and that should go into SNS topic, or it should go to SQS. All of this could be easily choreographed and designed with just a couple of rules on event bridge. So all of it, you don't even have to write a Lambda code. Uh, just by the saying that you can define them in your infrastructure, be it as a template, YAML template, or the CA function, where you can define all of these things as different snippets of your architecture itself or infrastructure itself. And this will ensure that the event is being transposed from the source, from the producer to the consumer. So this is amazing how we work with different serverless patterns, where you have orchestration of workflows and choreography of workflows. It's always a question like, okay, which do I use and when do I use? The simplest answer for that is you could use hybrid, just for the fact that you could make use of both the integration patterns, where you have something like you have an event coming into your event bridge, it sends it to step functions, step function does some processing and posts it back into event bridge, and it takes it and process it for the next steps. So it's so simple to design these systems that you don't have to write huge Lambda codes or huge application code. When you're trying to build all of these, that's where direct integrations come into picture. So why direct integrations? Of course, the very fact about Lambda functions is cold starts. I'm happy to know that there's an announcement about cold start being addressed in Java with the reinvent announcement, and I'm super happy that it's been addressed. So when you're doing direct integrations, you wouldn't have to write Lambda code. And when you're not writing Lambda function code, you don't have to worry about the cold starts that it holds. So when you're building all of these, there's no Lambda function. There's a direct integration happening between different services, and all of these ensures that there's no cold start. So it's faster in terms of execution. You don't have latency. It's also available always. And when you're working with it, going with the responsibility model, all of these services, it's a responsibility being shared by the AWS side or the cloud provider side, where the scalability, availability is maintained by them, and we would have to only focus on application code. And here there's application code literally means your code of your infrastructure. So infrastructure as code has always helped in terms of ensuring that you don't have to build huge code bases. And these code bases could be defined with your own infrastructure as code. I'll also be walking you through the snippet of code where my old application into the session where I'll be showing you how these things are being defined on a SAM template. And it's all a couple of, it's about 100 lines of code. And if you had to do the same thing, it would be a lot more things. So going with the very fact that direct integrations can help you in a lot of terms, it is a direct integration with the service itself. So you have end-to-end integration. So for example, it could be step functions, you're using direct integrations, or it could be on different other services that I'll be speaking about. So some of the serverless services that work with direct integrations are step functions, Event Bridge, AppSync, and API Gateway. All of these have been adding as common entry point into our architecture executions, right? Where we've had step functions for orchestration, Event Bridge for choreography, AppSync and API Gateway for endpoints which can be triggered from external systems. So you have a mobile application or an IoT application. All of these can be interfaced with AppSync or API Gateway, which can help as entry points for your events and entry points for triggers that will start the execution of your step function or post events into your event bridge. All of this, again, there's no Lambda function and there's no application code. So looking first into step functions. Step functions announced last year before the reInvent. They announced about 200 plus API actions being supported with direct integrations, and the support has been growing since then. So today we have over 300 plus. I don't have an actual count, but it's over 300 API actions that's been supported across multiple AWS services. So you could have I've added a simple, I call it simple. So it's a simple user sign up workflow that I have, which is a state machine diagram that I've added. So you can see that when a user sign up happens, in a regular scenario, you have a application, you have a SaaS product, you have user sign up being done on the go, and what are the different things that happens, right? You may have to work with writing it into the database. You may have to create users. You may have to post some events on some external systems. You may have multiple things like you would have to depend on an external system to update, or it could be a payment gateway as well, where it has to wait for the payment is done. And once the payment is done, it has to get back into the execution. All of these things can be triggered using step functions. We can be orchestrated using step functions. So what you see here is a user sign up where whenever the user sign up happens, there is a DynamoDB put, cognitive user creation, and also some events being posted into an event bus or an event bridge. So all of it is happening parallelly. And since it's happening parallelly, once all of this is done, you would have to wait for a certain time. And I'm trying to invoke an API gateway endpoint so that the event from my event bridge is being posted to an external system, which updates, and I'm using the same API to check if the update has been done or not. So once the API execution is done, you have a choice to check if it is successful or it's failed. If it is failed, I'm just posting it to SNS to publish a message out telling, hey, something went wrong and the sign-up didn't succeed. Or if it is successful, I have another database that's on RDS, and I'm trying to execute certain SQL commands on RDS. I'm doing that from step functions itself, And once that is done, I get some objects, I retrieve it, and then I update DynamoDB. All of these, if you imagine this in a Lambda function, it would be a very long code. And probably you would have to use multiple Lambda functions invoking each other so that you're trying to go with minimal code on Lambda functions, saying, okay, my Lambda function should be focused with a specific need only, and I want to do like, okay, I want to do Dynamo operations on a specific Lambda function, or I want to do RDS-based functions on a specific Lambda function. All of it could be on different Lambda functions, and you'll be invoking each of them. With step functions, you don't have those hassles of creating so many Lambda functions, maintaining them, updating all of those codes. And say, for example, if you have to update certain SDK attributes, you would have to go and update in one place and you miss it in the other place, it still errors up and you have to handle all the error conditions. With step functions, you could easily do it with SDK integrations. So SDK integrations supports over 300 plus API endpoints. So basically what your Lambda can do, your step function can also do. Maybe there are some services that's not yet supported, but maybe into the future it's supported. So it's still amazing how you could build a huge workflow on with a state machine on step functions. Imagine the same step functions as a whole, right? I've added here for representation of how the whole workflow would look like, but you could even go breaking it down into smaller state machines so that you have, instead of doing the API invoke, you're getting it from EventBridge, from the external system. And once the external system posts that event to EventBridge, you take the event and start the execution of your step function. All this is possible, making things more lighter and faster to execute. You wouldn't have to go through, okay, I have a state machine execution going on, I have to wait until the response is done. All these things could be avoided. So ultimately making it more easier for developers to write huge workflows on step functions. Coming to the next thing, EventBridge. Amazon EventBridge is an amazing way where it acts as a event bus where producers can post their events onto the bus, and from the bus, it has different event rules that could be resolved for different destinations. So I've added a couple of them here. It could be Lambda functions, it could be step function, or it could even post it to another event bus, or things like this could be done with EventBridge, where you have rules that are being defined, and there could be multiple rules on your event bus, and this could route events to different destinations based on the nature of the event. So say, for example, I have an event coming in from S3, and if it's a put object on S3, I wanted to invoke a Lambda function. If it is a put ACL on S3, I want to post it to an SNS topic. So all of this smart routing with event filters is possible, where it enables you to have choreograph the whole architecture in such a way that you're defining from where the event is coming and where it should go, and based on all of these is what your event filters are based out of. The very fact about EventBridge supporting API destinations make it so easy for you to say, okay, I want to invoke a specific API endpoint, but for me, if I have to do it, I would have to define the API endpoint from a Lambda function. I have to use different things like HTTP-based packages or things to invoke these. Instead, what you could do is define them as API destinations on EventBridge. And the very fact that you could even transpose or translate the whole thing into a payload that you wish is so powerful on EventBridge that you could say, okay, I am getting this event in a different JSON structure. I want to translate it and transform it into a specific JSON structure, and I could do that. And once it is done, the way the API destination needs it, it could be defined, and all this API happens with the secrets being stored on secrets manager, so you can be sure that, okay, my API credentials are not being leaked, or all of these things will be taken care of. The other amazing thing about EventBridge is that it supports SaaS-based integrations. And when I think SaaS-based integrations, there are a lot of, I guess, 20 odd even SaaS partners who support these on EventBridge, where any events on the SaaS product, they'll post it into your event bus on your AWS account, and from there you could take it and process it. And when you're processing all of this, you could return back to the same SaaS account, SaaS product, telling that, hey, it's an API destination, and I can post the events back, or you want to update certain things on the SaaS product end, you could do it with API destination. So imagine you have some system where, for example, you have a Freshworks Freshdesk ticket that's been generated on Freshdesk. It posts the event onto EventBridge, and once it's there on EventBridge, it takes it up. It could do a lot of things, like I want to do a sentiment analysis on this specific ticket and define what the priority is based on the sentiment of the ticket description. So all of this could be done, and with API destination, you're posting things back into EventBridge and say, hey, this is of a priority 1 or priority 2, and high priority or low priority, and set it back with API destinations. So the integration with different ways in terms of, even though it's not in the AWS ecosystem, it is in the SaaS product. So you can easily integrate is an amazing way where application developers, when working with a lot of SaaS products, like it could be GitHub, or it could be Stripe or Freshworks, a lot of other things, it's easy to build applications where you're talking multiple systems and still ensuring that you're in the AWS ecosystem. And when you're doing all of these things, the idea behind that is that you don't have to actually write, again, no long codes of application. The other, like I was just mentioning about API gateway endpoints, when API gateway was introduced, and a lot of these, the very first use case that it came into existence was invoking a Lambda function. So since then, serverless web backends has been improved a lot, and today I've seen, or I've even architected a couple of systems where you're taking API gateway endpoints and directly integrating with different services like DynamoDB or Kinesis or other things, where all of this integration is being done with VTL. VTL is nothing but Velocity Template Language, which defines or helps you to transpose your request responses to a payload that the specific AWS service needs, so that you're formatting the data in a specific way and sending it out. So when you're working with, say, for example, you have a basic API endpoints, and you're doing some CRUD operations, and all your data is being stored on DynamoDB, the traditional way of going or approaching this is that, okay, I have a Lambda function, I'll use the DynamoDB SDK, and I'll start doing query and scan or put items, all of these actions from my Lambda function. Well, the same thing could be done from your AWS API gateway endpoints. So when you're trying to configure these, you just have to say, okay, which service and what is the VTL resolver for that, and define these things. So all of these data wouldn't even be going through a Lambda function. It's saying, okay, I have my API gateway, and it's directly integrated with DynamoDB. And it goes, and the query operation on DynamoDB gets back the data and returns it back to the invoking side. So API gateway acts as a middleware where it helps you to directly integrate with services like a lot of services, and in this case, DynamoDB, where it tells, okay, what are the type of actions that you would have to do and how you would want to do. All of this can be defined on API gateway. So if you design your API endpoints smartly, if it is a very simple CRUD operation, or just a read and write, and those kind of operations on your databases or Kinesis or things like that, I would always suggest, okay, go with API gateway, because it's easier, and you could even have your request models, all of these being there so that you could even validate things. So even before the very fact that the request models came into action, what we would have to do is we had to validate if the attributes are coming in the right way or not. All of these things require a Lambda function. But now you can define your own models, and the models can define, say, hey, I'm getting this value. It's not of type string, and API gateway itself will throw an error out to the invoking side telling that, hey, the data is not right. So this could be formatted in the way that we need, and ensuring that you have the right validations in place. And also, you can do direct integrations with different services. So the next thing is AppSync. AppSync is again, AWS AppSync is again API exposure where it uses GraphQL-based APIs on AWS with a serverless offering. So when you're doing a lot of these front-end applications, web or mobile applications, using GraphQL-based APIs is really good because it makes the life of a front-end developer easier because they know what they're integrating with. The schema is defined. You request only what you need. All of that is an amazing plus point over API gateways. The other thing is that AppSync can also integrate with different other services. So your ideal approach, again, resolvers for your API endpoints. In case of AppSync, it would be different queries, mutations, or subscription. The resolvers for these was traditionally Lambda functions, where you had to define what that specific operation does and return back the response. And when you're returning back the response, you had to ensure that, okay, hey, the schema is this, and I need to match the schema when I'm returning the response. Otherwise, the response doesn't pass to the invoker. With AppSync and direct integrations, what you could do is you could have direct integrations again with DynamoDB or RDS, or you could even have HTTP-based endpoints that can directly be integrated from AppSync. So if you want to do an API call for your front-end applications, it's again a query or a mutation that's being done, and those queries or mutations is going to be resolved into an API action. And from AppSync itself, using VTL, and you'll be calling the HTTP endpoint, getting back the response, and returning that back to the front. So all of this can help you build smarter systems where you wouldn't have to. The very fact that I'm speaking a lot about how direct integration helps is that often at times when you're building real-time systems or building subsystems which are dependent on certain things like is data updated, or if there's a data change, a subscription back into content, all of this could be easily managed with AppSync. And when this is happening, when you're using different things like Amplify or AWS Amplify for your infrastructure, so this can help you define your models in such a way where you can just say, hey, this is a model, this is a structure, this is a schema of the model, and it will even create your different CRUD operations. So that will generate your queries, mutations, and subscription if there's any. So all of these can be easily created. Also, when you're creating these resolvers, you can define from what are the different data sources that resolvers here speak to a different data source in AppSync. So when this is being done, you can say, okay, it speaks to my RDS instance, and I don't have to create a Lambda function, ensure that, okay, it's in the same VPC, ensure that the proxy is maintained, database proxies are maintained. All of this, you don't have to manage or worry about when you're trying to do direct integrations. So going into a demo application that I have. So I spoke about orchestration and choreography. So I'm trying to do a hybrid of both these integration patterns with direct integration so that you could do a serverless workflow without a Lambda function, and even without even a single code where you have to write some huge functions or huge resolvers, all of these things. It's all maintained in your infrastructure itself. And I'm using step function, so state machine. So here, again, a Marvel fan. So what you can see here is Bruce Banner trying to see whoever has survived the blip. So when he goes through, he sees different folks, different Avengers or different team members. He sees their photo, and below them, he sees their name. So you can see that I've even highlighted Scott Lang's name, and this is a amazing technology where you could recognize people's faces and say, hey, this person is this. And imagine a world where you live with in such a way, in such a technology where there's a real-time name prompting where you imagine you're at a conference, and the one hassle that I deal with is I don't remember names. So imagine I have this technology, I don't have to remember his enemy's name, and I'll get this, hey, this person is Scotland, and I can easily go and say, hey, Scotland. So I'm trying to build this kind of a system where, of course, to train this model, I need to build a huge ML model, all of these things. So I'm using only celebrities at the moment. So my architecture looks like this, where whenever there's a picture upload into my S3, the put object triggers an event into my event bus. So my event bus will say, hey, if the source is from S3 and if it's a put object, invoke my state machine invocation. So it defines these things. You can see the very fact that I'm trying to do choreography and orchestration. All of this code is available on GitHub. So you can scan this QR code, and it takes you to the GitHub repository, and you can even clone it, deploy it into your own AWS account using SAM, and test this out. So what I've done in the step functions is that I've used direct integrations with different things like Amazon Recognition, DynamoDB. So what it does first is that it invokes recognize celebrities API action on Amazon Recognition, uses the image as a source, finds who are the celebrities in that image, returns back a JSON array, and using that JSON array, I'm looping through them and storing them on my DynamoDB. When this has been done, I'm using the intrinsic functions that was recently added, like the UUID part of it, where it generates a new UUID, or array-based functions, or string manipulations, because DynamoDB expects all the values to be as a string. The confidence level that recognition returns is in a float, and I would have to so I would have to do the parsing into a string, all of it. So what I could do is, with the intrinsic function, I could just format it in a string way and send it into DynamoDB. So you can see that this is the first state where I'm using S3 object, which holds the bucket name and name of the key itself that's been coming from the event. And S3 gets this event whenever there's S3 put, it sends this values as events into my event bridge, and event bridge sends it into my state machine. So all this values directly from S3, that you're getting these values, trying to send these values as parameters into recognize celebrities, and it recognizes celebrities and returns back the response. So you can see that there's three aspects, three screenshots that I've added. One is the state machine itself. The other is the integration that I'm doing with the SDK, and this is a form-based integration where I can edit the attributes or API parameters that it needs, and it generates this JSON value that is part of the state machine. The next is the DynamoDB put, where again I'm using SDK-based integration, using different different intrinsic functions, and defining my complete payload, how DynamoDB requires in an unmarshaled way, and sending it through. So, and it also generates the state machine equivalent JSON structure. into the demo. So what I'll be doing now is that I'll upload an image to my S3, and once that is done, okay, it's uploaded, and this is my state machine. It started the execution. You can see that the execution hold did get certain values as input with respect to the detail, telling what is the object details, the key, the bucket name. All of this is available in the event that I was just mentioning, and it generates the response as well with different celebrities that it found. So this is a long JSON array that is being generated, and you can see that there's been 9 celebrities that have been identified, and I could just go here. There's Robert Downey Jr., Chris Evans, Hemsworth, Scarlett Johansson. So you can see that it identified a lot of these celebrities, came as an array using map as a state. I'm looping through each of these iterations so that I could write them on DynamoDB. And once DynamoDB put has been done, it successfully ends the execution and ends the whole execution part of it. What if I told you that all of this, what architecture that I showed you, didn't have a single Lambda function? That would be amazing, right? So I'll just walk you through the code. You can see that there's a template YAML. Okay, so there's template YAML, and in this template, I'm defining different resources like my S3 bucket. I'm even defining a custom IAM policy, my state machine. So all what I did was I designed my complete state machine on the Workflow Studio, generated the JSON, and added the JSON into my code, and I'm just using that as a destination URI in my infrastructure as code. The other things that I'm using is, since this holds a DynamoDB, I'm defining my DynamoDB in my infrastructure as code and sending it as definition substitution into my ASL. And also the different policies that I hold. Here is the part where I define, telling that, hey, this state machine should be invoked whenever there's a event. And what is that event? Is that I'm defining a specific event bridge rule, telling that, okay, if the source is S3 and the detail type is object created, on the specific S3 bucket that my infrastructure as code has been generating it. So all of these things as my event input, and what's the source and how is the source being defined, all these details. This will ensure that, okay, my event bridge rule will say, will check for these event rules, and based on these rules, it invokes the state machine execution. So say, for example, if I do a delete, it doesn't trigger my state machine at all, so that the execution doesn't happen. And you can define, okay, hey, it only happens on an object creation. I'm defining my DynamoDB table. I have another state machine just to get all the items from DynamoDB. And I'm just doing some outputs. You can see that the whole of this thing as infrastructure was only 116 lines of code. And this complete thing didn't have a Lambda function. Instead, it had a state machine definition, which I was just walking you through in terms of different states, like recognize celebrities and the map state to process each of those items, and then put it into DynamoDB, and then it just returns these parameters. So again, my state machine is also about 60 lines of code, and infrastructure about 110 or 116 lines of code. So the complete workflow itself was minimized into a very low code and focused on the infrastructure itself. So you don't have to, ideally go, okay, I want to do some changes in my application, I want to maintain them, you can just go update your infrastructure as code and also update your state machine, deploy them over your cloud, and you're done. So, and the very fact that you could use infrastructure as code bases into your build pipelines and also enable them as CI/CD workflows. So, hey, I want to build these, post it into my development account, and then test for a couple of things, and then post it and then deploy them into my production account. So all of this again could be done with simple infrastructure as code as this. And SAM, I'm using SAM here, which is a serverless application model. And this also supports pipelines where you could define a pipeline with different GitHub actions or code pipelines, all of these, and ensure that your execution of your pipelines are there. So that's about the session. And with that, I conclude it. So I have all of this infrastructure as code is available on my GitHub. The link that I was sharing, the QR code that I was sharing earlier is available on GitHub. I'll also share them over the message now. And I've written different blogs on Dev2 about different architectures using step functions and a lot more things. So you could check those blogs out on my Dev2 handles, Zach Jones Noel, and you can connect with me on LinkedIn and Twitter. You can chat with me about a lot of things serverless. So that's about it. And thank you.
Thank you, Jones, for that exciting session. I think it truly ended with a bang for us today. So thank you again. So guys, if you have any questions, you can ask Zach, or we can wind up for the day. Seems like there's not a lot of questions, but guys, like as Jones told, like you could just reach out to him and ask things you want. He's pretty friendly to reach, and I'm sure he'll be happy to help you guys out. So thank you again so much, Jones. You were our last speaker today, and we're so happy to have you on board. And we hope to work with you in the future as well. So it was great to have you on board.
Thank you, Keshav. Thank you for having me. Thank you.
Yes, no worries. All right then, guys. I think that's about it. So as the last thing for today, we are going to before we wrap things up, I have to first mention the quiz winners for today. So we have two sets of winners. So for the actual quiz winner and the tournament winner, as well as the referral contest winners. So the quiz winners are, first of all, for the quiz 1, the winner is Yasit Samaravikrama. And for quiz 2, it's Dureksha Vasala. And quiz 3, it's Aishwarya Sood. And the overall tournament winner is Vinay Prashant. Hopefully I pronounced all of you guys' names correctly. So thank you so much for participating in this quiz, guys, and so congratulations. I think you guys did a really great job answering all the questions. So we will we have the emails you guys provided when you guys registered. So we will reach out to you guys soon within the next few days regarding how we can send the gifts and things like that. So do keep an eye out in your emails. So we will reach out to you soon. And as for the referral contest, we have Venura Mendis in the first place, and then we have Mohammad Nizad, and then we have Suja. So we have the emails of these guys as well. So we will be reaching out to them within the next few days, and we'll try to send out the gifts. So congratulations for the referral contest winners as well. Thank you for pulling a lot of registrations for our event. So that was a really great thing you guys did. So yeah, those were the winners. Congratulations again, and we will, as I said, we will contact you guys soon, and looking forward for you to send out the gifts as well. All right then. So as the last thing for today, I'll just give a small vote of thanks. So it has been such an honor to be a part of this event, and I'm really proud of the team to get these things to make this event a success and to get it done. So first of all, on behalf of AWS User Group Colombo, I would like to thank all of our speakers, Derek, Alex, Lakindu, Lahiru, Geetika, Arshad, Yan, Sanchit, and finally Jones. So I think we couldn't have done this event successfully without you guys. You guys gave a lot of support on the event day and even before the event day leading up to today. So a heartfelt thank you for all of you guys for the bottom of our hearts, and we hope to do more sessions with you guys in the future as well. So thank you again for all the support given and for the amazing sessions today. I think we truly learned a lot today. Next, we will also like to thank the Confab team because those guys helped us with the registration as well as the quiz. So to name a few, Ganesh, Shefali, and Harikaran, these guys helped a lot during the past few months to get the registration and quizzes done. So thanks again, guys. And I will also finally, I will also like to thank the rest of our team members. So Manoj, Chamira, Trehana, Lakindu, and Lahiru. So they have been putting in a lot of unwavering efforts and continued support to make this event a success. So I'm really proud of what we achieved today. So thanks again, guys. And last but not the least, heartfelt thank to all the audience. Thank you for sticking out until the end and showing up for the entire day, even though it's a working day. And even though it's in December, we are really glad that you guys showed up. And we really hope you guys learned something new and you had fun while doing it. Yeah, and so thank you so much for joining. Thank you for still sticking out. And once again, congratulations to all the quiz winners. As I said, we will contact you guys soon through your emails that you registered with to move forward about the gifts and stuff. So that's it, guys. That's our event. Thank you so much for joining. Do give us a follow on Facebook, Twitter, LinkedIn, and in our meetup page. We will be doing our monthly meetups and exciting events as always. So we will have a lot more speakers coming in, and yeah, our plan is to keep growing this community and keep giving back to the community as we learn together. So thank you again. So we hope to see you in the future meetups, and yeah, it was a great day, and thanks everyone for making it a success. See you guys.